Check, check. Well, that was check. Oh, mute. That was exciting. It's the joys of using 30 seconds. In the previous years, I've brought in like a full camera and tripod, and it's a lot to like put in a suitcase across the Atlantic Ocean. And Flock last year, the AV company just used GoPros, and I'm like, I have a GoPro. That's so much easier. But anyway, hi, welcome to day two, everybody. I want to start off by thanking our sponsors. They help us put on this event, help us make this into a two-day event with the meetups yesterday. So thanks to Alma Linux, Rocky Linux, Red Hat, Meta, and Fedora for sponsoring this event. All of our sessions today will be here in this room. We do have these other meeting rooms available and the whole hallway space out there. You're welcome to have conversations and whatever. The Birch room, which is all the way that way, is for speakers and staff only, but otherwise all the rooms are available. We do have during lunch one lunch and learn session that František will be giving. That's in Buckeye 1, I think. If anybody wants to put together an impromptu lunch and learn session in Buckeye 2 or Elm, you're welcome to do so. If you let me know, I'll make an announcement about it or something, right? If you just want to have some sort of session during lunch. You're not plan to eat and have conversations, right? Not like give a presentation, because you should nourish yourself. So speakers, you have 25 minutes unless you have a 40-minute slot. I have a timekeeping device here that I sometimes remember to set for you. I just put down this tape on the floor. If you're speaking, the angle of my GoPro here, if you're here, you are not in the live stream and the recording. Generally, during your talk, it's okay. Most of the time, the live stream is actually showing your slides and not this, but like during your Q&A, I do have the camera on you. If there's questions from the audience, please use a mic. We have a mic that roams around. Or like if someone shouts something out that's cool just as a speaker, please repeat the question just so it shows up in the mic or in the stream and in the recording. The camera is here, as I said, and so when I introduce you as a speaker, if you start speaking immediately, the beginning of your recording that lives forever on YouTube will be me walking into a camera, and that's not great for, like, I don't know, your video. So just give me a second to get past the camera. And if you all, like, clap for the speaker after I introduce them, then that'll help them remember. I think it's everything. Oh, we have the Fedora badges out and about. If you do Fedora badges, there's QR codes out there in the hallway track you can use. And just a reminder that we are all here to have a good time and also to be, to learn and to collaborate on stuff, and that we want to follow the code of conduct and be good to each other to make this a good, welcoming place for everybody. I think that's everything that I need to tell you. Oh, the waffle party tonight, I will have the details up. You should have an email if you registered ahead of time. Otherwise, I will have the details up during the closing session. But that'll be at 8:30, so go have dinner on your own and then join us for waffles and drinks. So with that, I will introduce our first speaker of the morning, which is Fabian Erutin, who is the floor sweeper at CentOS, and he'll be talking to us about the CentOS infrastructure.
Welcome all survivors of the first CentOS Connect days, and let's get a second day as good as the first one. So we'll go really smoothly this morning, so nothing too technical, so that we can take easy. I hope that you are all caffeinated enough and that you can recover from whatever you were doing yesterday. I don't want to know. So the first mandatory slide is who am I, for people not knowing me yet. I started to contribute to CentOS, I think 17 or 18 years ago. And yes, Sean was right. I was floor sweeper, but I was promoted to all these new titles. I just added another one to the list, which is we are in 2025, so I have to use one AI word in the slides. Here we go. So Apart from that, I'm touching a little bit of infra. I'm a sysadmin by choice, meaning I really appreciate and I love what I do. And if you're a sysadmin, you should be proud of yourself. So this is the agenda for today. It's just a small review of what we did as the infrastructure SIG for CentOS project and the special interest group. What is a small roadmap of what we will be doing in 2025, because of course we'll have new things coming on our plate automatically, but what we are already aware of, and Q&A section eventually at the end. So just a small reminder first. The InfraSig is a special interest group in CentOS because, in fact, well, we are needed everywhere. Whatever the SIGs you are contributing to, you still need to rely on infrastructure at one point or another, meaning that, and I was entering some meetups room yesterday, and I've always something to do for them. Yesterday in the OKD the meetup, we discussed about new infra needs, and we'll work on that later this year. But the InfraSig is mainly there for two big things. Meaning that we have two hats that I have to wear at the same time. The biggest one at the moment is, of course, working on the CentOS Stream infrastructure, which I will not touch today because I will more discuss about the public thing that you are contributing and you are relying on. But CentOS Stream infra is also something that the InfraSig needs to care about, even if that's semi-internal to Red Hat. But for you, for the people from the community, or contributing to one SIG or another, or just using the artifact built by the special interest group, well, we need to support the CBS codable system and everything after that. So we have our own CI infra that you can abuse for free. So what we call Duffy API services. If you are a member of a SIG, if you don't know what Duffy is, talk to me after, because it's a way to just get ephemeral machine from AWS sponsored directly for you for your test, and then even bare metal machine. We have also an OpenShift setup that we need to maintain for you in case you need a namespace in that OpenShift cluster, hosted for free. So ask for your namespace and your project there. We also need to take care of everything after the deliverable, so just the mirror network and the various CDN that we need to maintain for that. And well, the website, the mailing list, so all the classical things that you expect a project, an open source project to have these days. But let's go back first to some fundamentals and basics. I guess that a lot of people have seen multiple iterations of this, so I'm not saying that it's the official one, but you get the idea. In software lifecycle, there are multiple steps, but when you think about it, infrastructure is almost the same, because we need to support applications that will be deployed on top of an infrastructure. And in infrastructure, we have also to think the same way. First, infrastructure as code, but also design, do some kind of requirement gathering, implement new hardware, new solution, maintain, and eventually at one point, it's not shown here, but we need to exit the circle when we have to decommission a piece of infrastructure. So as a kind of, I like to call that the loopity-loopity-loop. That's a trademark thing that I just invented 5 years ago. These are more or less the steps. So we can use different words, but these are the idea, the principle behind. So quick survey from all these steps. So design, build, maintain, operate, and decommission. Which part do you think is the most important when you are talking about infrastructure? Which one? Quick survey. Which? Decommission, no, that's usually the easiest one. Maintain and operate, the third one. So that sounds like a little bit boring when you are working in infrastructure to maintain, because it's not where you see the new shiny things, but it's really mandatory, and usually it's overlooked and underrated, the maintenance part of a project, including for an open source infrastructure. Because if you do your job right there, people will not notice. But it's because you did a good job at maintaining what exists. And yes, there is a part where you need to design, implement new things, but just maintaining infrastructure is really, really needed. So this is a big part of what we do in infrastructure SIG these days in 2024. It's just the maintain part. So I had to put at least one slide with some charts. So here we go. This is coming from the CentOS Infra Tracker, one of the various trackers that we are using, because I mentioned for CentOS Stream Infra, not covered by this talk, we have another internal to Red Hat issue tracker. But this is just for the public infra tracker for the special interest group. So the number of tickets we got over the last year and how it was worked on. So clearly, like a new SIG is coming in, we need to onboard, create GPG key for them, maintain, operate, etc. So tags creation in CBS, so in Koji, everything else. So this is what we mostly did for the operation part of CBS. So one of the biggest change was the update to Koji 1.34. Nobody noticed, we just announced it, but nobody noticed, which is in fact good. That means that it was a smooth transition. The reason why we did that was to also start to switching to systemd and spawn for ch-root isolation, and also be close to what is used internally to build CentOS Stream. So we are at the same level of Koji. All the builders were installed from EL8 to EL9. For one particular reason, people doing kernel builds and K-mods, they were hitting issue, and I know that Neil is remember what I'm talking about, with the small HMAC issue that we were seeing from a ch-root when using systemd and spawn, when you have the kernel running, the host running a kernel from EL8, not having the correct patch for that implementation, when it was a call to libck API, in fact. And so everything was upgraded. Again, nobody noticed because we just took machine out of the pool, reinstall completely, automation for the winner, put it back, and so on, and rinse and repeat, and that was done easily. So other things that we did, you may have heard that CentOS Stream 10 was announced in December, but the early bits were available for early adopter back in June, I think. They were published to the mirror network already. And so the special interest group asked for these packages to be available in the build route in CBS so that they can start working directly on their packages for CentOS Stream 10. Reason why, when it was announced, in fact, plenty of special interest group had already their package built and tested, which was a great thing. So that's one of the things that we had to implement, including RPM auto-spec support. Very few special interest groups are using it, but it's supported for CentOS Stream 10 and EPEL 10, of course, in CBS. Big thing that is, well, it's a summary of 2024, so people don't remember, but we announced beginning of 2024, we reinstall all the ARM64 builder with better, stronger, faster machine. Clearly, I think the build time for some packages like big one, like Ceph, for example, which was taking forever to build, they were divided by 3 in time, so it was really good. And I would like to also thank Ampere Computing, because they sponsor one of these machines for you to use it as a builder, so that was good from them. The other thing that you may have heard of, and it was the end of CentOS Linux 7 legacy. And at the same time, CentOS Stream 8 was going end of life. It's the first time in the history of the project that we have 2 releases going end of life at almost the same time. CentOS Stream 8 was going end of life in May, and CentOS Linux 7 in June. So, well, guess what? We had plenty of infrastructure machine running both. So that I spent a lot of time just reinstalling and moving things around to Enterprise Linux 9. Other things we did was split the chassis, the hardware chassis that we had, that were used initially for an on-prem OpenShift cluster, that were just added back as Koji builder in CBS, because OpenShift itself moved to AWS end of last year. CentOS Stream 10 onboarding was a thing. It's not that we had a lot to do. I did a lot of work on the infra just to build CentOS Stream, but after that, it was like onboarding for you CentOS Stream 10 artifact into the mirror network, but also in CBS, also in Duffy. So back in, I think it was at the same time in June, you could have requested already CentOS Stream 10 support in Duffy just to test your packages in advance. So that was also done. And same thing for debug infod package. I don't know if we have developer in the room relying on debug infod, which is like fetching the debug info package as a service directly from that instance. We add support directly from day one. The other things that, yeah, I would like to call that business as usual. So it's not fancy, but it's, yes, work that needs to be done. Various things, monitoring, backup, and of course, if we do that behind the scenes, nobody noticed, but we are doing still a lot of work to proactively monitor machine and react. That is tied to a relationship with sponsors. Since day one in the CentOS project, it would not have been possible to deliver or build anything without the help of sponsor. Before we even joined Red Hat being the biggest sponsor, of course, of the project these days, we still have plenty of sponsors. If you go to the website, CentOS.org/sponsor, you will see all the sponsors listed. And we had a bunch of machines that were still running on, let's say, machine donated in 2012, 2013, so clearly not matching any spec to run EL9 kernel anymore. So I did a lot of, opening tickets, sending mail to sponsors, and they reacted. 19 of these sponsors reacted positively to just refresh the hardware that we were using. So again, a lot of thank you message to all these sponsors, because they are really needed and helpful for the mirror network. And I have a long blog post if you are interested for that. That means that we spend a lot of time in just maintaining the infra. Nothing really fancy happened in the CentOS infra in 2024, apart from, let's say, mailman migration. So normally a migration is like, oh, but you had already a mailing list and mailman running, so that should be in the maintain and operate, right? Yes, but no, thank you. Mailman 2 and mailman 3, they share the same prefix, but they are completely different beasts. So they are mailing lists, but not built the same way at all. So thanks a lot, because it's a collaboration that happened between multiple projects, in fact. People from EPEL, people from Fedora Infra, Jonathan from Alma also contributed to it. Michel did a lot of work. Thanks again, Michel, for all the work you did for the EPEL packages for this. And we migrate easily, thanks for the collaboration. We migrate to Mailman 3 earlier this year, meaning that I can forget about it. It will continue to run and be maintained. Sean mentioned that yesterday. So the infra SIG, well, we still contribute a little bit to the content itself, but we just contribute to what was happening behind the scene to automate the workflow to make that possible. And again, thanks a lot to the documentation SIG for the content, but also for the artwork SIG. So Alain was mentioned by Sean yesterday. I really appreciate working with him, because he automated the whole step just to have through GitLab action, GitLab CI pipeline, the container registry being the container image being pushed to the registry that are used to automatically render the website. So this was a good collaboration, done in a hurry, but as Sean mentioned, yes, done and available. A small step that seems to be a small step, that was a huge step for CBS for a long time. In CentOS Stream itself, we had multiple architecture, including S390. But for the special interest group, we just add x86-64, ARM64, and PPC64LE, but a lack of S390 architecture. And we had requests from a person using S390, and they were interested into using RPM packages built for S390. So thanks to the Linux One IBM project, they sponsored one virtual machine remote that we can abuse as a builder. And so I thought that would have been difficult to add that architecture, but no, because we had already Ansible for that. So it's just building some or two packages that are specific to that. And in one day, the machine was up and running, and special interest group was able to start building for that new architecture. The decommissioning part, well, the 90s have called and they wanted their torrent tracker back. So yes, it was running OpenTracker, which was Python 2 based code, which like nobody wants to see anymore, running on CentOS Linux 7, so it had to go away. And yes, we had a discussion back and forth. Do we want to keep torrent tracker? Doesn't make sense in 2024 anymore, because we used to rely on torrent tracker for major but minor release in the old days of CentOS Linux 7 and 6 and 5 and 4 and 3 and back to the root. But these days, there are at least 1 or 2 composers a week from CentOS Stream going out with a new ISO image, so it doesn't make sense. It's like really going, and it's also backed by CDN for mirror.stream.centos.org, so by torrent tracker. And the forums were also migrated and consolidated with the Fedora one, so on the Fedora Discourse instance. So for the roadmap, first thing, let me introduce you Greg. Greg is sitting there. Just remember his name and his face, because from now on he will be responsible for everything. I will just redirect to him directly, all the tickets. But yeah, that means that we will have help, and Greg will be helping for CentOS Infra, but also Fedora Infra, because we want to synergize both infrastructure together more and more. We are relying. Already, we started to merge with Fedora a long time ago when we switched, and you remember that, the authentication platform to FAS and IPA, the common IPA. So if you have a FAS account, you have automatically a CentOS account because it's the same thing. So we'll merge more and more in the future. We'll continue, of course, to do business as usual, but one thing that is new was announced on the Fedora blog platform last week. There are 2 DC moves coming this year from Red Hat perspective for Fedora and CentOS. So Fedora is starting to move first, but they have most of their hardware hosted in one data center. We have CentOS, we have some machine there because we are enrolled into IPA. But the community cage where majority of the CentOS infra is will also move and being consolidated in the same place. So that will impact us, and I started to work with Greg on architecturing the migration so that it will be as smooth as possible. We'll also have probably new refreshed hardware for that, and we'll probably embrace the hybrid strategy more and more, just to abuse like compute CPU cycle from the cloud and have everything else on-prem. Something that I mentioned eventually, I don't know where it will go, but at least we have a kind of plan. Do you know Secure Boot? For a long time, the special interest group were thinking about, can we get Secure Boot support for our own kernel? So not the one from the distribution, but our kernel. So Hyperscale, for example, they build a different kernel. The KModSig is rebuilding also, they're tracking the stable branch of the kernel upstream and rebuilding that in CentOS Infra for EL8 and EL9 and CentOS Stream 9 and 10. And have also kernel module, third-party kernel module that they would like to be signed for secure boot operation. So as we'll converge the Fedora Infra and CentOS Infra into one DC, it can be that will be, whether it is a plan, no ticket yet, but we'd like to start working on that and finally have something working for special interest group. The other thing that you probably read, at the Fedora level, they decided to go with Forjo, but the CentOS board want to investigate the option of going to GitLab, because that's what it's used for RHEL, and so be closer to RHEL development. It's just a discussion at this stage. We are just investigating, but that should be done, and we don't know when it can be done, because it can be done before or after the DC move. They are not related to each other, so we can move one and do the other one. So that's we can do whenever we want. We just need to have a plan, but we have already a kind of a plan. Other things that was coming from a discussion, Dennis gave a talk yesterday about OKD. If you know what OKD is, it relies on CoreOS, and it exists as a Stream CoreOS version. So there is already Fedora CoreOS, Red Hat CoreOS, which is used as an operating system for OpenShift, and there is also Stream CoreOS, which is built from CentOS Stream, the distribution, and that will serve as a basis for OKD deployment. And we work with the OKD team just to have that pushed out publicly and tested, and so that you can also, even if you don't want to use OKD, you can still deploy Stream CoreOS as an immutable operating system if you want. That's one of the things we'll work on this quarter with collaboration with the Cloud SIG. And yes, of course, we'll continue to migrate the remaining Enterprise Linux 8 machine that we have, still supported, but would like to move to something newer, EL10. The biggest change will be, and there is a ticket for this, we'll migrate from the old IP table style firewall rule to NF table directly on the host, and so that will need some change in Ansible automation and a quick review, but that should be straightforward. And I think I'm on time, so I still have time for Q&A. If you have questions, I eventually have answers or not. Wait for the mic.
Sorry, you mentioned the ARC64 builders being faster. There's Ampere machine, and what else do you have, if I may ask? Any other hardware?
So we used to have all Mustang machine and also eMag, but we migrated to the Ultra machine from Ampere Computing. What I will probably do for the DC move is keep this machine around and also abusing a Graviton machine from AC2 as optional compute capacity. So that these will be the two that we'll be using in the future.
So can we start directly pinging Greg instead of you?
If you do that through a ticket, which is required, then I don't mind. IRC forever, thank you.
Any more questions? Thank you. We are once again running ahead of time. Neil and Davida will be up next, but take your time. No, seriously, we're on time, or are we going to start early? Let's start 5 early, but I want to give a chance to. There's notifications that go out for the live stream, so if I start too early, you might miss it. Do you need power? Oh, yeah.
Okay, let me turn off Matrix first, because
And the do not disturb.
you all don't need million notifications. Yes, that's do not disturb too. And the terminal doesn't work. Okay, put this on mirroring. Oh, it's already mirrored.
Yeah, we're already seeing.
Oh, we're good.
Yeah.
Yeah, we've been seeing everything you've been doing.
Excellent, excellent. Where's the button? Slideshow. Okay, let's see if this works. It does.
That works. Yeah.
Hello?
There you go.
Okay.
Whoa. I'm gonna have to.
Okay, we'll just do it from here then.
Yeah, we'll be fine.
Do you... Oh, that's the camera. Okay, good.
So.
Hi. I'm Davide.
I'm Neil.
We'll be giving the usual update on the activities of the CentOS Hyperscale SIG. We'll start with a quick recap. We'll talk about deliverables, we'll talk about recent work and stuff we've been doing, and we'll close with what's coming up down the pipe. So, Hyperscale is a SIG. It is focused around CentOS Stream. The idea is to have a place for people that work around large-scale infrastructure to have kind of a common ground where we can all work together on things that are needed. This started originally with people from Meta and other companies, but it is by no means limited to folks working in large tech companies. And the idea is just to foster collaboration between folks around packaging and tooling and infrastructure and things like that. almost everyone that has deployments of CentOS in production ends up rewriting roughly the same tools and having to solve roughly the same problems. So we wanted to find a way to take this out and make it easier for people to collaborate. We have 36 members as of this month. It's been steadily growing. To be fair, a bunch of those members aren't super active, so at some point we should clean that up. But in general, I would say the meetings are well attended. There's good activity. This started in 2021. Jesus,
It's been 4
years already.
This is our 4-year anniversary.
Oh, nice. Oh yeah, that is right. Nice. It's been a while. We are on Matrix. You can hang out there. Most of us are based in the US, but a few of us are in Europe, so you should get answers
in
roughly
theory
24 hours-ish. We have bi-weekly meetings on Fedora Meeting, also on Matrix. The meetings are minuted, although I routinely forget to update the minutes list on the docs page, but eventually they will show up there. We also do monthly video meetings. This is something that started during COVID, and we found it was nice to have people to see face-to-face. These are a mix of working sections and then just shitposting and social hangouts.
mostly shit posting.
And then we have meetups. We did one yesterday. It was very productive. We will publish notes from that. We ended up doing like twice a year meetup, I would say.
Yeah,
Usually it's this conference and then something else.
Yeah.
We'll see where the next one will be this time.
So for the SIG, we have our charter, which David already said all the things, so who cares? But we have all these documentation and reports and talks like this one. So if you want to see all the stuff we've ever said about hyperscale updates, you can watch every iteration of this and see how we started from fumbling to actually knowing what we're talking about. Mostly, yeah. And we have our issue tracker, which is more of a task tracker. We have other trackers. We'll talk about that later in here. But this is like sort of the nexus of the SIG.
Yeah, the issue tracker is a bit of a war zone now. We kind of forgot to clean it up. We were supposed to do that yesterday.
We were supposed to do that yesterday. We will do
We'll do that. Okay, let's talk about what we actually have in the SIG. We have faster moving package backports, meaning we take packages that we believe will be useful, usually from Fedora, and we make them available. We have packages that deviate from CentOS Stream in various ways that we believe are useful. We have a dedicated repo for large-scale testing enablement. We are on kernel. We have live DVD ISO images, so you can install the distribution, and we have cloud images. Let's go over this one by one. Backports. Backports are delivered into the main Hyperscale repo. These are meant to be drop-in replacement for stock CentOS Stream packages, so they should behave the same as the stock ones provided by Stream, but just give added functionality. This is almost always true, with a handful of exceptions that aren't super important. If you use this, please do not file bugs on Jira, because people will be very confused. File bugs on our tracker, and then we can triage it as appropriately. These require EPEL and CRB, because nobody in their right mind runs the distribution without EPEL. If you have to do FIPS or stuff like that, that is not my problem. We are targeting x86-64 and AR64 because those are the only architectures we work on and have access towards. If somebody really likes mainframes and wants to port this to S390X, we now have builders for that. But I don't particularly want to be responsible for testing it. But if you do and you would like to join the SIG and do that, by all means, feel free.
Same goes for Power. If you like Hyperscale and you want to do it on Power, like,
yes.
go up, please.
You can get both of those on IBM Cloud, by the way, if you really like pain. These have a lot of packages. Most of these ends up being kind of low-level system user space stuff, a few core components that we'll talk about in a moment. You can find the list in the tags. That's just the laundry list of the ones we updated in the last few months. As you see, it's just a mix of utilities, hardware enablement stuff, things like that. There's also some major packages that are work in progress, like OpenSSH. OpenSSH is kind of a fun one because at Meta we had an internal fork of OpenSSH for the longest time with like 15, 20 patches on top, some of questionable value, some more useful, and they've been like slowly trying to get those upstreamed. Upstreaming stuff in OpenSSH, as you might be aware, is challenging. So as a stopgap, we've been trying to get these into a better shape and having it published in Hyperscale, so at least it's there and other people can use it. This isn't yet for public usage, I would say, but it is there if you want to play with it. I mean, you can look at the list of patches. Roughly, I would say most of the stuff around logging and a few questionable things about ciphers.
I think at this point, I think all the patches are now documented. We went through like several months of review to get those clean, get those documented.
Mostly stuff around logging and auditing. I think we still had one patch to enable the null cipher, which you should not use, and a few other things.
Yeah.
I don't work on this myself, so I don't know the details.
I close my eyes.
Yeah.
So we have, for package updates, actually kind of maybe, we have, in theory, automated tracking for packages that need to be updated. And I say this in theory because we built, this was built by a former member of our SIG that put it in the OpenShift CI, and one OpenShift cluster upgrade, or two of them ago, it stopped working, and I have not been able to fix it, so it kind of doesn't do anything. So that's why the bullet of rewrite plan to be based on GitLab CI, because none of us can figure out why it doesn't work. So
If you're good at OpenShift, we could use the help, because none of us apparently is good at OpenShift.
yeah, there is that. But it leverages kind of the notification infrastructure that exists. Thank you, Fabian, for actually making that work. That we can reliably know when something gets pushed, and when it is working, it lets us know that we need to like merge upstream CentOS changes into our fork packages and stuff like that.
Let's talk about systemd. We have our own backport of systemd based on the one that's in Fedora. We currently have 2.5.7 as of a few days ago. We generally try to track the latest systemd release or the latest -1. This targets CentOS 3.9 and CentOS 3.10. It is basically the same systemd you would find in Fedora with all the features enabled. So it has all of the daemons that RHEL doesn't ship are here if you want to use them. So you can use networkd, you can use resolved. It has oomd available. This needs PSI in the kernel, but PSI is now available
Everywhere.
In the RHEL kernel, so that's not a problem anymore. You used to have to turn it on manually in RHEL 8. The journal has a bunch of improvements around cow optimization, in particular if you happen to use it on a cow file system like ButterFS. We also ship an SLinux module for this, so it should mostly work on SLinux. However, none of us run SLinux in production, so except Neil.
At least you remembered this time.
So your experience may vary, especially I would say core systemd should work fine, but systemd has a lot of daemons in it, and some of the like more fringy daemons will probably fire off SLinux exceptions. If somebody really likes SLinux and would like to fix the policy module, that would be appreciated.
For what it's worth, things are a little easier now because we're now backporting the SC-Linux policy from Fedora rather than attempting to beat into shape the one in CentOS. So if someone wants to come and help for this, at least a plus point would be this would also make it work in Fedora too, because that's where we would make you fix it.
We also don't have super good testing around SLinux yet, but that's something we'd like to improve down the road. We used to do development for these in a soft fork repo. These days we do everything just upstream, so the builds we do are built off the systemd stable branches in the systemd upstream repositories. Systemd is as like the main branch, but then they have stable branches where they like cherry pick patches, kind of like the kernel. The packaging also used to be its own, and now is exactly the Fedora rawhide specs, just merged into our repo, because we pushed all of the work up to make Zbyszek happy. So now we can have everything in one place. We also contributed our testing logic there, so we can run everything in one place there using the FMFDMT stuff. Then there's a repo that Dan, who is somewhere here, set up. It should be, which is on GitLab, that uses GitLab pipelines, and this runs the builds and gives us feedback when stuff breaks. And then we have a CI setup that takes the systemd GitHub main and every day builds it, makes a bunch of RPMs and shows them in a repo, so we can get daily signal on whether something that happened in systemd is going to break for the future release, or something that we did is going to break the future release, and so on. Eventually, we would like to hook this up to OpenQA or to something more streamlined, but right now it's not there yet. We do test these internally at Meta, but the results of that, the internal CI, aren't published yet because we haven't quite figured out how to make that useful. All of this stuff is surprisingly well documented because it turns out we have a bunch of people working on systemd, and every time we add a new person, it's nice to have documentation. You can find the documentation there if you would like to use this or contribute to it. That is the wrong URL, but it should still work because mkdocs does redirects,
Yes.
which is very nice.
So the Intel optimized package, most of these actually aren't in Hyperscale anymore, but this is kind of an example of us actually incubating functionality and features that spun out into another SIG and then later was merged into CentOS Stream itself. So Intel came to us some time ago about being able to bring optimized variants of certain critical components like zlib and glibc to test out being able to use new CPU features as they are detected to be available. And so we rolled these out, and people at Red Hat were interested, and so we spun up this ISA SIG thing, and they rolled those in, and eventually those were merged into CentOS Stream 8 and 9
And 10.
well, I mean, they were inherited from Fedora in 10, but like for 8 and 9, that happened in the CentOS side. So this is like a good example of how we kind of helped another party come into the community, do stuff, get Red Hat to be interested, pull that stuff in, and resolve into like generally an improved platform for everyone.
And as we mentioned, right now we're still primarily targeting CentOS Stream 9. This is a laundry list of things we did throughout the lifetime of 9. There were features we were able to contribute upstream working with Red Hat that made it into the distribution itself. So the work we did during the SIG ended up being helpful. Also for people running stock CentOS Stream and RHEL. We are also doing this for 10. The work with 10 is still ramping up, but we already had a fair amount. Oh, you added more, nice. We already had a fair amount of features that we added for CentOS Stream 10. And with more to come, we just filed a bunch more JIRAs today.
Yes, there's gonna be a lot.
A lot of these ends up being, some of these are just straight package rebases, where like this thing is self-contained, it'd be nice to update it, and it doesn't hurt anyone, so it makes sense to do it. But often it ends up being like bug fixes, extending features, figuring out things that were unshipped or they weren't enabled for whatever reason, but are still useful and don't hurt anyone.
Yeah, so like an example that's not on this list because I was too tired to actually add it is AeroFS utils in CentOS Stream was upgraded by us because I've been doing testing in both Fedora and CentOS Hyperscale about improving the performance and the compression for live images using AeroFS because SquashFS is not supported on 10 anymore. So, I went with them, talked upstream, a bunch of stuff happened, and Bob's your uncle, so I went and updated the package in Fedora and then sent, made a ticket and sent a pull request to update everything in CentOS Stream, and that's all landed in whatever. So tons of performance improvements, like your AeroFS image sizes are probably 30% smaller now, and that's why. So stuff like that.
I mentioned earlier the large-scale testing. The idea is that we have a repository that we can use if we need to deploy and test things that kind of affect the whole distribution, but we don't believe should be deployed everywhere for production just yet. A good example of this is the NF RPM copy on write work. This is something we've been working on for several years now, and it's a set of patches on top of RPM and DNF that make package installation significantly more efficient on copy on write file systems such as BudderFS. And this is something we run in production at Meta. We've been running it for quite a while. It works very well, but it is not yet upstream in RPM, and the upstreaming process of this has been challenging. There is a long list there of links if you're interested in this. This went through various evolutions and rewrites. The current iteration is built for both 9 and 10, although I think the one for 10 we still need to polish it. But
it's not there yet, which is why my images weren't.
Yeah, we'll get this sorted out.
Yeah.
Matteo, who is somewhere down there, is working on this now. But we hope to eventually get this into RPM proper and into Fedora because we think it would be valuable to have everywhere. But until it is, it's still in the experimental repo.
Yeah.
Now.
To give you an idea of like how useful this can be, a very easy way to see the improvement with these patches is an image build that I do, because I build all these live images and whatever, right? So I'm building these images like the cloud images, and the package transaction time cuts from like 10 minutes to 2 with these things because so much I/O operations get conserved because it's able to do smarter things when I have ref links between the host and the target, stuff like that. So these kinds of things can in normal situations it seems small, but it builds up and it becomes very nice for again large scale deployments.
Yeah, for image build scenarios, it's at least a 10x improvement. We have roughly the same experience internally in Meta. You should talk about the kernel.
Right. So, because I do the kernel things, so CentOS Hyperscale provides its own kernel, now based on the Fedora one with a rel-ish config. We used to be derived from the CentOS Stream kernels. Now we don't do that anymore because it is too hard. I have given previous versions of this with more detail. You can go watch those and find out why it's too hard. But now we have a development tree that's forked from Arc. We build it for CentOS Stream 9 and 10, and right now 6.12, we will roll over to the next version. We basically track Fedora stable. So as soon as Fedora rebases to a new kernel stream, we upgrade with it. And so the main difference from stock rel config that we have currently, although we are willing to explore more based on user feedback or whatever, is we have ButterFS support turned on, and we have the Android modules that are required for Waydroid to function. So if you're doing Android development, then you can use this and actually have a decent experience developing your Android applications because they won't be slow. The secure boot stuff is still ongoing. Fabian mentioned it earlier, so I just, whatever, yeah. So while we don't use the CentOS Stream kernel for Hyperscale itself anymore, that hasn't really stopped us from, if we determine that there are things that are missing or broken or could be improved, that would benefit stock CentOS, because again, our systemd backport is available for people to use on the stock kernel. So we do make sure that that stuff works. When there's things missing, we will try, or need to be improved, we try and help here. So for CentOS Stream 9, we did a bunch of build fixes, upgraded the Z standard stuff. There was some crypto stuff, miscellaneous things. For CentOS Stream 10, again, we're ramping up, so there hasn't been too much. But one big thing was that when I was working on producing our desktop images, that I noticed that ZRAM was completely broken. So turned out people missed the fact that with the upgrade to 6.12, a whole bunch of configs had to be turned back on. So I sent a fix to get that all done, and it landed. And I think the kernel that just went out 2 or 3 days ago on CentOS Stream 10 is the one that has this fix landed. So we are doing stuff like this because we want to pay attention and kind of help boost the overall experience for CentOS Stream users. We have a contribution guide for contributing to the rel kernel if you don't understand how to fix things and send patches to them in the right way where they'll actually consider it. We have a cheat sheet that will help. And part of this has also helped with being able to support ButterFS as an externalized kernel module for Stream 9. I assume that we'll probably work with the Kmod SIG again to see if we can do something similar for Stream 10 as things settle down a little bit more. But yeah, so this is kind of, we try to make sure that we can help the mainline experience with even at the kernel level.
On the user space side, we have the corresponding user space for ButterFS. So ButterFS progs is backported from Fedora and is currently at 6.12. We have CompSize, which is the handy utility that tells you how compression is set for files. Neil also backported the entirety of the storage stack and restored ButterFS support, so you can install systems from scratch with ButterFS already, and all of Anaconda and Blivet and all that fun stuff has ButterFS, and this is what we use for our spins. Outside of ButterFS, we have backport of the Kpatch stack. Kpatch is used for kind of live patching. This is something that is provided in stock CentOS Stream and rel, but the version that's provided is it only has the ability to apply patches. It doesn't have the ability to make your own patches, which makes it kind of useless unless you're using a patch feed from somebody else. We wanted to make our own patches, so we restored Kpatch build, and that works. And we use this extensively at Meta. We also backported a patch set to support kernels built with Clang and FPGA optimizations, which are quite useful, and a few other minor fixes. We do, at Meta, we do a lot of work upstream directly on kernel live patching, so this is one of those things like systemd where we're able to contribute directly here. We also backported kernel tools, kexec tools more recently, because there was some dependencies snafu with another package. I think I still need to file a JIRA for that one, actually. Yeah. But that one is less interesting. On the containers front, we have a minimal container image you can play with for CentOS Stream 9, Isam Quay. This is supposedly built from scratch. and published from OpenShift, but the build pipeline is broken right now because OpenShift.
Yeah. Cluster upgrades broke everything.
Yeah, we are likely going to set this on fire and redo it on GitLab in the foreseeable future, and we'll also get Stream 10 images containers coming soon. These are built from scratch, to be clear. They're not derived from the stock Stream containers because the stock Stream containers derive from UBI, and that was kind of a mess.
No.
I haven't looked at all what the situation is for 10. Maybe for 10 they stopped using UBI. Do you know?
I haven't. I don't know.
I don't know. We should check.
We should check.
But I mean, it's kind of trivial to make them from scratch anyway.
Yeah. Right. So, in addition to the container images, we're also making other images as part of the CentOS Hyperscale spin, which at some point will actually be on the website that you can download from. We have already right now for 2 CentOS Stream 9 spins, the GNOME and KDE Plasma ones. And these are live DVDs that have all the hyperscale content on it. All the stuff that we just talked about earlier is all included on here, pre-configured, working out of the box, and so you can download them and use them. CentOS Stream 10 images are under development. These are, and with CentOS Stream 10, like the idea is that we're going to move towards more of a strategy of having a flagship variant and then these alternate variants, stuff like that people can use and contribute to. So, like for example, for CentOS Stream 10, we'll have the KDE flagship variant, and as Hyperscale GNOME gets developed, the package set to have a complete GNOME desktop, we can add a GNOME flavor and go on from there and so on. So again, things are still in flux. It's early days, but we'll have it fairly soon. And on top of that, cloud images, which are the same story as the live images, but for the cloud, which means cloud environments, no desktop environments, it's server workloads. But a lot of this stuff actually fed up back into Fedora and is actually was the progenitor of the work in Fedora 40 to redo all of the cloud, vagrant, and container images to use Kiwi, and kind of kickstarted the development of the Kiwi plugin for Koji and all this other stuff to make it so that there is a streamlined, easy to manage way to produce both standard and custom images from this thing. And the improvements that come from there come back down into us in Hyperscale, and has also helped the CentOS alternative image SIG, which you'll hear about in a little bit. But like that's what that the cloud images work was kind of the seed for all of this other stuff that has happened here.
Okay, let's talk about what's new. We have CentOS Stream 10, as we mentioned, so you can start playing with that. I think we only have this one slide. Yes. Checking. We had a bunch of work to get an updated visualization stack in Hyperscale. So right now we have backports of QEMU and libvirt that are being used in production at Meta, and this should work fairly well. We are going to be doing active development on QEMU in particular, so you can expect this to be updated. I also expect to have libguestfs at some point in the future there. libguestfs is challenging because it uses every single language on the face of the earth in one single package, but it is necessary. So yeah, this should be available soon, and it works fairly well. The other thing that we were able to do in the last 6 months or so is that we joined the Linux distros mailing list. Linux distros is the private list that gives you embargoed security notifications when there are CVEs. Because we are shipping software that is like end user software, and we have a distribution spin, and these things can have CVEs, we felt it would be responsible to be able to handle this timely. So this has been useful. We've been able to leverage it already a couple of times, and in general, it's been valuable to get this kind of exposure early on. Coming up, as Neil mentioned, we will have spin images for 10. We are also playing around with porting CentOS Stream to Apple Silicon platforms. Neil and I, in a different project, have been involved into the Fedora port to Apple Silicon with Fedora's iRemix. We'd like to kind of do the same thing for CentOS Stream. I have a copper that does not work for this right now, but we are slowly getting there. There's like a long list of things to get into EPEL, but we'll get there eventually. There's also work around doing unified composes for SIG content, which Neil will talk.
Yeah, I'll talk about that later.
We already talked about QEMU. We would also like to get QEMU in EPEL at some point, but that is challenging. So we will see. We will see where that goes. And finally, there's still interest in doing butterfly transactional updates at some point in the future. We'll see when we might get there. I think that's all we had. We will leave you here with a few resources. As I mentioned, feel free to join our meetings. They're open. You're also welcome to join the video meetings. Just introduce yourself, and you're welcome to come and shitpost with us. We have the issue trackers. We have the mailing list. Any questions? Yes, yes. How does this work?
He's got the third microphone.
You have the mic.
We have 4 mics, actually.
Run the mic.
I was half a millisecond earlier. So, Neil, you mentioned that the ERFS images are 30% smaller, but you didn't say then the bloated up ERFS images or the squashFS images?
They were 30% smaller from when you would do AeroFS images before this update. That's not relative to squashFS.
Okay.
The relative to squashFS is a different one. At this point, they're comparable. The compression levels are relatively equivalent with this patch set. Before that, it was significantly worse unless you pumped up the compression levels and waited a whole lot more time. There's been a lot of work done upstream, and I'm engaging with them on a regular basis about like bringing the time down and bringing the compression levels up, and that has been on almost a every other day improving kind of cadence. So like I can't give you accurate numbers because like when I get to my computer and look at my email, the dude's written another patch and like it's another 5 or 6% improvement, and I have to keep testing to tell you what those numbers are. So, but it is a lot of continual improvement. I also became the co-maintainer of AeroFS utils in Fedora, so I can just keep pushing the backports and fixes and updates there pretty quickly. But obviously I can't do that for CentOS Stream, so I just wait until there's a nice batch of fixes and then I'll send it again.
Thank you. You mentioned, if I heard you correctly, you mentioned about contributing something to upstream QEMU. What areas do you have in mind? And second related question is the QEMU in EPEL. Why extra packages? What is missing currently in CentOS? Or
I think we can answer this question backwards, so because it's a lot easier. Okay. So the reason for QEMU and EPEL is that the QEMU KVM package in RHEL strips almost all of the functionality from QEMU. So QEMU KVM only includes native Arch virtualization and removes most of the
ECG, the emulated.
User emulated, system emulated, some of the extra devices, the display modes, the remote modes, the orchestration modes. All those things are important for various reasons to us. You know, a couple jobs ago, I was maintaining the virtualization stack, and I was the original one who brought it into Hyperscale. Now, Meta also uses that work and has been extending it further.
Yeah. From a community point of view, that makes absolutely full sense. Thank you.
Well, foreign Arch mock truths don't work without QEMU user, and that isn't in RHEL. So it is very hard to build for a computer you don't have when you don't have a way to run it on your computer.
Yeah, and in terms of QEMU, at Meta, we are using more and more extensively QEMU for targeted deployments, I would say. The thing, I don't work on this myself directly, but the things I'm aware of, that there's a lot of work happening around confidential computing, and part of that is backporting work that has already happened upstreaming QEMU into the build, but part of that is also trying to run that in production, finding stuff that is maybe not working as well, fixing it upstream, and then getting those trickled into distribution. There's a number of other areas. We also use QEMU extensively for ephemeral development system, for lack of a better word. People do very interesting things on development systems, and it's not uncommon to manage to trigger fun bugs. So those are examples of things. For what it was, the folks that work on these are getting into Brussels today. So I'm happy to put you in touch if you'd like.
Thank you. Yeah, I mean, I work with the QEMU community as well closely. So there's also folks working on confidential virtualization. Also, will be here tomorrow.
Oh, excellent.
There's a separate attestation developer room at FOSDEM related to this confidential thing. But
yeah, so originally when I brought in the virtualization stack into Hyperscale, when I was working at Datto, we needed the upgraded QEMU to have fixes for being able to convert disk images to various virtualization formats, like particularly VHDs, which were broken for a very long time, and we were backporting fixes that we were making upstream for that. The other one was we had a patch set on top of QEMU and libvirt to support RDP for it with our RDP Mux solution. And so that was being maintained with RDP Mux and all this other stuff in Hyperscale for a while. That was during the 8 series time, and then 9 and 10 we stopped using that at Datto, but then Meta picked it up for their own use cases, so the stack kind of stayed in Hyperscale.
Thank you. Don't want to take up more time.
Anything else? Oh, all right.
You mentioned the Wayland for Waydroid
Yeah.
patches. Is that in Fedora?
The Waydroid stack, the user space for Waydroid is in Fedora. It is not branched in EPEL, but if you
Is it working in the kernel though?
I mean, so it needs
doesn't work.
it needs 2 Android features in the kernel to be turned on to be useful, and so the stock rel kernel doesn't have it as far as I know. I haven't actually checked with the 10 configuration, but it wasn't there before. But
I was more specifically asking about Fedora. Sorry.
yeah,
I know
for
this-
Fedora, it's all there.
Fedora's good.
Okay.
It's been that way in Fedora since Fedora 34. Yeah, 34. So it works on either Fedora KDE or Fedora Workstation since Fedora 34.
Okay. Thank you.
All right. Thanks, everyone.
Hey, everybody. We've got one more talk. We're like 5 minutes ahead of time. We'll just go straight into it. And then hopefully we can have a little bit longer break. All right, so.
Or not. We'll just have a extra speak time for. Sorry. I'll turn it back over to you.
Oh, okay. Well, I gave Troy a very long introduction yesterday, so today I'll just mention Troy is back here. He's a principal software engineer on the CentOS Stream and Emerging Rel team, and he makes these amazing shirts. So he's going to talk to us today. I think I got teased already in the last talk about the work in the alt images SIG. So Troy, thanks for joining.
Hello, everybody. The one thing that we didn't put on yesterday's introduction was that I'm also the chair of the CentOS Alternative Images SIG. We didn't want to abbreviate that anymore because AI SIG just did not seem right. We had to put AI in there this time. Okay, it's our yearly SIG update or semi-annual SIG update. What does our SIG do? One of the things I do on the CentOS stream side is make the images for the CentOS stream. One of the reasons this got started was because we have your net install thing, which is really small and it has to be done over the internet, and you have a 10 gig DVD, and I kept asking, can I make a smaller one, some minimal? And they said no, and they said, but there, you can make a SIG. So I did. And the alternative, the Hyperscale SIG has actually been working with me, and a lot of them are in the SIG. So our goal is to build alternative images for CentOS Stream. Whenever possible, and thus far it has always been possible, we're building it on the CentOS SIG infrastructure. That's really a big thing because we don't want to say, well, was your laptop really in okay condition to be building that thing? So what have we been doing this is actually just this quarter. This quarter we got our updates out for the 9 images. So currently for CentOS Stream 9, we have live images that are the Cinnamon, boot into Cinnamon, GNOME, KDE, Mate or Mate, however you want to pronounce it, XFCE, and my favorite, which is the Max, that has all the desktops, all of those desktops, plus a few more that don't do well with live images. And my second favorite is Min, which is text-based live image. That's actually what I use the most, because when I need to boot into something, I don't need the GUI stuff. I just want to boot in. We also updated our WSL images for Windows users. That was really good. If you haven't seen previous slides, I did a demo on how to do the WSL. But the big news this January is we have our first CentOS Stream 10 live images. So we only have GNOME and KDE right now because those are the only desktops in EPEL, or as someone call EPEL, or whatever. That sounds weird, doesn't it? But EPEL, how's that? That's even better. As we get more desktops in there in EPEL, then we'll build more and more live images. A couple of them, the fact that there's no X has slowed down a couple of them. We also have the WSL for 10 images. All of these images currently are for x86-64 and Arch-64 only. It's very much like Hyperscale. Nobody's asked for the other images, and to be honest, I don't know a single person who's used our Arch-64 images, but we make them. So what do they look like? This is, majority of this talk, just so you know, is going to be a demo, but I want you to see what all these are. This is CentOS Stream 10 live minimum image. This is actually blown up quite a bit because otherwise you can't see it. But hey, you boot into a machine, you got CentOS Stream 10. Wait, no, that wasn't. Sorry. I should look at my slides while I'm doing them. This is our WSL 10 image running on Windows. But it is also blown up because you can't read it, because obviously I can. Anyway, this is running on 10. It works great. Thanks to all of those that got the WSL stuff. I think some of it's Hyperscale, some of it's probably Neil, but I know there's other people that helped. It was so easy. And wow, it was amazing. Okay, this is the Min one that I mainly use. You boot up, there is an install the hard drive. You can do the install it text-based, and it just works. One note on the 10 install the hard drive. It does on the text-based. It installs it and all that, and then it says, okay, hit enter to finish. And then you get this error. Don't worry about the error. It still worked. But to head off any tickets that start coming my way, it's a known function. It's not a bug. It actually doesn't crash. It just gives you this weird SE Linux warning, even though the SE Linux stuff works. I do run with SE Linux on. It was on before, it's on after. After they're installed, SE Linux stuff works. But it gives you this weird SE Linux warning. But it installs. We're working on that, so don't worry about that. This is what GNOME looks like. For those of you who've installed CentOS Stream 10, it looks very similar. It's just we got the little, can you see my mouse on the thing? You can. We got the little install the hard drive there. It looks great, but you know, this is what really looks good. This is our KDE version. As those of you who might have missed the talk yesterday, there's this little icon down here. Says, looks like a little Firefox. So again, we have Firefox in there. This was something we were concerned about, and literally the last minute as I'm making these images, it got put in, and I was like, yes. So anyway, KDE Live looks great. I happen to love that background. Wait, I went too. And we also have our Macs. There's GNOME Classic, GNOME, and Plasma currently right now for 10 Macs. We also have the 9 images. I'm going to go through them just so you can see. We got our Cinnamon Live. We got our GNOME Live. This is what it looked like for 9. These are for 9. GNOME Live looks good. KDE Live 9. I like that one, that background. The XFCE, by far my favorite background. The little mouse is cute. It's not a penguin, but it's still cute. So this actually shows all the ones we've got. This no longer has, okay, here's what it, here's what it used to look like. GNOME, anyway. And we fixed that. We fixed that bug. It now just lists, I mean, there's still several GNOME things, but it just lists the actual GNOME desktop, so it's not duplicating them. So we fixed that. Okay, and this is the old Live. Looks like the new one, except for it says 9. And this was the WSL 9. So, what do we see in our future? This slide might look familiar of those of you who looked at me. We are still working on persistent media. That is the holy grail that we're looking for. We're still working on raw images for ART64 or x86-64. Flipping that, I don't know anybody who uses raw images in x86-64 on purpose other than testing, but we're going to make them because I can test on those. I don't have any ART64. Not on this slide because they only came up during this conference and I didn't get a chance to do this. We're going to work on the WSL next generation. I wish they had done, when Microsoft had updated WSL, I wish they'd done it to like to 3 or like 2.5, but having a point release upgrade to have some major functionality isn't. Anyway, there's a new way of doing WSL. It will make it easier to install and stuff like that. We'll start working on that. So like I said, it's not on this slide. The other thing is, I should have said the other thing first. Oh boy, what was it? Anyway, there's other things we're working on. Now, for what people really want to see is the demo. I'm not going to show this next slide until we go to the demo. Those who were observant might have noticed something about my laptop this time. Come on. There we are. Yeah. Yeah, that's just a CentOS background on a Windows machine, and it is Windows 11. So we're going to do a WSL demo this time. So those of you who are concerned about me being hacked, I have no network on this machine. So, because let's be honest. Well, this isn't like a black hat thing, but we're gonna start with the command prompt, run it as administrator. Yes. Okay. The font is really small on this, and I realize that. And wow, I can type. I'm just going to show you what I've got on there. CentOS Stream 9, Ubuntu, and CentOS Stream 10. Here's a fun thing about CentOS Stream 10 and RHEL 10. It does x86-64_3. If you they can be new chips. Intel does not support that on all of their newer chips. So you can be running a Windows 11 laptop and not be able to run RHEL 10. And I have that. So we're going to be doing CentOS Stream 9. I'm sorry, I didn't mean to badmouth anybody who helped implement that, but anyway, I'll get off that soapbox. I have CentOS Stream 9 set up, and there's a few things I wanted to show on this. First off, CentOS Stream 9, I've already installed Firefox, but I'm on a Windows machine. Yeah. WSL 9, or CentOS Stream 9, on a Windows machine will do graphics. And it will do Firefox. And to be honest, it does do Wayland too, for those who are wondering. I have tested this with the CentOS Stream 10 thing. It's just that my laptop doesn't have that. Firefox, come on, stop. We want to show something else. Okay. So we do have a question, but I'm gonna. The question is that out of the box? Good, because I was gonna. Thank you for reminding me. Yes, that was completely out of the box. I typed in Firefox and I was like, what? I didn't do anything. So yes. The other question is, does it have hardware acceleration? And I haven't a clue. This machine has got just an Intel chip. It itself barely has hardware acceleration. So another question, and this actually came up in another meeting, and I didn't answer it on purpose. Does KDE run on it? I cannot get. Somebody else might be able to, but I cannot get the full desktop of KDE to run on it. And on using the CentOS Stream 10, majority of the KDE apps do run on it. The exceptions are things. The exception I found was I was trying to do a screenshot. So you guys don't need me in names. The KDE screenshots is whatever it is. Spectacle, yeah, because that's easy to remember. It does not work on it, but my Kwrite, all my Office stuff did work on it. But this is CentOS Stream 9. And the KDE stuff really doesn't work on it. 10 it does, 9 it doesn't. But not all GNOME stuff, but some GNOME stuff does. So if we do Nautilus, because let's be honest, I prefer using a Linux file browser versus a Windows file browser. And also, be honest, I prefer KDEs, but we're going to do this. And this is also out of the box. I don't know if you guys have used WSL or not, but out of the box, it will mount your Windows drives under /mount. So we have this C drive right here, and I can go into my Windows thing and look at that, and I can go, hey, what's under this test thing? And look, there's this presentation, so we can just do, open this up. What'll it open up with? Oh, that's right, GNOME has an actual open up or a document viewer. So, thank you, GNOME, for not having any, sorry. I should not diss GNOME people. GNOME is a good desktop. It is a good desktop, and it is way better than the other one that I'm trying to cover up right now. But then we can use our GNOME things, and we can go down and see the other slide that I said I was going to wait for. There we are. So, how to do it? As somebody asked, is this straight out of the box? Yes, you use the alternative images does have a page on how to install these things. It's simple. It's 3 steps. Download the image, WSL install, and we've got the things to put in there. With the new way, it will be much easier. Just do WS install the tarball, but now there's some extra stuff. And then WSL run, and we've got a few extra commands for things like that. So right out of the box, you get graphics. One word of warning, don't try to run it as root. That's when you start getting errors. Those of you who saw my last WSL thing, we were trying to run it as root. That was, if we hadn't been running it as root, we would have been surprised on YouTube. It would have been a genuine surprise. So CentOS Stream 9, some things work, some things don't. Like I said, Nautilus works, Firefox works. I purposely didn't open up those images. GNOME's image viewer doesn't work. I'm not going to debug it, but it doesn't. If you want a really good experience, do CentOS Stream 10. The graphics work really good. The Wayland stuff works really good. But not everything. Like I said, the Spectre, it says something about dbus issues. So I said Spectre, it's Spectacle. I have a question over here. Can you hand him a mic?
So I think I know why those weren't working, and it's because, and also why you couldn't launch a KDE desktop in your WSL environment. There is a command that you can run as part of launching any of the KDE applications that need dbus, and it's called Plasma dbus run session if needed, and it checks if dbus is running, and if not, it will start it and bind it to the process that you're trying to run. And that will let you run the Plasma desktop as well as Spectacle and the other things. And the reason I know this is that if you remember last year from Flock, when I was and at Texas Linux Fest when I was doing the Cloud KDE talks, though that's what I used to run KDE over the internet with RDP with Weston, and this is just Weston, so all of that will work the same way.
Thank you very much. We will get that written up and put it on the documentation page because that will be cool. I'll be honest, I don't have very many Windows machines. I have one. I use it for gaming. And I know you can do Fedora gaming. You saw me on the slides. Adam was trying to tell me that does gaming. But, hey, Fortnite doesn't like Linux. Anyway, at this point, we're at questions and answers, or do you want to see more demo stuff? Or we could get out of here early for lunch. Or, no, it's not lunch, is it?
No, it's a break, but we'll have a long break at this
We'll
point.
have a long break. We do have one question. The question was, are there any others that you have tried? Are you asking about WSL specifically? No, I have not tried any others. Yeah, I've tried GNOME KDE. When Fedora WSL comes out, yes, I will be trying probably every Fedora desktop, which there is many. But good question, thank you. Sure.
Thank you. This runs on Weston, so it doesn't run on Wayland yet.
Yeah, Weston is
So natively on Wayland.
yeah. So this is natively on Wayland. One thing I didn't show because I'm not a Windows person and I don't know how to get this back up again, but there is a WSL settings, and one of the settings, which is on by default, is graphics. One of them is can your thing do thing virtualization inside virtualization.
Nested vert.
Nested virtualizations. There's several buttons, and I believe one of them actually was a Wayland in the X setting. But by default, they are all turned on, which is handy and nice.
Yeah, that last setting is, do you want X11 applications to work? And by default, it's on, but you could turn it off if you don't like the implications of an X11 server that is somehow talking through RDP to Windows. The way that WSL works is that there is a fork of Weston being used as a rootless compositor using RDP to talk to DWM, which is the Windows compositor, to be able to run the applications on there. So you can do Wayland applications, you can run Wayland desktops in windowed mode or in full screen mode, as long as you're aware of how to invoke it to talk to the native Weston compositor that then forwards everything over to the Windows desktop. So use RDP internally? Yes, RDP, RIALL, I think is what it is. The remote effects stuff for the Windows application thingy that they do for Azure, that's the same technology. So you can run this remotely? Yes, that's how it's done for Azure, for Windows apps on Azure.
So those that didn't hear, his question was about, can you run this remotely? And Neil was answering that question. Yep.
Does the X11 server run a system?
If
That's clarifying.
yes,
Great.
that's why it's a checkbox that you could turn off.
Yep. Yeah. Like I said, I'm showing the settings things, but I haven't hit them all. Okay, so yeah. Let's see if this one actually comes up. No, if you see in the background, it's saying, no, the application doesn't work. So show photo doesn't work. Let's try, I know Ocular doesn't work, or Gwenview. What about color paint? Oh. No, that's what I'm trying. The GNOME image.
None of those worked.
No.
So it's failing to.
On 10 it does. All of them work, both GNOME and KDEs. At least for GNOME, simple things like image viewers and stuff like that, things that need the dbus, no. But for 9, it's limited. So if you want graphics, I say go for the 10 image. It's up there. It works. It works great. You were going to say something, Neil?
I was just going to say that the reason that all of them are failing is that on 9, for some reason, it is not correctly detecting the Wayland socket to connect to when you are launching an application from another application. So it works, it seems to, well, except for that one, which I actually think is running as an X11 application. Which
I think you're right. I think it is.
There's
your
terrifying
office.
things going on in here.
Yeah, if you guys want to actually see all the errors, yeah, it's every
Yeah, so
time I
it's
hit
trying
that.
to load it as an X11 application, and it's failing, and it can't find the Wayland platform, so it's failing to do anything.
Yep. Yeah, it's saying all sorts of things. If this machine, this is another thing. So if your chipset cannot run Rel 10 or CentOS Stream 10, don't just try to put it in WSL. It still will not run. It will look at it and go, you don't have the right chipset.
Another question is that user RDP, have you run any preliminary performance benchmarks on this?
You have to ask him. He's the one with the Windows computer.
Well, no.
Sorry, that
And
question goes to
that
the
sort
two
of
of
goes
you.
along with the hardware acceleration.
Yeah, I'm just wondering about the performance implication, because RDP, at least the little I know about RDP, is not the most performant protocol.
Play Super Tux card. We'll find out.
Go ahead, yes.
I do not have that installed. That actually sounds like a good idea. I don't have it installed, and I do not have network on in this machine.
Fair enough. No, I was
This
just
isn't a
wondering.
Black Hat conference, but
I mean,
as soon
all
as
looks
it's getting wiped as soon as.
it all looks very interesting, but there seem to be a couple of caveats. So,
Yes.
but it does look interesting, and thank you very much.
Yeah, there is some caveats, but it is, and I really wish I had the 10 machine, and then I could do. But we'll get with Neil afterwards. We'll get that command up on our documentation, and I look forward to next time. This Windows machine will just be running KDE, except for this thing doesn't run 10. Anyway, this Windows machine will be running.
So, final question from my side. This is
Okay.
24H2 with regards to the Windows build.
Which
It's
Windows build?
11, exactly.
It's 11. It was updated like a week before.
That must be 25H2, which the latest build in that case.
I believe so. I don't do any development thing, but it is the latest
Just
Windows.
asking. Okay.
But I also ran these on my Windows 10 machine. My gaming machine is a 10 machine because I won't get into that pile of thing. I think I've already said enough negative things about it, enough communities to be bad. But it does run on 10. And I can verify after I get home whether Neil's command will let me run. That will be cool. Have my KDE desktop on my 10 machine. Sorry, that just sounds cool. Any other questions? I think we're almost out of time now. No? Oh. I talk fast. And I break things. That's how you learn. That's what. This has nothing to do with alt images, but in life, go ahead and break things, but also learn how to bring them back. So break things safely, and it's good. Okay, thank you very much.
It wasn't just you talking fast. We've been running ahead of schedule the whole time. We've got, I'm going to mention, because that was the alt images talk, we actually have some USB sticks with the live images. Some of them have the Mac, some of them have the GNOME. So if you want to try them out, we've got them up at the Reg desk. We've been running ahead of time. We've got about a half hour, 35-minute break. So come back at quarter after the hour, and some guy named Neil's going to be talking. So. Hi, everybody. When I start talking into the microphone, people out there hear me and come in. Was this the VIP seat? Would it work maybe through the USB-C with the dongle?
It only works when the computer's power cycling, not when the computer's done voting.
Let me throw away the cup of coffee first, because otherwise. Do you have a bin? No. That's fine.
I don't know. Okay. I can do that.
Do it like the elements. Okay. What do you need?
Well, my computer doesn't work,
Okay,
so
you can use mine.
I need to. I shared it with you in the
Yeah,
slide
yeah,
deck, so
I have it.
you should be able to pull it up with your.
Let me just grab it.
Yep.
No, but it's that's not a problem. It's more that it's on the close this. Stream, do not disturb. Turn on caffeine. Then you have the clicker if you want.
All right, hey, let me just check the time. Okay, next up we'll have Neil Gampa, who's a principal consultant at Velocity Limitless. Yes? Yeah. Will be talking to us about creating collections for CentOS SIGs. So please welcome Neil.
Hi. So hello, everyone. My name is Neil Gampa, and I'm here to talk to you about creating content collections for CentOS SIGs. So there is a lot of things about me on here. This is a lot of bullets. Put it simply, like, my day job is I'm a consultant at Velocity Limitless, my consulting firm, but I also contribute to a number of Linux distributions, as well as a variety of open source projects in both code capacity or mentorship, leadership, directions, project planning. I also am involved in KDE, as well as in Wayland and all these other related stuff. And I'm a co-host of the Pseudo Show, where I talk about open source, business, and all that other fun stuff. So let's talk about CentOS SIGs. So CentOS special interest groups are a part of the whole CentOS project in the sense that CentOS project itself is essentially split in two. You have the core group from Red Hat Enterprise Linux Engineering that develops the CentOS Stream distribution, and then you have everyone else. And everyone else is, there'll be the infra SIG, as Fabian was this morning, Hyperscale SIG, as David and I earlier, there's automotive, there's K-mods and virtualization and all these other special interest groups that have different functions and provide additive content for CentOS Stream. So SIGs operate on the principle that they provide something to make CentOS Stream more interesting to use on top. And so how this kind of looks, and this is kind of a little bit in the weeds, but also I think kind of helps illustrate what I'm talking about here. So this is from the Hyperscale 10, one of the tags for, or the build environment setup for one of the Hyperscale build tags in CBS. And for this, you can see we have all these Hyperscale segmented content repositories being pulled in through the inheritance. But you'll notice that the external repos, we have the CentOS Stream stuff and Fedora extra packages for Enterprise Linux. And this allows you to kind of see where the divide is in terms of what stuff SIGs are able to do things with versus ones that can't. Things listed as external repos are effectively treated as immutable. You can't really do anything about it. You kind of have to just react and respond to when they change, because it's not up to you. Whereas the stuff that's in the tags is the stuff that in the normal inheritance model that you can actually control, which comes in and out. Even if it's a tag from another team pulled into your inheritance, you can exclude content from that or inherit it or whatever. So you have more fine-grained control over the stuff that you have, and then you just kind of have to take what you get from the external content sources. So there are two big problems that kind of come out of this when you especially have SIGs that consume lots of independent sources or interdependent content sets. The SIG content in CBS Koji can change and publish at any moment based on the activity because everything is instantaneous. Everything kind of happens immediately. And the content pulled in by CBS Koji, the community build service, to expand on that, will change on a schedule that you don't get to know. Well, in practice, you get to know for like EPEL. For CentOS Stream, you kind of sort of know because you know that that they're doing these collections, these composes, on a regular cadence. You don't actually know when those composes are actually going to go out because that part is sort of invisible, and so you just kind of have to accept it coming in. So that's the content integration part shifting all the time, and then you have issues with when you want to create test cases and reproducibility and things like that. When you are trying to isolate a problem that you are seeing, you want to constrain or simplify the variables. You also want to be able to lock down the inputs so that you have some kind of way of describing what is the state of the world that creates or fixes a problem and be able to prove it. And in the way SIGs are able to function today, this is not really possible because SIG content is not strongly linked to the content that they build on top of. So when something gets built and shipped into a SIG repo, the relationship to the content that it came from is gone. And therefore, when you install it, for example, you don't know whether the nature of the problem was caused by you or the nature of the problem was caused by the thing you were built on top of or whatever, because you just don't have a way of proving it. And this kind of leads into the second point, which is that a complete collection that kind of shows the full set of inputs that release to create the outputs is just not available to you. So we'll jump quickly to Fedora for a second. I promise this is important. So Fedora differs from CentOS in a couple of key ways. The first way is that everyone is involved in the production of the Linux distribution. For the purposes of our discussion, there are two major parts of it. There is the Fedora Linux distribution, and then there's the extra packages for enterprise Linux repository. EPEL is not interesting for the purposes of discussion because it's basically the same problem domain that we're talking about right here. But Fedora Linux is interesting from this problem domain because it is entirely self-contained as a discrete content set. When things go out and they get pushed as updates or whatever, you have a strongly linked case of where things churned or changed, and you can prove these things because you have these content collections that Fedora calls composes. And these composes are essentially this release engineering tooling goes and pulls all the things that happened and then puts it together into one big blob of stuff and pushes it out into a folder. And then that is then used as an input for testing. So OpenQA, for example, will take a compose directly and start producing artifacts or testing artifacts or both, depending on what kind of the test cases are. So for example, in Fedora's OpenQA, we take the artifacts that were produced by Koji and then run them through a battery of tests, but then we also have some tests that test the cases that Koji itself runs. So for example, there's a test case to produce a live image to make sure that the live image tooling doesn't break as part of an update, because that's important. You really don't want that tooling to break between releases of these composes. So coming back to CentOS and talking about what that means for us. The CentOS Hyperscale SIG operates quite a bit differently from most of the other special interest groups in CentOS, with the notable exception of automotive. Special interest groups in Fedora, and I guess now the Cloud SIG because of the SCOS thing that happened yesterday. CentOS Stream Core OS is, I think, what I'm supposed to say there. So with exception of the Cloud SIG with CentOS Stream Core OS and the automotive SIG with the CentOS Stream Automotive Distribution, you don't really see SIGs needing to care about the link between the base components and the layered components in a way that they can have verified testability. Like that's not important to them because they don't deliver an artifact. Like when the virtualization SIG was building overt, it was an important factor for them, and they actually built out secondary infrastructure for this. When RDO was doing more stuff inside of CentOS, they were also doing this. Neither of those projects do things in CentOS infrastructure in this way anymore, and so they're out of scope. I mean, their problems are still there, and they're still real, but they either solve them differently or they don't care about them. So for CentOS Hyperscale, you essentially have to start thinking of us like, well, okay, we're basically operating in the same sense of a Fedora Linux, where we effectively want to create this relationship of a strongly linked set of content between all the different layers and treat them as one testable unit for whether it's validation, release engineering, or any number of reasons. So this is where a tool that we've been developing for Hyperscale and hopefully will be useful to other SIGs called Kurchu, which is a tool to assemble Fedora and CentOS resources to create artifact collections. So essentially the same thing that Punji does in Fedora for Composes. If you're familiar with Punji, it is, naming a Punji, it charms anacondas to do things, whatever. But like, it used to automate Anaconda. That's what it used to do. So that's why it's named that. But Punji is used to talk to the various services within Fedora to collect the content, to orchestrate the creation of image artifacts, pull them in and integrate them into the set, and then push them out to testing. And if they pass the testing, then push them out to the mirror network. In some sense, this is what we're attempting to re-implement with Kurchu in a slightly different fashion and more tuned towards the use case of, well, we're trying to integrate these disparate things that already have their own stuff and provide another layer on top of integration. So for Kurchu, it's basically defined with a TOML. Sorry if it's too small to read. It's actually quite hard to make that fit and look semi-reasonable on a slide. But the idea here is that unlike Punji, which uses semi-programmatic declarative configuration, which scares me, I decided to kind of go a fully declarative approach using TOML with some templating, very, very restricted templating that allows you to define what your inputs are going to be and how you're going to transform and then publish the outputs. So this is a TOML configuration file for a CentOS Hyperscale 9 compose, which results in something like this. So just a few days before we all got ready to come here, David and I got kind of our first compose that worked up on this site, hyperscale.sig.centos.org. So hyperscale.sig.centos.org is, a resource sponsored by Meta for the Hyperscale SIG to be able to host these testable units. And I went into a folder to kind of show this. This is, you can see this base extras, EPEL stuff, Hyperscale. And if you go back to this description here, you may not necessarily be able to read it, but I promise you it's there, is that we list the hierarchy that we are constructing for this ultimate output inside the definition. So we don't really make assumptions about the structure. You get to define the structure as you please. This is another big difference from how it works for other compose tools that are used in the Red Hat world. So like ODCS, which is the on-demand compose service used for CentOS Stream itself, and Punji, which is used by Fedora, and Bodhi, which people don't know this, but Bodhi actually makes composes all by itself. It is a re-implementation of Punji inside of an update manager. So, yay. So those all have much more fixed and inflexible ways of operating this. And this was actually one of the reasons we didn't reuse Punji, was because if you tried to do this with Punji, what you would get is a one big flat hierarchy of stuff. And you wouldn't be able to preserve things like how is the ordering, the inheritance, the override model, and things like that. Those are all things we want to preserve because we want to be able to test the unit as we actually want it to be shipped. And that is not easy to do with Punji, as it is not designed to work that way. And I couldn't find enough people to explain to me how Punji's internals actually work to see if it would even be possible to make that do it. So a big part of why I wrote this was no one knows how Punji works, and that is a very big problem. And I spent a lot of months last year actually doing a lot of Punji-related work as part of the Fedora cloud move to using Kiwi images and things like that. So I learned that almost everyone else also doesn't know how this works, and we're all just hitting hammers until it works, which is not the experience I want to have for this. But yeah, kind of coming back to this hierarchy gives you a very easy way to understand, a very easy way to like structure things. And we kind of want to drill into this JSON file. And again, I apologize that if you can or can't read this, but it basically is the result output form with all of the value substitutions and things like that in place here. But another extra property that isn't in the in source is that, so for example, we have in the TOML, we say, okay, we're going to pull the latest composes of all the things, and then we're going to use that to create a testable unit. This artifacts JSON actually resolves all those latest to their exact inputs. So for example, the Punji compose and the ODCS compose and the Bodhi composes, or the Koji dist repo versions that were actually pulled in, so that if you used this JSON file, you could read out, you could actually push it back into the tool to do it again, provided that the resources are still there where they originally were. I personally wanted this because I didn't want to have to figure out how to parse all of the different ways that all the different tools that I'm consuming store their metadata. So I just wanted to pull the relevant parts of the metadata and incorporate them into this file so that you only have one place and one standardized format to pull it in. Because like Punji puts it out in a config parse, a bastardized config parser format. ODCS uses JSON, and Bodhi just uses a value in a text file, and like it's not a particular format. And I just didn't want anyone to suffer through trying to parse all the different metadata, and just made one that has the important parts. If you want to go read all the other metadata, we actually import all of them too. They're in the compose artifacts, but you don't need them. That's why it's kind of set up that way. So the current state of Kurchu and the release plans. At this point, Kurchu development is, well, is gratefully sponsored by Meta to support all this stuff. It is also being done in tandem with the development for CentOS Stream Hyperscale 10. So a lot of the bring up work that we've been doing, part of the reason that it's kind of gone slower than it did when we were doing CentOS Stream 9 is this time around, I am trying to put everything into, write everything down and figure out what pieces matter and put that into a form where we can repeat this again and again and again and again, because I want to make the next round go faster, because we're doing this every 3 years and the treadmill does not get easier. So having a way to minimize the amount of human grunt work steps for producing releases is useful for validation, for testing, for integration, and even for development. So I want to have this in this for these steps. At this time, Kurchu can gather all the repos, and it can produce the metadata of the collection, and it can publish them either to a local mount point directory for being to a regular web server, or to S3. I mean, other targets can be added because the internal code structure supports more targets, more things, whatever. The remaining thing to do for the initial release is to get it to be able to orchestrate producing hyperscale spin images and container images, because I want this, we need to replace a bunch of aging automation for image releases in Hyperscale, and this is kind of where I want to put that stuff. There's also another aspect of this design which I didn't really note, but is I think kind of important and will make it more useful for other SIGs. Each of the steps that are done in here can be omitted, and it's fine. So if for example, if you are a CentOS alt images, you don't gather any RPMs because you don't care, but you do produce ISOs or disk images or whatever. You can just have the steps defined for producing images, and it will just whack Koji with a stick until they're all built. But they will all be coherent, and you can at least tell it to also download them or archive them or publish them somewhere or whatever. Or if you're Hyperscale, you want to produce this and you want to have both packages and images, and you maybe want to have secondary steps or hooks or whatever, then these things are all possible. Or if you're RDO, maybe you only need just the repos and you want to collect up the content set so you can feed into Weirdo which is literally the name of their testing tool, to actually integrate OpenStack with the full set of content in a reasonably reliable fashion. I know this was actually a big challenge for OpenStack before, when I used to be involved in RDO, that they could not figure out how to reliably, repeatably, strongly link the stuff that they built on top of CentOS Stream and EPEL and whatever, and make sure that they could tell people this is how we were able to verify things and make it work. Because OpenStack's a big, complex system. That kind of stuff, that kind of data is really important. And they just don't have it. And Overt, which I'm not actually sure what's going on with them, but they could probably find this useful too, because in the past, Overt used to build live images to do from USB Overt hypervisor nodes and things like that, and they could orchestrate the production of branded Overt deliverables for built on top of CentOS Stream or Alma Linux or whatever, because also this tool doesn't care. It is very easy for me to add, say, another build system's compose data format to be able to consume and add that information. So we already support Punji, Bodhi, ODCS, and so on, but if ALBS has a special metadata format that we need to be consuming, for example, it could be very straightforward to add that. And of course, we could just pull yum repos, because that's the lowest common denominator. You have a yum repo, we'll pull it. So that's along with that, Hyperscale SIG.CentOS.org site still needs some work to be set up. Like, again, we literally got the first things working like a week and a half ago. So there's a bunch of things that need to be done, a landing page and a few other things there. But this will be fed. This is actually a prerequisite for us in Hyperscale for OpenQA testing, because OpenQA testing works best when you give it testable units that it can strongly link to. And so these composes that we're doing for Hyperscale will allow us to have concrete links of things that were tested and have test reports that are meaningfully reproducible. So that's kind of it. I don't know if I talked slow or fast enough, but if people have questions, yeah. I left enough time for questions, so I did at least pace it right. Okay. No? Nope. I guess I explained it perfectly. All right. You? Okay, cool. All right.
Thank you. I think you're set up. Everybody's seated, so let me make sure that this is running. You can have extra time if you want. Hey, so we'll just get started again here. Adrian Erba is going to talk to us about OpenHPC. So welcome, Adrian.
Okay, now it's working. Hello, welcome to the session OpenHPC running on multiple distributions. My name is Adrian Reber. I'm at Red Hat and I'm involved in high performance computing HPC for about 15 years now. I'm involved in OpenHPC since 2017. OpenHPC exists since 2015. It's a Linux Foundation project and it's structured like probably any other Linux Foundation project. We have a technical steering committee which does most of the technical things, as the name says, and then we have a governing board, which is, I guess they mainly deal with the budget and things like that. I'm currently elected by the TSC as the project lead of OpenHPC, and this is not my day job working on OpenHPC, and this is what all contributors of OpenHPC currently do. It's a project they do in their free time, basically. So high performance computing, what is high performance computing? This always seems to me like a difficult question because it can be many things and it can be something different for different people and how they're using it, what they're using it for. In the context of OpenHPC, we think of high performance computing something like a system like this. So this is a pretty old picture, but I think it's still true to what we as an OpenHPC project want to achieve. So you usually have one management system which kind of controls the whole thing and runs the services that you need. And then you have compute nodes, hundreds, thousands of compute nodes maybe. And the compute nodes, they are often very similar, almost the same. Maybe you have a couple of compute nodes with GPUs today. Maybe you have some high memory compute nodes. But the main problem, and like with any other system in a data center, you need to get an operating system on it. And high performance computing exists for a long time, and it always feels it exists on the side of the normal data center setup. So the things in high performance computing are often done a bit different. There are tools used you maybe have not heard before, but one of the problems you have to solve is getting an operating system on your compute nodes. And there are basically two approaches. I've seen often that people like to use stateless compute nodes, so you do not have any operating system installed on the compute node directly. You usually do a network boot, DHCP, TFTP, NFS, things like that, which makes it, in my point of view, maybe a bit easier. If you have a lot of nodes, then you do not have to touch every node yourself with some automation or whatever. You have one image and you deal with that, and then you have just to deal with one or two images. OpenHPC has provisioning tools which helps you to install or run an operating system on your nodes. OpenHPC comes with tools to do stateless and stateful provisioning. Stateful provisioning is also what I've seen people do, but it doesn't feel as common as stateless, where the operating system is installed on the local compute node. One of the things OpenHPC tries to do, the project doesn't try to force you into a certain tool. So it's one of the taglines is building blocks for high performance computing. So we like to have our users pick and choose what they want for their use case. And this means OpenHPC comes with different provisioning tools. So we have 3 different provisioning tools, and you can select the one which makes most sense for for your use case. Then once you have the operating system on your compute nodes, you also might need software additional. And this is also something which is special in high performance computing. You do not have just one compiler, you have lots of compilers, you install them in parallel, and you have compilers from different vendors. So, and one of the reasons is that, at least that what I have seen so far is that if a scientist starts a simulation with one compiler, they don't want to change the compiler ever. So just in case some result changes, you don't want your result to change. It should always be the same. It should not change because the compiler does something right or wrong. So we provide a way to install multiple compilers, multiple MPIs, multiple different libraries used for high performance computing. And one of the things which is pretty common in high performance computing is that a tool called environment modules is used to enable you to install the things in parallel and use them in parallel. I think software collections around the RHEL 7 time was a bit into that direction. It might have been even compatible with environment modules, but in high performance computing, it's very common to have that. There are currently 2 implementations. There's a Tickle-based. I just learned it's from 1991, so it's pretty old software, still around. And then there's a Lua-based called LMOD, which OpenHPC uses today. So what's also common in high performance computing is you have 2 different type of networks. You have Ethernet, usually for management stuff and maybe getting the operating system on your nodes, maybe distributing the jobs, and then you have a high-speed network, often something like InfiniBand. You want a network with low latencies so that your compute jobs can exchange data without waiting too much on each other and without losing CPU cycles while waiting for the data from some other compute node. It's InfiniBand often, or if you have some proprietary vendor solution, then maybe that's the one you have. And parallel file systems are also very often seen in high performance computing in addition to NFS. Typical file systems seen in high performance computing are Lustre, BGFS, GPFS, things like that, where you have where the users can store and retrieve the results of their simulation. Oh yeah, and then you need to distribute a job somehow, so you need a resource manager. And the resource manager, it's like a batch system, but a resource manager knows things like you can request, I want so much CPU, so much memory, wall time, GPUs, maybe licenses for software, and the resource manager will select the right compute nodes and assign your job to them. In the best case, the resource manager is even aware of network topology, so the resource manager can assign compute nodes which are close to each other again for low latency between their communication. All these things are very common, I guess, in high performance computing. And to get such a system running is the goal of OpenHPC. So this is a project which is basically useful for people who don't have that much experience. The OpenHPC project tries to provide a standard which brings you from a bare metal cluster with nothing running on to a cluster with a HPC system running on. And OpenHPC consists of 2 things basically. So we have an RPM-based software stack where we compile different things in an HPC specific way which you can install on your system. And in addition to the software, we also have validated recipes, validated documentation. And by this documentation, by validated, I mean for each release, we test all the steps documented in the written down in the documentation to see if what we provide, the combination of RPM packages and documentation, actually results in a running cluster. And we test this for each release so that people know if they use our stack and our documentation, they will get a running system. Currently, OpenHPC supports ARM and x86 systems, and we build RPMs for RHEL 9 in clones, for OpenSUSE Leap 15.5, and for OpenEuler 2203. The build system we're using is OBS. One of the reasons we use OBS is when the project started 10 years ago, OBS was a good match to build for different distributions, and for me it was in the beginning a bit difficult coming from the Fedora world, Koji side, but today I think the project is doing okay with OBS. It fits what we want to do, it solves our problems. We are lucky to only have a small amount of ifs because we have one spec file for all the operating system, and the ifs we are using are mainly for differences in dependency names. The packages are named a bit different on different distributions, so that's the main thing where we have a couple of ifs. I mentioned we have one spec file, multiple RPMs. So this is true in the case of we build for different distributions, but what we also do is, I mentioned we have different compilers, so we build with different versions of GCC, and then we build with the Intel compiler and with the ARM compiler. Those compilers are not distributed by us, but the resulting packages based on those compilers are distributed by the OpenHPC project. And so we have normally for each release at least 3 different compilers, and we support 4 different MPI implementations. So for a package depending on MPI and compiler, we already have to build one package around 12 times, 3 compilers, 4 MPIs. And then if you think about 2 architectures, 3 target distributions, so from one spec file, we build around 72 RPMs. The result is more or less the same. It's just probably some ABI differences in the resulting binary. And to do this, we again use something that OBS helps us with. With OBS, we can inject certain RPM macros into the build of each package, and so we redefine for each build the compiler family and the MPI family, and then with the help of a bunch of macros, we get all those different packages built with the help of OBS from one single spec file, which results that we can provide a software stack like people expect it in high-performance computing without us having to do each build separately. It's all handled by the build system. We do not replace RPMs which are coming from the operating system. This is a bit like EPEL, I guess. But what we do is we install sometimes newer versions of a package in parallel on the system. And to avoid collisions with packages provided by the operating system, we are doing a couple of things. Should be almost readable. So we're using something which I think it's called RPM coloring. So on the RPM name, it's easy. We have all packages suffixed with OHPC, so we don't have a collision on the RPM name level. Then all OpenHPC packages are installed into a different location, so we do not collide on the file system level. And then we use the thing which I think is called RPM coloring to differentiate our RPM dependency names. You see on the right there is an OHPC after HWLog SO15, and on the left it isn't. This is the package from the operating system in this case. And the reason why we do that is that, especially if a user has installed our package stack and then installs a package from the operating system, then DNF RPM might think, I already have the dependency HWLog SO15 installed on my system. I do not need to install the package again. But because we installed a package in a different location, which is not reachable by the default dynamic linker configuration, the binary will not run. So the user will install a package, DNF RPM will be happy, but the binary does not work. That's why we use this RPM coloring to make sure none of our packages collides on the name level, on the file system level, and on the RPM dependency level with existing packages. The second example, the OpenMPI package, you see the one from RHEL also uses this coloring because the OpenMPI package is also, I think it's installed in a different location and also needs environment modules. And on the right, it's again the one from OpenHPC, and it also has, for all the dependency, the coloring available. So I mentioned our documentation. So in addition to the software stack we provide to our users, we have the thing we call the validated recipes. And I just want to talk about how we validate those recipes. So we generate documentation. It's a PDF, it's maybe 30 pages long, where we describe what you have to do, and then there's always a shell command which you should type in to do the thing we just described to do. And we extract all those shell commands from the documentation, put it into a large shell script, and this is the basis for our CI run. So our CI system, our CI cluster is usually 4 machines, 1 management machine, and then we use that to kickstart the installation of a second machine. This is then the main node of our cluster. And once the operating system has been installed by Kickstart, or for Leap, it's AutoJust, we then run our recipe to do the actual validation of the recipe. And the recipe will then install a provisioning system. It will provision 2 compute nodes, then it will install a resource manager and all the software packages OpenHPC provides. Once this is all installed, we will run tests to see that the software we have installed is actually working. And for each recipe, we run around 1,000 tests, and the tests range from checking if the software actually starts to compiling something with the libraries to see if the compilation works, and then also see if the numerical results are correct, so that the libraries, the numerical libraries we install, actually result in the numbers we expect them to do. So we have validation on multiple levels, and the thing where this gets where this gets a lot of why this is so much effort for our side is because we have so many combinations of operating systems, architectures, provisioning systems, resource managers, and different networks. So we build on RHEL 9. We have there's this rosy Red Hat open source infrastructure project where we get our subscriptions from Red Hat. But we build on RHEL 9, but we test on Alma and Rocky Linux. We build on SUSE Leap 15.5, and we test on Leap 15.5, and the same for OpenEuler. And so we have 4 Linux distributions we test, then we have 2 architectures, and then we test for Ethernet-based clusters and InfiniBand-based clusters. We test with our 3 provisioning systems, with our 2 resource managers. And for the latest release, this means we had 23 different test suites running, each with over 1,000 tests. So the good thing for our users is that what we test, or what we release, we at least believe, or we think that it works, because we run all the documentation through our CI system as it is written in the documentation. And so this makes us very positive that it actually works. And the last thing I have is some statistics from the project. Is this also working, this microphone here? Yes. So this will be a bit difficult because I don't see it. Let's see. It should work now. Okay. I still, sorry. I don't have screen mirroring currently, so it's really difficult. Okay, so basically what I wanted to say is we as an open source project, we don't know how many users we have. We see that we have about 60, 70,000 unique accesses per year. Maybe 50% are kind of robots, so it leaves us maybe still 30,000 IPs are accessing our repository for the actual data, which is, I guess it's a pretty good number. And then I think this is where you see the difference between, I'm sorry. Oh yeah, this is the series where you see how our different releases are used by people. So OpenHPC 1.x was used for CentOS 7. 2.x was used with RHEL 8 and 3.x with RHEL 9. And maybe take a look at this one. So, so DNF is nice enough to tell us which distribution accesses our repository servers. So we see currently that we used to have, the blue line is in 2021, we used to have, our main users were using CentOS Linux, and then they switched to Rocky and RHEL. This is the RHEL line, and this is the Rocky line. And this is the ARMA line, so we started in 2023 also to test on ARMA, and we see that people are responding to it. And I think this one, just below ARMA, is actually Oracle Linux, so we have also surprisingly a lot of Oracle Linux users on our system using it. And yeah, I'm sorry, this is not as planned. But anyway, with this, I'm at the end, and thanks for your time, and happy to answer any questions about OpenHPC. Want a mic?
Thanks a lot. Yeah, I'm definitely one of these people in statistics. So.
Oh, nice.
Yeah, I love OpenHPC, especially like I have my own cluster running, and it was super to just get started and have something as a basis. I have one thing that is very interesting, as you are publishing as a PDF, as far as I know.
Yes, yeah.
Those guides, which is super helpful. We just created out of that for the latest version, latest release, an Ansible role. Very simple for that one, because we looked around and there wasn't much out there in the community. Like there were some approaches, but they were all like not full, not complete. And I was wondering, do you have something else apart from these PDFs already, or do you accept contributions to like have something officially published in Galaxy for a specific version? I mean, I guess it would help. It's not super important, but yeah, have basically all of the steps in a role is nice to have.
Yeah, sounds great. So yeah, what we do is pretty old school with the shell script, and people are regularly asking for Ansible. And a couple of years ago we discussed this, and then it was still not as there were more tools people were using, but it seems at this point most people using Ansible for this kind of stuff. And I think the challenge from ours, so we would love to publish something based on Ansible. The challenge from our side is how can we combine our shell commands from the documentation with an Ansible approach. So I don't know, maintaining both sounds unlikely to work for a longer time, and generating one out of the other is also kind of strange. So I'm not sure. So if you have any idea how to combine those two and have one solution, we're happy to take it, definitely. But
I could imagine like a community operated one that is basically just, for example, me just publishing that to the Galaxy and then just trying to maintain it, but it's one that's out there that's not maybe not directly suggested in any document, but is out there. And I know like maintaining both, especially if this is like something voluntary that is being done, OpenHPC, it's like we don't want to burden you guys with.
Yeah, no, but definitely, if there would be a good solution, we would
Yes.
happy to take it. So this is not something we try to actively block. We're thinking about how to have one source of the information and not two.
Yep. Cool. Thanks a lot.
Yeah, but reach out to us. Yeah.
Yep.
So I have a question regarding the queues for the batching system. Can you have those customized based on x86 nodes and GPU nodes, and it will understand that, for example, Slurm will need to have these queues created, and it will know which nodes and it will install drivers, or you need to plug in a configuration manager?
I don't know. I'm not a Slurm expert. I'm just doing OpenHPC on the level to get it working. But if you need any details about Slurm, this is I don't know. I know enough to get the tests running. So that's sorry.
So basically, the test will be just for compute nodes.
Yes.
You don't use any GPU testings or stuff like that.
Yeah. So GPU is a good point. People of course ask us, what about part of the, or include the GPU installation of the recipe. So we, in December, we were able to get 2 GPUs for one of our test clusters. So we are thinking about adding a chapter to the documentation, how to, I don't know, it will probably, how do you run the NVIDIA installation script, something like this. And then maybe, I don't know, the GPU situation will be a bit different with OpenHPC, but currently we left it out. The problem was we didn't have the hardware to validate our solutions, and on the same time it always felt like this was always really the thing. You went to NVIDIA and got a driver, and yeah, but at this point everybody's asking for it, so maybe we have to do something.
Thank you.
Thank you. Oh, wait.
I was very interested in the documentation testing part. Do you have any special code to do that, or is there any magic, dark magic?
Oh, you don't want to know. So this is all really old code, and the documentation is LaTeX based. And somebody wrote a Perl script 10 years ago which extracts all the shell commands which are marked with a special LaTeX tag. So it's, in the end, it's horrible, but it's what we have. And again, this is also, it has been discussed, why don't we use something like Markdown? Because we don't need LaTeX in the end for what we want to deliver, but nobody has stepped up. But yeah, it's...
That's so common. Thank you.
Okay, thank you.
Okay, thank you for your time. We include EasyBuild, and Kenneth always updates the EasyBuild package in our repository. So we have.
In the end, you use the EasyBuild receipts.
No. We just install EasyBuild. We install EasyBuild and Spec. Both tools are installed in our software stack, and then we let the user decide. So what we do is just a minimal software stack. What we think somebody would need to get started, and then if you want to install additional software, there are the tools like EasyBuild.
EasyBuild can rebuild your complete system, including GCC and
Yeah,
everything else.
yeah, I know.
And you manage different environments.
Yes, we try to work closely with EasyBuild at some point. Oh, we have to go.
Okay, we're running just about 10 minutes ahead of time. We'll just drive forward, and maybe we can get out to lunch a little bit early today. So next up will be František talking to us about Packit and CBS Koji. So please welcome František.
Hello all. I'm František, I'm from the Packit team at Red Hat, and I would like to tell you a story about how we are working on integrating CBS with Packit. After all, it was a really never-ending one, so we are definitely not done, but I hope we have plenty of stuff to show you and things that you can take a look, try, and see. So, what's ahead of us? I'll try to shortly cover what Packit is. I hope most of you are aware of that, but still to just frame it somehow. Then what Packit can do for you, like for CentOS in general, but then mainly for the SIGs, and then how to try it all and what's ahead of us. So, Packit, the project has a goal to get upstream, downstream closer together. We have like two ways how we are doing that. So providing downstream feedback to the upstream changes, so for the developers, and then bringing upstream releases down the stream. So for the upstream use case, we have integration with GitHub in form of GitHub application and GitLab by setting up some webhooks. And we can run various stuff for you. We are like leveraging existing single-purpose services and providing the results to you in form of like statuses for pull requests, commits on branches and releases. So you can run like RPM builds, TMT tests on top of that, VM image builds. And if you've missed the yesterday's talk and you are interested in static analysis, there is newly OpenScan Hub integration, so you can take a look at the recording. So, and in all of these, you can use the CentOS Stream targets on, so you can like you check your code or project on CentOS Stream right in upstream. But what we are here for is like with the maintainer side. So we are trying to get the upstream release thanks to like bring it from GitHub, GitLab, or from release monitoring / Anitia and get it down the stream through the distributions. We have something for Fedora and EPEL, something for CentOS, and something for the CBS / community build service. And as you might see or might not see actually, we are only covering like the public space. So Packit in general tries to be like as an external contributor. So we are trying to cover that part. So let's start with the Fedora. As you might know, or for those who might not know, to get an upstream release to the user, we need to do few steps, and Packit tries to like automate the boring stuff and let the maintainer do just the like relevant, important parts. So we are trying to, first step is to get the release to the dist-git, to the distribution git, and save the sources or to the look-aside cache. For that, we have like two modes. One is like push way and one pull way. The push one is triggered from GitHub or GitLab. The pull way uses the Anitia system, the release monitoring, to get known about the release. But the results from both of these are the same, and there's a like archive saved to look-aside cache and updated distribution git and set of pull requests or single pull request created in distribution git. Then once there should be like a CI happening on pull requests, and maintainer should take a look and approve it and merge it. Once this happens, once there is a new commit in this git, Packit can automatically trigger a Koji build, and once there is a successful Koji build, we can create a body update. If you are interested in like doing this for multiple packages, there is also a support for side tags, so you can take a look. I was mentioning Fedora, but thanks to Fedora and EPEL sharing these steps, so you can easily do this for EPEL as well. And if you want to take a look at this more practically and try to set it up for your packages, you can spend a lunch with me on the room next doors. So there will be a lunch and learn happening, helping you with the setup. So please come, and we or if you have any like other Packit related question, I'm open for that. But what about CentOS? Okay, so from the beginning of Packit, we were asked like, hey, support EPEL, hey, support CentOS. So here Christian was asking like 2 years and a half ago that, hey, support CentOS Stream Koji. And then there was an issue, hey, support the proposing to CentOS Stream. Then there was some kind of overall issue tracker for CentOS Stream support. And then Christian again, hey, support CentOS Koji. Hey, isn't that the same thing you were asking like 2 years ago? And actually not. There is a slight different, and that's the start of this whole story, that there is a slight of a mess in these names and systems, and I was from the beginning very confused what's actually ahead of us. And I thought that it's just another Koji. We already support Fedora Koji, so it's just a few config changes, and after a week or two we are done. You might see the dates, and we are still not finished. But just to provide credit where it's due, because a lot of work has been done on that. So main thanks goes to Maciej from our team that spent like months and months on this, and also Maya that joined him on that few months ago, and Nicola trying to help, as you will see on the screenshots during the last hours / days / weeks to make something presentable, and also Laura driving the whole Packit project, like from the technical side. And Christian for pushing us to this, and also it was Christian who, he's not from Packit project, but he was interested in that in a way that he has submitted the first PR that started all this work on CBS stuff. So that's him. Okay, so let's take a look at CentOS. You might see that there is like the bottom part compared to Fedora is missing, because that's the internal part, and we are not trying to touch that, at least for now. But there are few things like blurred, because there are some caveats. So what's ready now is the proposed downstream. That's the push workflow coming from GitHub or GitLab, and the GitLab as a distribution Git. So what's missing? That's the anitia part, the release monitoring, so the pull workflow. There is still some work needed from our side to do this, about the processing the events, because when we started Packit and the GitLab integration, we were thinking about GitLab just as an upstream, and so it took a while, Maciej, to actually like do our homework and fix the event-based things. I think you can check the diff, and it was, the screenshot is from the last night. So finally we've done our homework to clean up the event parsing, and we can finally take a look at adding support for this pull workflow. So that's especially useful when you don't have access to the upstream project. Then the look-aside cache, that's the tricky one, and I'm sad to say that I don't think we can do something about that soon, because the look-aside cache for CentOS Stream is like writable from internal, so it, but you might heard various things about Conflux and these projects, so maybe there will be something on that front that this will not be needed, but I don't have much of detail about that, but I hope something will happen about that, and hopefully we will not need to do this like when submitting these merge requests. Okay, but after all, it works. It can create merge requests for you automatically, with the caveat that the look-aside cache is not there, so some manual changes usually needs to happen. I just remove them from the merge request to fit it in the slide, but the maintainer actually has done some manual changes. But you are notified about the changes, and the spec file is updated for you. So at least something, I hope. Okay, and there is a documentation covering like the details and what you need to be careful about. So you can take a look. Everything is searchable through the packit.dev if you don't want to type all the. And I think we'll definitely be able to share the slides later on. Okay, so finally we are getting to the 6. Yeah, that's. It took me a while to like figure out all the services, and bear with me if I made any mistake, because maybe I'm still not understanding it all. So originally I thought that there is just a Koji and separate instance, the CBS Koji, but after a while we realized that like the CBS stuff is like a whole distribution, so it has its own dist-git. Actually, 2 of these, like 2 ways how to set up dist-git. One based on Pagure and one based on GitLab. For our automation, we've picked GitLab because it's like similar to the CentOS, so that's the way we went. And also there is a send package command, like a send package -sig one. That's actually like configured one for working with look-aside cache specifics for 6, so that's a specific one. And as far as I know, there is no bodhi. But there, I think I've heard some discussion going on. But for now, I hope this is correct. So let's take a look what we can do for you. So this is the overall. This is the ideal plan we have. You start with like upstream release and ends with a Koji build on CBS as a like final step. There are few. Again, there are few places missing, but I hope a lot is nearly done or can be like finished soon. So, Anitia, again, proposed downstream works now. Like the push workflow coming from GitLab works now. The pull workflow with Anitia, there needs to be some work done on our side. Then the look-aside cache. Actually, a PR was sent like yesterday by Nicola from our team. Thanks, Troy, he's not here, for taking a look. So if we have this little fix, then the send package SIG can upload correctly to the look-aside cache. So once this is there, we can correctly send it. And also, like authentication-wise, to be able for the Packit service to get the upload the sources to the look-aside cache, we need to be able to do that. So if your SIG wants Packit to do that, you need to give Packit fast account access to the SIG things. So get us to the SIG. That's the way how it's currently done. Maybe we can figure out another way how Packit can authenticate. But currently, Packit behaves like a regular Fedora user. Then the Koji, that won't be so hard, I hope. The missing piece here is, Alexander is not here, but she set up, not only her, but she was working on like set up notification service so we can get the events. So that should be done. So we just need to finish that on our side, the parsing. So we are notified about new dist-git commits and can react on that. So there is still something on our side to finish. But otherwise, as you can see, the screenshot 7 hours ago, and it was taken like 2 a.m. So yeah, since yesterday we are able to publish the merge request to the. There is a we produce this Python spec file library in the integration SIG namespace. By the way, if you want to do anything with spec files in Python, please take a look at this library. A colleague of mine mainly works on, because that's really handy. I can save you a lot of time. So yeah, there is a merge request coming as a reaction to the upstream release, and you can like run CI on top of that and maybe do other stuff. So how you can actually test it? So the configuration, Packit uses Packit configuration file. You might see that it's a lot of stuff, but actually this shows like if you want to both provide updates for Fedora and CentOS 6, so you can leverage concept of so-called like packages, so you can define multiple different configurations for a single Git repository. So that's why it's here. But the crucial part is like explicitly specifying like the GitLab instance, the namespace, and also like the project/SIG setup there, and the packaging tool. We used to be more magical and try to guess everything for you, but learn it the hard way that it's maybe easier for user one time set this explicitly and everything is correct and we can't just guess it badly. So that's why it's like explicitly mentioned here. So once you define this package, you define this proposed downstream job on GitHub or GitLab, and once there is a release, that's why there is this release field, this so-called package defined on the previous slide will be proposed to this Git branch for you. So just set up from the configuration side, and regarding the Lucas side cache, just add Packit fast account to the respective SIG, so we can actually like upload sources. And also you need to use our staging instance or just wait for Monday, because we release like every week regularly. So and there is a setup how to do that. Usually like staging instance follows our like main branches or all the projects, and we have stable branches for like the production instance. And every Monday we are like moving the branches. But still, if you want to play with that like locally with your accounts, because this, as I mentioned multiple times, we are using Packit's fast account, but if you want to do it on your own, there is also command line. Just install the latest, greatest Packit from, for example, this copy repository that is documented there, and get the fixed/patched send package, or just wait until it gets matched. But otherwise, it will not upload correctly and skip this step. And then there are two command line commands: Packit propose downstream or Packit pull from upstream. They are doing mostly the same stuff, because main difference on these two is that like how they are starting, if they are starting from upstream or downstream. So from command line, most of the stuff is like same, and the results are definitely same. So yeah. And what next? It's slightly on our side, but mainly on your side, because if you want to help us help you, just start using it, try it, or just let us know that you are interested in that, because we can afford working on that only if we know that there is a demand. So if you know there is this SIG that interested in this, or this set of packages that needs this, yeah, we can work on that. If we don't have this, we probably can't afford continuing this. So if you want to like fix these blurry things and continue on that, just reach us. So that's mostly all. But if you want to take a look at the related Packit topics, so as I mentioned, the lunch and learn happening in the next room, where I'll be probably eating the lunch alone. And then on Sunday, with Dan Chermak from SUSE, we are working on integrating OBS. It was also mentioned in the previous talk. So, if you are interested in that, we will be describing how it works. So, and that's all from me, and I'm happy to try to answer possible questions.
So in my mind, usually changes flow from Fedora to CentOS, and I was wondering if it would make sense to, instead of doing the Packit stuff in parallel for both Fedora and CentOS, doing a kind of pull from Fedora action instead in CentOS.
Yeah, that's a really good point. Yeah, I totally agree that for a lot of packages this doesn't make sense at all, and changes should go through Fedora and the regular just wait through the process. There are projects like that pushes changes like regularly and parallelize it, like Anaconda Cockpit and these that has like a strong CI system and like just trying to make the loop quicker. Regarding like pulling from Fedora, yeah, might make sense. We might want to take a look. Not sure if we are not like duplicating the ELN and these efforts. Yes, so but if it would make sense for some of you, so maybe we can start taking a look at that.
I have a similar use case in Hyperscale SIG, like not just pulling from Fedora, but also pulling from CentOS stream.
Okay, good to know. Thanks. We might want to take a look how this could work.
How do you generate the update? Is it customizable in a way, or do you simply use RPM dev bump spec or something like that?
Yeah, thanks for that. Yeah, I'll try to cover that like during the lunch and a bit more deeper. But there are like various steps on the way, and all these steps are customizable. We call it so-called actions or hooks, so you can like replace part of Packit's workflow and do something custom. But we are heavily using this spec file library, so we are like updating the version and also like updating the changelog. There are a couple of ways how to fill this information. Also, if you want to use like upstream release field, if you are in control of this, or you can have a like custom command that generates it. Also, like auto changelog is supported. So if you don't care about. So various ways on that way. Also, yeah, like usual stuff that like manually the maintainer needs to do. And the nice thing also on the spec file library that it can, for example, if you have like the version defined by macros, we are able also like not replace the macros, but like set the different values to the macros that generate, so transitively like updated.
Okay, sounds very interesting. I'll take a look. Thanks.
Yep. Enjoy the lunch. Thanks.
So lunch is already served. As František mentioned, there will be the lunch and learn session in Buckeye 1, so you can join there and learn more about all of this. And we will return here at 2 o'clock. We'll start our afternoon sessions with the Road to EPEL 10 with Carl George. So we have a little over an hour for lunch. I've been informed that apparently in the afternoon break we are adding some beer and Prosecco, so you know, as well as non-alcoholic beverages, so stick around for the afternoon for that. Check, check. Hey, everybody, welcome back. I mentioned before lunch, if you were in here, apparently we're getting beer and maybe Prosecco during the afternoon break. However, we are going to try, we've been running ahead so far, so I'm hopeful that we will again. we're going to try to do a group photo right out here by the couches during the afternoon break. So right after our third session finishes here, we'll go out there and do a group photo, and then you can have beer. So we'll get started here, and I'll hand it over to Carl George, who is the EPEL team lead at Red Hat, who will be talking to us about the road to EPEL 10. Welcome, Carl.
How y'all doing today? Ooh, that's sensitive. Y'all doing all right? Real quick show of hands. Who has already used EPEL 10? Good couple people. Who's already been using EPEL 9? A few more. EPEL 8? 7? Yeah, 6? 5? 4? No EPEL 4 users, the very start? I did use EPEL. Okay, a few of y'all. So, another show of hands. Who has delayed migrating to a new OS major version waiting for EPEL packages to get created? Most of the same people, right? One more show of hands. Who's delayed upgrading to a new minor version waiting for EPEL packages that got broken in the update? I know you have, Troy. You've been fixing them. So, that sets the stage for what we're going to talk about today, the road to EPEL 10. Sean said, my name's Carl George, and I'm the EPEL team lead at Red Hat. First off, what is EPEL? Based on the show of hands, a lot of y'all already know, but just in case there's anyone in here that's new, just a level set, EPEL stands for Extra Packages for Enterprise Linux. It is an initiative within the Fedora project to provide extra packages for CentOS and Red Hat Enterprise Linux, or RHEL. And the goal is to enhance that base distribution, but not replace or disturb any of the stock packages. So, EPEL packages are derived from Fedora packages. This diagram up here is roughly proportional. But it's not drawn completely to scale. There's a lot more than 90 packages in Fedora. But a subset of those will get forked off and put into CentOS and RHEL. Everything else that's not in that subset is eligible to go into the EPEL repository. If a package later gets added to CentOS and RHEL, we'll retire it from EPEL to make sure we're still not conflicting with it. Let's zoom in a bit on that Fedora to CentOS to RHEL part that I talked about, though. This is the old relationship of how things work together. There at the bottom, Fedora Rawhide is the rolling release in this ecosystem, and Fedora versions would branch off from there. Red Hat would pick a version of Fedora and then branch it off and do private development behind the firewall for a while, and eventually come out with a new RHEL major version. The RHEL minor versions, what would actually get published, would branch off from that major version branch, and then later on, at the time, the CentOS project would take that source code and rebuild it to create a very similar operating system with the goal of trying to match RHEL as closely as possible. That was generally referred to as bug-for-bug compatibility. That made a useful distribution that you could use, but it was really flawed because that meant that the CentOS maintainers couldn't actually fix any bugs themselves. They couldn't accept any contributions. They just took what they got and just built it as much as they could. And that also meant that contributing was, you really couldn't do it. Maintainers had to turn away contributions that they would otherwise like to take. You could contribute to Fedora, and then that would help get it into the next RHEL major version, but that may be multiple years away, so it was a very painful process. The good news is, we fixed it. This is the modern relationship. Now, branching to the new major version happens in the CentOS project in public. And if you saw Troy's talk yesterday, he talked about the bootstrap phase. That's that initial dotted line there. And that's when there's a lot of changes, finalizing decisions on what versions of libraries and things are going to be in the next major version of RHEL. But at a certain point, that little bit of churn calms down. And then the CentOS project says, yeah, we're releasing it now. For CentOS 10, we just had that last month. And that's where that line up there turns solid. After that point, it's functioning as the RHEL major version branch, and RHEL minor versions branch off from there and become the RHEL product officially. What that means is that now, not only are RHEL developers CentOS developers now, that means that we can finally fix bugs in CentOS directly. and also accept contributions from all of y'all. You can send a pull request and get your change in that you want to see fixed into CentOS, and then it goes into RHEL after that, within, not in years, but in months. In this way, CentOS defines enterprise Linux, which is what you'll see on all your lanyards here. It still has to follow all the RHEL compatibility rules, though. There are literal contractual obligations on what can change between RHEL minor versions, and CentOS has to follow all of those rules because it's becoming the next minor version in a short period of time. So it still stays very similar. There are a few historical problems with EPEL, though, and we hinted at those a little bit with the show of hands at the beginning. The first one is around minor versions. RHEL is very stable, but it's not completely frozen. Sometimes in those minor versions, there can be library changes that will affect EPEL packages. In the old model, there on top, EPEL only built against RHEL, and then it was also used on CentOS. That mostly worked, except for around a month, twice a year, where there was a rebuild gap, where RHEL had bumped to a new minor version, but CentOS hadn't released the corresponding minor version yet. The problem for EPEL maintainers was they had to choose if a package got broken by a library change, they could rebuild it immediately against RHEL, they would fix it on RHEL, but then break it for CentOS, or they could delay that decision, delay the rebuilding and leave it broken on RHEL for approximately a month, and then rebuild it when CentOS caught up. Neither of these was a good option. Both had downsides, and it really came down to which users the maintainer was trying to prioritize, RHEL or CentOS. But because it was only about a month period, the problem was mostly ignored, and there wasn't really nobody had come up with at that point yet a way to solve that. In the new model, the problem kind of got inverted and exacerbated. Instead of CentOS being a month behind RHEL, now it's 3 to 6 months ahead of RHEL. And there was originally when we started this model, there was no way to build EPEL packages against CentOS. They still all built against RHEL. And that longer gap between the two made the problem harder to ignore. And that's when we introduced EPEL Next. That was our first attempt at solving this problem. We launched that in June 2021 with EPEL 8 Next. And it was a way to build against CentOS only when you needed to, when you had a library difference between CentOS and RHEL. It wasn't a complete duplication. It was just for the packages that were affected by the library differences. I measured it at various points of time, and it was never more than 1%. It was usually a fraction of a percent of packages. Back to the point about how stable the overall platform is anyways. So it was a small problem, but if you had one of those packages that wouldn't install, you were upset and you didn't care that it was only 1% of packages. So the idea was that RHEL users would keep using EPEL with no changes. They didn't have to think about it. But CentOS users would enable EPEL and the EPEL Next repo, and then some packages in EPEL Next would be a higher version or higher release than the EPEL packages, and then install and work correctly. So this did solve the basic problem. It allowed maintainers to target both CentOS and RHEL at the same time, and we implemented it kind of as a bolted-on solution without disturbing anyone's existing workflows. If maintainers didn't know about it, it didn't matter. They just kept building their EPEL packages like normal. We explicitly made it optional at first. But however, the negatives were it was often mistaken for a standalone repo. We had a lot of maintainers that thought they had to build in both EPEL and EPEL Next for every update, and that wasn't the intention at all. There was a decision process about when it was appropriate to do an EPEL Next update. And another problem was that we had no way to inherit builds. You got your stack of dependencies and whatnot working in EPEL Next, and then it was working on CentOS, and then a few months later, the library change would roll into RHEL, and then it would happen all over again. And that, for a single package, that's not that big a deal, but something like the KDE stack with tons and tons of packages that interrelated, that can be a very big chore that you don't want to go through twice. And I mentioned that it was optional. Being optional meant that a lot of people did opt to not use it, and that made a worse experience for CentOS users. The second big problem historically we've had is related to RHEL major versions. We talked about with the show of hands about waiting to upgrade your OS till packages were available. That's because every EPEL release we start fresh with an empty repo. Not everyone likes that, but there's a lot of good reasons why we do that. One of the most important ones is when we branch new packages for an EPEL release, that is the time that we check if it is in RHEL already or in CentOS already. And so we have to figure out, just at the very beginning, we'd have to figure out another way to check that either continuously or point in time. So we start each EPEL repo fresh, and so maintainers have to build that up from scratch each time. We got consistent feedback from both Red Hat customers on the business side and the community members about how painful that was. About, yeah, I'd like to upgrade from, you know, say RHEL 7 to RHEL 8 or RHEL 8 to RHEL 9, but I won't do it until these packages are available. And I know they're not supported, but I still need them there. This feedback directly led to the creation of the team I'm on now, the EPEL team. That's a somewhat recent thing that was created, I believe, in 2021, right after we did EPEL Next. First thing on our team agenda was EPEL 9. We wanted to use this as an opportunity to fix that major version problem. Our original plan was that we would launch EPEL 9 Next by itself, and then build that against CentOS, and then after RHEL 9 launched, rebuild all of those packages to quickly populate the EPEL 9 repo. That would let us launch EPEL 9 just a few days or weeks after the RHEL 9 launch, which would be much faster than we traditionally had in the past. But we got to looking at that and realized there were a few problems. One of the number one things was that people wanted EPEL 9 ready on day one of RHEL 9. And we've been telling people that, yes, CentOS, you can use it, and it is a really good preview of what's coming up in RHEL. So we decided, you know, let's put our money where our mouth is. Let's prove it. Let's build EPEL 9 against CentOS for about 6 months, and then we'll switch it to RHEL 9 after that. And we thought about it. We're like, we've never done this before. Could we do this? Is this okay? And we tried it, and it worked wonderfully. We didn't get a single bug report that I'm aware of about a package that was built against CentOS that didn't install on RHEL 9, you know, a few months later. So it worked as intended, which was a real big relief and success. Because we started it about 6 months early, that gave maintainers a lot of time to add their packages to EPEL before the actual RHEL 9 launch. And by the time we reached that, in which I think was May 2022, we'd reached 5,700 EPEL packages, which is way more than we'd ever had before at the start of EPEL or even several months into EPEL. So it grew much faster, and starting earlier was definitely something we saw was, yeah, this is a good idea. We need to do more of this. All of that is just context to set up what the main subject of today is, EPEL 10. One of the big benefits of having a dedicated team at Red Hat to focus on EPEL is that we get to think strategically about EPEL for the long term. How do we improve this in the future? Not just be reactionary. No judgment to people that have worked on it in the past. They're all great people, and many of them are still involved. But when it's not your full-time job, you can only do so much. So being able to focus on it at work, we got to say, yeah, we've got EPEL 9 out the door. I'm not just going to sit here and just build EPEL 9 packages all day. That's not the best use of my time. Let's think about what's next and think ahead. So we started planning EPEL 10 basically right after we launched EPEL 9, just a few months later. And the conclusions we came to was that EPEL Next wasn't really working. It was a subpar solution. It was a bolt-on solution. And also, EPEL and EPEL Next were really just a roundabout, convoluted way to target two separate minor versions at the same time. To really solve this problem the best way, we needed to fully embrace minor versions in EPEL. While we were thinking about that, we knew we wanted to make it more intuitive than what EPEL Next had been for maintainers. All EPEL maintainers are also Fedora maintainers. I mentioned that EPEL's part of the Fedora project, so they already knew how Fedora branching worked. Rawhide is essentially Rawhide's the preview of the next version of Fedora. Right now, I don't think we've branched for 42 yet, or we're about to. So right now, Rawhide believes it's Fedora 42, while Fedora 41 is the current one. That's very similar to what we've talked to people about with the CentOS RHEL dynamic now. Like CentOS 10 right now is a reflection of what RHEL 10.0 is going to be later this year. And so we wanted to set up something similar where there's a leading branch and then trailing branches. And so that's the way we designed EPEL 10 to work. So that way it'll feel familiar to Fedora maintainers and RHEL maintainers. The real big key to this is that like in Fedora, if you have a library change in Rawhide and you're rebuilding the packages to get them ready, you don't have to rebuild them again when that Fedora version's released. You just have them prepared and then they go into the release. So we wanted the same type of outcome for EPEL. So now an EPEL maintainer can get their packages ready for a library change in the leading branch, and then whenever that becomes, like, say, the EPEL 10.0 branch, It's just ready day one for RHEL 10.0. Aside from the specific branching mechanics, a higher level concept kind of started to emerge during this planning. EPEL is a community repo, so it makes perfect sense that we would prioritize CentOS, the community enterprise operating system. An EPEL maintainer can just participate in community spaces and somewhat ignore RHEL and just work in EPEL and work in CentOS. Building a package against the EPEL 10 branch is going to always, or mostly build it against CentOS until the 5-year mark in that CentOS version reaches its end of life. Building against the minor version is going to build against the corresponding minor version of RHEL. Similar to Fedora, if you only build it in the leading branch, it won't go into the trailing branches until the next mass branch event. So later on, say after RHEL 10.1 comes out, if you just add the package in EPEL 10, it's going to be prepared for EPEL 10.2, but you'd have to go back and ask for a 10.1 branch if you want to put it in there as well. This workflow also is very similar to what RHEL maintainers do. If they just do the minimum and get the package into CentOS, it's not going to be in RHEL yet, and then it rolls into the next RHEL minor version as it gets published, or even just for a regular update, not just a new package. If they want to do that update, by default, it's go into CentOS and wait. If they need to get it into both at the same time, it's extra work. But this isn't just about benefiting CentOS. This also improves RHEL readiness. We used EPEL 9. EPEL 9 used CentOS 9 to start building packages in preparation for RHEL 9.0. In EPEL 10, we're really just extending this concept to every minor version, not just the .0. And I mentioned before that avoids the double rebuild problem that we were having with EPEL Next. So on day one of a RHEL minor version, those packages are already built and compatible and working. Enough planning. Time for the rubber to meet the road. We held an EPEL 10 Hackfest back in August at Flock. It was very successful. I see some of y'all that were there. Thanks for attending. We also used that to kick off a soft launch period. I mentioned about starting earlier and earlier. So this was before even the 6-month mark before the RHEL release. We started this. We didn't announce EPEL 10 to the general community, but we did say, maintainers, you can start building your packages and get things ready. And that was really successful because a few months after that, we officially launched EPEL 10 last month with over 10,000 packages available. So, and I helped. I did like 7 of them. No, it's definitely a team effort, and the biggest thing is the best use of the EPEL team's time is not building packages all day long. It's how do we be a force multiplier and help the community do things like this and have a lot of packages available and get out of their way and make the workflows more improved. Since that launch, even in the last month, we've already gotten over 11,000. So I expect that'll keep growing, and I'm looking forward to seeing what number I can put in this slide whenever I hopefully give this talk at Red Hat Summit and say, yeah, here at RHEL release day or whatever that or near Summit that we're now this many packages. That'll be really good news, hopefully. So that's our story so far, but this story is not yet complete. So a few events that we have upcoming. And warning, these are all just kind of projected expectations, no guarantees, no nothing. Don't take it to Vegas. Next month, we're going to do a mass branch event to create EPEL 10.0 branches. We already have EPEL 10 branches. And we'll create an EPEL 10.0 branch for every branch that already has an EPEL 10 branch. That's the mechanism to opt into that. We'll temporarily build that branch, that 10.0 branch, against a snapshot of CentOS 10, because CentOS 10 is going to move on to start having 10.1 content with the RHEL lifecycle. Meanwhile, in the EPEL 10 branch is going to move forward and start becoming EPEL 10.1, like what you would see in Bodhi. And then after the RHEL release, we'll actually switch EPEL 10.0 to build against RHEL 10.0. It's very similar to what we did for EPEL 9. And then we're going to rinse and repeat it for EPEL 10.1 in Q3 and Q4 later in the year, and for every minor release after that. So that's how we got here and where we're going. And I think I'm close to time, 5 more minutes, so just about right for a Q&A. I saw that hand up first.
You were first, right? So sorry, go ahead.
I don't know. You should ask.
Okay.
We can answer.
Yeah. Okay.
I'm next.
Okay. So how should we swing this? Go ahead. Yeah. Quick question on the general CPU architecture support for EPEL. RHEL only supports Intel 64 as an AMD 64, System Z, and PowerPC, right? Fedora
main
supports
architectures.
much more.
Fedora's the same architecture.
Arch64, at least Arch64, if not RISC-V, that sort of thing. What does EPEL support? Just the Red Hat specification.
Yeah, since RHEL and CentOS are the build root, we're just
That's it.
matching those.
Okay. Any plans to roll up into Arch? As an
AR64?
Yes.
It's already there.
It's already there, okay.
In RHEL and CentOS and EPEL.
Okay, cool. You want to update the Wikipedia page in that case. Thank you.
Yeah, you mentioned that you want Apple to be basically like targeting CentOS and you can just stay in the community space. But that's what happens if like say like, hey, you know, like I don't care about RHEL, I only care about CentOS. Hypothetically, I do care, but what
question
happens
like a bug report against the package on RHEL, but it works on CentOS, like that scenario?
if you get bug reports against packages only on the like branched like EPEL 10.0?
Right.
Well, I cannot test and I cannot repro.
That's why I tried to couch that statement a little bit with somewhat. You can somewhat ignore it. It's not really appropriate to just say, yeah, I'm ignoring all. Similar to a Fedora maintainer, you can't just say, I'm ignoring all bug reports for Fedora 40 because I only care about 41. That's not really appropriate. But it does affect how you prioritize things and how your outlook. The general approach there would be adding more co-maintainers. That's something we don't do enough of. We have a lot of packages with a single maintainer, single point of failure, and there's too much of an attitude of owning a package, which isn't real. They're Fedora packages. They're not yours. You're just the maintainer right now. And we need to add more co-maintainers to spread that workload out. Someone may be on vacation. They may move on and not have as much time for EPEL. So adding more co-maintainers, I think, is the best approach for that. Where's the next question?
So this is more of a comment than a question, and a thank you. In your talk, you talked about your EPEL team, and meaning the Red Hat EPEL team. I just want people to know that in the talk, it sort of sounded like you did everything, and you guys did do a lot of things, but you didn't feel as a community, as sitting back in the EPEL community, it did not feel like you were forcing it down our throat or anything. He came to the committee, he's in the teams, and says, hey, I have this proposal. What do people think about that? They took feedback and stuff. I just want people to know that Carl and his team, Diego and James, they worked with the community. It felt like a community thing, even though we knew you were getting paid by Red Hat. We all did. This was a community
Evil
effort.
paycheck, right?
Yeah. And I think you guys did this in a wonderful way, and
I
continue to
appreciate
do
you
so.
saying that, Troy. Thank you. Yes, this idea definitely wasn't a by decree. This is my way or the highway. We're doing this. I said, here's my idea. This is what I would like to do, and here's why I think it'll work. And we deliberated on it for what, a month or two before we even took a vote. I think.
Yeah.
Maybe longer.
Yeah, and it was. Yeah.
Well, that was more the planning. That's at one point we said, yeah, we'll work out the details, but yes, this is the direction we're going, and took a vote on that.
Yeah, the detail of 10.1 versus 10_1 or till.
Yeah.
Boy, that was a fun debate.
All of the bike sheds.
Any
other
more
questions?
questions or praise for Carl?
Oh, yeah.
So for the Rust packages that we maintain in EPEL, we usually need to, so for EPEL 9, we usually need to hold back some updates because we need a newer compiler version, and those are only shipped with RHEL minor releases. And so that will really help us with EPEL 10 because we can just keep submitting the stuff to the leading branch, basically. And what I wanted to ask is, I mean, similar to the question that Michel had, we'll probably just submit the stuff to the leading branch and let all the other branches inherit from that. and really only
Totally valid approach.
yeah, and really only push stuff to the branched Apple, to the point to the minor branches when we really need to push some bug fix or something. Is that
It actually matches the Fedora update policy and the Apple update. Well, the Apple update policy hasn't been fully rewritten for this model, but it's worded very similar to the Fedora update policy. So that kind of mentality is totally valid and accepted.
yeah, just wanted to make sure, yeah, if that's okay.
Focus on the default experience, building against CentOS, and then touching the minor version branches if necessary, which also is very similar to RHEL maintainers. I mentioned there's extra work for them to go ship an update in an existing shipped minor version. There's extra red tape there. The default experience is get it prepared for the next minor version. So taking the same approach with EPEL is totally valid and honestly desirable.
Yeah, we just have a different approach in Fedora because most Rust packages unship to users. So we have an FESCO approved updates exception, so we can push the library updates to all branches. So we're going to handle Apple 10 a bit differently there.
If you think it makes more sense to be able to ship those updates to each of the Apple branches as well, we can definitely talk about that. I'm not opposed to it if you think it works better.
We'll see.
Yeah, we have Apple policies, but they're all written by people, and we're people that can change them. We make adjustments all the time. Someone comes up with an idea that says, hey, this part of this isn't working right, or we should carve out this exception for this, and we change those. Like they're living documents. They're in Git. You can send pull requests to propose your idea about how to change the policy, and we can talk about it from there. Sometimes one of those good ideas is, I see where you're going with this, but I want to see how you would word it in the policy. So send a pull request, and then we'll discuss it. Not unlike the Fedora Packaging Committee.
Yeah.
Carl, question. I know that we already discussed that, but it was not mentioned in the talk, so maybe if people are interested. How long will the minor branches be supported on the mirror network? Because you know where I'm coming to with my question for CBS. We have at the moment SIGs like Hyperscale needing to rebuild against EPEL. And for them, if they build against CentOS Stream, they will follow the main. So that's not a problem for them, but some other SIGs are also rebuilding against and for RHEL content from CBS point of view. I just have to know in advance how many different mirror URL I would need to catch and follow based on that. Is that automatic? Or
So we're not trying to keep all the minor versions around forever. We talked about RHEL's EUS product as part of this proposal and explicitly said EUS releases are out of scope. For anyone unfamiliar, that's extended update support. That's where you say stay on RHEL 9.4 after 9.5 comes out, and even 9.6. There's certain minor versions that get longer updates. We left that out explicitly from the proposal originally. It's set up in a way we could add that on and leave branches open longer if we wanted to, but we're going to retire those releases. Basically, we'll retire 10.0 after 10.1 comes out, or rather, after the RHEL 10.1 comes out. So most of the time we'll have two of them at a time, like 10.1 and 10.0. For a brief window, we'll have 3, and then we'll go back to 2. So that's when they'll close up. It will be a little bit more storage space on the mirrors, but not all of them the whole time.
And I know that you will be using some specific macro in the repo file just to point to that specific major.minor release. But that means that people who are eventually on older RHEL version at one point, the DNF macro will point to a repository that doesn't exist anymore, right?
Yes, we're hoping that we can get that set up in Mirror Manager to point to archive releases.
Okay, thanks.
Yeah, so that makes it where even if you're even outside of using the EUS product or not, if you're just on an older minor version, you're not pointing at the latest EPEL that's built against the latest. That's another problem we've had historically. If someone chooses to stay on an older version, they might have some EPEL packages that stop working because they're targeting the latest minor version of RHEL. This will make it where they'll not going to get updates for those older packages, but they'll at least keep using packages that work. They'll keep if you're still on RHEL 10.0, you'll keep using RHEL 10.0 forever until you upgrade to 10.1.
Okay, thanks a lot.
The archive, it's the Fedora archive, so all the releases that are no longer maintained get moved to the archive. It's a different rsync module in the mirror network, so a mirror operator could just maintain the current releases, or they could also help mirror the archive releases separately. And people on end-of-life releases, even though they're not updated anymore or maintained, they can still get the packages and install them at the state they were when it went into life. There's one more in the back.
how will you deal with those stable branches where if you do an bug fix in 10.0, but then you also have release versions that might be updated and YUM or DNF might get confused? What's the best practice on that?
I'm not sure I follow about confusion.
Let's say I'm a maintainer of a package and someone submits a bug report and basically CentOS Stream is on sort of the 10.1 version, but I want to do a bug fix on 10.0. But then also, when they do a DNF upgrade, do they regress to the old version, or sort of, how do you deal with that?
They're separate repos, so like the leading repo is going to be just EPEL/10. It's right, it's 10.0 before we mark it as 10.0, and then when we actually we'll create a 10.0 directory, and then the 10 repo is basically 10.1 at that point. So the different users are pointing at different repos. If you're on CentOS, you'll be pointing at that leading one. If you're on RHEL or an older specific minor version, you'll point to that specific one. So doing an update in a specific branch will only go to that repo, not to both of them.
Right, but on finally installed systems, they might have release version 5 installed, and from 10.0 that might be different than the one from 10.1.
Yes, yeah, it should be a normal upgrade path, though. Still not sure I'm following the question.
Yeah. Yeah, so essentially, I think two users need to run distro sync to sort of make sure it gets from the right repository.
They shouldn't. Generally, maintainers shouldn't be downgrading the package. If they do, that's a mistake that should get fixed with either, last resort is a package epoch, but you could also just, a lot of times just bump the release higher.
Right.
The version and release should always be increasing. I'm pretty sure that's in the general Fedora packaging policy, which EPEL also follows.
Yeah, okay, so it's basically on the maintainer to make sure it doesn't happen.
Right. So is the question around, like, if you only did a fix in the 10.0 branch and the 10.0 branch got ahead of the 10
something like that
branch? Okay, I see where you're going with the question now. Yes, we need to address that in the EPEL packaging guidelines a little bit more, I think. We definitely want the default experience to be putting that fix in the EPEL 10 branch first, and it's somewhat similar to RHEL maintainers. If they do a fix in, say, RHEL 9.5 right now, it's on them to make sure that they don't break the upgrade path for users when 9.6 lands. They have to do it in 9.6, rather, in CentOS right now. And if they don't, then they're making a mistake in their job, and they need to fix that and keep the upgrade path going. Same thing for EPEL maintainers. We want that upgrade path to keep going on. So that is a risk. I see what you're saying, and I'm going to make a note of that and make sure we cover that in our policy.
Yeah, I just want to wonder if you could make some automation checks that sort of verify that basically EPEL 10 is always newer than minor versions.
I like that idea. Let's expound on that more later. Come help us build that.
Can't promise anything, but thank you.
Thanks, Carl. Thank y'all.
All right, we will move right into our next talk. All right, well, yeah, the popular topic to talk about, Our next speaker. The whole time? Yes, historically of the docs. I did a lot of docbook work, and then Mallard is what I worked on. So yeah, yeah, I haven't blogged in a while. It was a good blog. Thank you. Thanks. It's bringing something up. Just about to get set. Our next speaker will be Nofar Alfasi. Say that right? Talking about automating CentOS provisioning with Foreman. So as soon as she's got this going. Mouse is on the projector. Okay. If you're ready, then everybody please welcome Nofar.
Yeah? Okay, so hi everyone. Thank you for joining me today. Today I'm going to demonstrate how Foreman can simplify provisioning CentOS in your infrastructure. And this is my second time here in CentOS, and it's great to be back. Last year, one of my colleagues, Shim, introduced Foreman's capabilities, providing an overall overview of the project. And this year, I'm excited to take things a step further by diving into provisioning workflows and showing you a live demo in action. So whether if you're managing a small-scale environment or you're handling large-scale developments, Foreman offers powerful tools to simplify and automate your provisioning process, making your work easier and more efficient. Okay, so hi again, my name is Nofar. And I've been working in Red Hat for almost 3 years now on the Foreman team. My primary focus is on provisioning and its various aspects. And I'm also maintainer of the Foreman Ansible plugin, which enables seamless integration of configuration management into Foreman. And in addition, I moderate the Foreman community demos, which are being held every 3 weeks, where we share the latest developments with our communities and we foster knowledge sharing and collaboration. So a short agenda for today. We'll have introduction, what is Foreman, then we'll talk about some of its core features, then we'll explain what is provisioning with Foreman, how it works. Then I'll try to convince you why to automate CentOS provisioning with Foreman. We'll have a live demo, and then we'll talk about recent features we've been working on, like Secure Boot and IPv6 support, the end questions and answers. Okay, so what is Foreman? Foreman is an open source, web-based system for provisioning and managing your servers. Basically, it's the perfect tool to manage your servers because it has so many powerful features, which we will cover in the presentation. It supports wide range of operating systems, including CentOS. It's centralized management for all of your servers. It automates your provisioning tasks, reducing manual efforts, and it improves consistency and reduces errors in deployment because everything is automated. Okay, so some of the Foreman features, we have the provisioning, configuration, and monitoring. So for provisioning, we have the bare metal. We support some virtual servers. We'll cover that next, and some cloud instances. For the configuration, we have plugins for Puppet, Salt, and Ansible. You can automate everything from Foreman. And for the monitoring, we have the facts, reports, statuses, dashboards, etc. Okay, so if we're talking about provisioning, these are basically all the components that we cover for Foreman. So we talked about bare metals and VMs. We also have the PXE booting, the grep2, BIOS, UEFI. Everything is supported from Foreman. We have the subnets and domains can be managed from Foreman. Same goes for DHCP and DNS services. Multiple operating system support and the templating system and registration. And the list of the computer resources and profiles supported by Foreman, as you can see. Okay, talking a little bit about configuration. So we already mentioned Puppet, Ansible, and Salt. We also have host groups, which is basically a set of host groups. We also have the parameters, which is basically the same idea. You can define the parameters on the host groups, on the host, on basically each component the Foreman has. So it can be DHCP, it can be DNS. Each one of them has their own parameters. Authorization, which means that you will have multiple users in Foreman and not all users can perform the same actions. So for example, some user may have permissions to execute Ansible roles and to see them and to edit them, update them, and the other user may not. It all depends on your needs. The last one is organization and locations, which also I'll cover in the demo, but basically it means that you can divide your Foreman into smaller pieces if you don't want to control all your servers in one place. That's possible via organizations and locations. And last one is configuration and monitoring. So we have the facts, the reports, the statuses, the dashboards. I'll show a little bit about it in my demo, but basically it's some visual tools from Foreman where you can monitor the statuses of your server. Yeah, and some plugins that Foreman have. For example, remote execution is a plugin that works together with Smart Proxy, also something I'll cover up next. We'll have the discovery. So Foreman Discovery is a tool that allows for the automatic dedication and registration of physical hosts in Foreman. So that means if you want to discover a host in your network, Foreman can do it for you automatically. Yeah, and boot disk, webhooks, etc. Okay, so here's an overview of Foreman architecture to give you a better idea of its integration points. At its core, there's the Foreman server, which orchestrate provisioning tasks. Compute resources integrate with virtualization platforms, and all of this works together to manage your host lifecycle. We have the smart proxies that extend Foreman's capabilities to remote networks, handling tasks like Pixie booting and Ansible jobs. And I would say that smart proxies are mostly useful in large distributed setups where Foreman needs to manage services across multiple locations. So we'll dive more into it in the next slide. So as I mentioned, using a smart proxy in Foreman provides numerous advantages, including improved scalability by distributing tasks such as DHCP, DNS, TFTP, and config management tools like Puppet or Ansible across multiple proxies. It reduces the loads from the main server, basically, and it enables network segmentation, allowing Foreman to manage remote or isolated systems without requiring direct communication with the central server. And the smart proxies also enhance performance by reducing latency and providing faster response time, especially for provisioning and Pixie booting. Okay, so how does Foreman handle the provisioning? So first off, we need to create a host in Foreman. And we'll define all the specification for this host. So that includes which operating system we want, some network configuration settings, etc. Then we have the provisioning templates, which is predefined templates to automate the setup. For example, we can use the Kickstart or Precede. OS installation, Foreman will take care of installing the operating system automatically from the templates provided by Foreman. Configuration management, after the host is all set up and running, we'll have the Ansible or Puppet jobs that will be post-installation configuration. And that's it. After that, the automatic setup, once configured, Foreman will handle networking, partitions, and installation for you. Okay, so if I haven't convinced you already, why to choose Foreman for CentOS provisioning? So as I mentioned, it centralizes your management tasks, making automation and consistency effortless. With built-in integration for Pixie Boot and Kickstart templates and more, you can deploy a system reliably. And plus, it scales beautifully across physical, virtual, and cloud environments. Okay, guess this is time for the live demo. Sorry about that. Can you help me? Where's the settings? Right there. Oh, left. This one? Yep. Okay. I don't know what to. Wait, maybe. Okay. Sorry for this. The demo I need to mirror. Okay, great. Okay. So I will log in into my Foreman server. This is how my dashboard looks like. If we were talking about monitoring. Wonder, yeah. Okay, I have an error for some reason. So let's make it disappear. You can remove some of the dashboards if they're less relevant for you. Just wanted to show you that. Didn't expect any errors. So let's ignore that. Okay, so what do I need to do the Foreman provisioning? So first of all, I need to create a host, but to create a host, I need to decide which operating system I want to install. I will use the search bar here. For this demo, we're going to choose the CentOS Stream 9. And this is the operating system I already have defined in Foreman with a major version. And architecture, the partition table, I'm going to use the Kickstart default provided by Foreman. The installation media, that's also something I already have defined. Just the two of them, the rest of them I will define by myself. So this is the installation media. And this is basically just a link from where to download the operating system. Okay, going back to the operating system, you can see here the templates that I have for it. For example, for the provisioning template, I'm going to use the Kickstart default. If I want to use grab2, I have the Pixie grab2 template here defined. And that's it. Here are the parameters. I don't have anything, but I can add if I want. Okay, so this is the operating system I'm going to use. After that, I want to check that I have all the services needed up and running. For that, first of all, I will create a new organization. Let's call it CentOS Connect. Okay. Here I could have defined some of the things, but I will do it after. Okay, so I was going to show you the smart proxy. Smart proxy is not created. Let's create one. No, you know what? Instead, let me use the existing smart proxy I already have. The reason I want to do that is because I already have the services up and running. So for example, you can see I have DHCP, I have Ansible, I have DNS. And if you ask yourself how to do that by yourself, there is a tool called the Foreman installer, which is just a command line tool. You run the commands and with the values that you want, for example, the DHCP server address that you want in DNS, and Foreman will set everything up for you. So I already have this set up, which is great. So I'm going to use this existing smart proxy. And I just need to add the new organization I created for it, so it will be accessible. Okay. Now I will go back to the CentOS Connect. And I have the smart proxy up and running. Great. This is the first step. After that, I need to create my host. So I will go to All Hosts, click on Create New Host. You can see here the name is a random name. Let's give it CentOS Connect demo. And it deploys on bare metal. No Ansible roles I want to give so far. let's set up the operating system, the architecture. We said we want to choose the Stream 9 version. Media. Okay, now I don't have any medias available. This one I forgot, so I will go here. Okay, it's not accessible through my CentOS demo organization, right? Okay, so let's fix that. Okay, I added the organization. I wanted to create a new one, so I will have the opportunity to set up everything from scratch, but it costs some issues. Okay. So starting again. Let's just keep it, the name it automatically originated for me. And okay, now I gave it the partition table, Kickstart default, and the pixel loader want to choose is the grub2 UEFI. Okay, I'm going to generate a password. And now I will click on resolve to see that all the provisioning templates are correct. Okay, for the interface, let's leave it for now. And let's go to the Virt manager to create the host from there. I'm going to create a new virtual machine. CentOS Stream 9. Let's give it a name. After that, I will use it for my host. And the only thing I need to take care of here is the firmware should be UEFI. And I wanted to boot from network. Okay, that's great. Now I needed to do that because I need to use the MAC address here. So let's change the host name so they will be the same. And if I go here to the interface, I need to use the same MAC address. Okay, so one thing I didn't do is to take care of the domains. Okay, so let's create a new domain. Okay, I'll go here first. And let's give it CentOS Connect, a new domain. And I need to choose the DNS proxy. Right now, I only have one smart proxy, so I will choose it. But if I had multiple smart proxies, I could have picked one. Okay, let's see what else I didn't do. Subnet. Right. So let's create a new subnet. Name of the subnet will be CentOS Connect. Protocol IPv4, the network address will be this one, network prefix 24, network mask generated automatically. And I will give it the gateway, the DNS. For IPAM, I would like to choose DHCP. I want to manage DHCP service here. Start of range, end of range. If you have any questions about the fields, please let me know. Yeah, and everything is okay here. For the remote execution, this is the smart proxy. I chose the localhost that I'm using. The domain we just created, CentOS.connect domain. DHCP proxy, everything is going to be under localhost, but as I mentioned, you can have multiple proxies and then you can play with it. And no parameters and location organizations already been taken care of. Okay, let's click submit. Okay. So I need to refresh the page, unfortunately, because I just created these two. So again, third time's a charm. I give it the name, you're already familiar with it, which is great. Again, I'm going to set up all these fields. This is a great example why you should use host groups, because if I would have chosen to just create a host group, I would have all these fields already set up, and I didn't have to do it multiple times. Grab two UEFI, great. Okay, everything is good. Now just the interface, and that's it. Okay, the MAC address. Now I have the domain we just created and the subnet. Oh, now I see I've misspelled it. Never mind. And the IPv4 address was being taken care of from the DHCP service, which is great. For parameters, I just want to add update package parameter. Update packages. It's going to be Boolean. I'm going to set it to false. The reason I do that is to make the installation process faster. Okay, I clicked submit to create a host. Let's give it a second.
You're doing the whole demo with only one hand. Impressive part.
Yeah, but I think my computer doesn't like it. It needs both ends, maybe. Okay, so let's see what's going on. Let's debug it. Everything looks good. No, but like I did it on purpose. Okay, so you know what? I'm going to use the host groups. Let's do it one more time using host groups, and hopefully that will work. Basically, in the end of the demo, I just wanted to show everyone that it works. So, worst case scenario, it won't work, but you all have to believe me. Yeah, we're building trust together. It's okay. Okay, so this is a host group. I'm going to do the setup from here. And then I'm going to try to create a host again using this host group, but everything will be like already configured. So it will just take a sec. And if you're familiar with the fields, it's because we already set them up from the host page. Thanks. Oh, wow, James, good catch. You too? Why? Because there's always things going wrong. Okay. Okay. So update packages. Sorry. Let's see if it will create a host group. Yeah, the host group successfully created. My host is not created yet, but I want to debug it. So. Okay, create a host. I'm choosing the host group, and you can see all fields already been set up for me. The only thing I need to take care of it is the interface. And no, the virtual machine has not started yet. No, this one I need to. Well, I need to click on begin installation, basically, but yeah. Foreman will take care of the rest. And you see, I already have the domain, the subnet, and the IP address. The only thing that is not correct is the host name. Now that I think about it, I could have done something else, but never mind. Let's see if that would work. It looks like it's all okay. Well, my first host was created. It took a while. I will cancel this one. I'm not sure why, what happened here, but I can show you the fields here in the details. You can see, for example, the provisioning templates. You can see the domain, stuff like that. Everything is set up correct. I have no idea why it took so long, but let's go back to the libvirt machine. That's it. I'm going to click on begin installation. And hopefully the grab menu will load up. Yeah, okay, so this is PXE booting, so it starts PXE over IPv4. And yeah, let's give it the Kickstart default grab to PXE grab 2. It supports IPXE, not for everything, but yeah, we support IPXE. Okay, so I now remember I didn't take care of the firewall before the demo, so let's see if that will work. No, let me do it for just a sec. Okay, I need to change to trusted, the interface. Okay. Okay, let's give it some time. I'll go back to my presentation and we'll get back to it later to see the results. Need to join again. Okay, good enough. I did a mistake. Okay, let's try it again. Maybe if I disconnect it for a second. Okay. Yeah, okay, so let's talk about recent advancement we've been working on. The first one is the Secure Boot implementation. We talked about Secure Boot today a little bit. Secure Boot helps you to ensure that the integrity during the provision process, that your operating system is signed by like authority that you trust. And we have Secure Boot supported on VMware and libvirt compute resources in Foreman so far. And the second feature we've been working on is IPv6. Recently, we added support to help you provision your host in a pure IPv6 network using PXE. And for the full IPv compliant, the dual stack support is planned for the future release. So for the Secure Boot, from the user side, it's the easiest thing to do is to provision a host of the same operating system as your smart proxy. For example, we showed in the demo CentOS 9. So if you want to provision a new machine with Secure Boot enabled for the CentOS 9 operating system, you don't need to do anything basically from your side. But in case if you want to provision a different operating system, for example, Fedora, you will need to create the grub and the shim file by yourself, like basically to copy them from place you trust and to place them in a designated directory in Foreman, as shown in the picture below. And then what will happen is that Foreman will take care of creating a new directory for your specific host with the necessary boot files. So what happens like behind the scene is that the DHCP server will have to retrieve this grab and shim files from this specific location for the host you're creating. And I think that's it. So let's go back for a second to see delivered machine. It looks like it's stuck. Okay, we can try to boot it again, and meanwhile we'll have the answers and questions. Yeah, so any questions?
Does it handle multiple releases at the same time? For example, I'm doing something like this myself, but I'm deploying Rocky and I'm deploying RHEL. But for secure boot, I have the issue that the PXE executable either signs for Rocky or for RHEL, but not for both.
Yeah, so like on the Foreman side, there's no problem with it. The only problem I can think of is from DHCP server. You will have to give it a different location for the shim and grab files. So that could be tricky, unless if you have multiple DHCP servers, you can manage them like from Foreman with multiple smart proxies. But yeah, I can think of any other way to solve it.
And the other question is, does it support using HTTP or HTTPS to load the kernel and the initRD, or does it still use a TFTP?
Yeah, you can do both. I didn't show that, but when you choose the bootloader, for this demo, I chose the grub2 PXE UEFI. If you want, you can also use the HTTP or HTTPS for secure boot. Yeah, this is possible. No questions? Okay, great. Let's see one last time about the machine, because, okay, I see it is stuck somewhere. Unfortunately, I wanted it to do the whole provisioning process and then show you also how Ansible and Puppet can be executed on the machine. And fortunately, I wasn't so lucky, so, oh, maybe next demo. Okay, so upcoming events. We have a booth session in FOSDEM for the Foreman community. If you would like to join us, we'll be happy to see you there. We also have a designated room for Foreman talks in Config Management Camp. That's it. Thank you. These are all the contacts you need to contact Foreman and me. So thank you for your time.
All right, next up will be Michel. He's up there. We'll have one more talk before the break. As a reminder, we're going to do a group photo at the break, and then we're going to give you beer. Yes. I don't see Carl in here, so there's a real risk he's finishing all the beer right now without us. All right, our next speaker, oh, you ready? We can just start. We don't have to wait until the. So Michel Lind is a production engineer on the Linux team at Meta, and he'll be talking to us about POI tracker and eBranch to go from ELN to EPEL 10. So please welcome Michel.
Hello, everyone. Thank you for coming. I'm glad I can present this from my Linux VM instead of from macOS because that'll be a bit embarrassing. So my talk will be about tracking and bringing up packages with POI tracker and eBranch. A bit about me. I've been a Fedora contributor for a long time. I mostly do packaging. Lately, I've been involved in some policy-making groups. So like I'm in the EPEL steering committee and FESCO. And I've recently been working on EPEL and CentOS Hyperscale SIG as part of my day job. So we have had talks from Troy yesterday about CentOS Stream and like from Carl earlier today about EPEL. So you would be familiar with this because this is Carl's diagram that I stole, that I borrowed. This is the flow from Fedora, Rawhide, and ELN, becoming Fedora, and then Fedora being branched to CentOS Stream, and CentOS Stream being branched to make RHEL. We have not talked much about ELN, and there is no talk about ELN on the schedule, so if you're not familiar with it, I'll give a brief introduction. So this is just like what we talked about. Fedora is released very often, every 6 months. CentOS Stream branch every 3 years. RHEL gets cut from CentOS Stream. But what is ELN then? Well, the naming is tricky. ELN initially was El Nino because Nino is a boy, and you know, like this is like not like a grown-up OS. It's both enterprisey and also saying like, hey, this is a work in progress and you're not really supposed to use it for production. Nowadays, we just think of it as Enterprise Linux Next, and I cannot spell disclaimer. This is not related to anything that might have the same name, so if you look it up, don't get confused. So it's basically Fedora Rawhide rebuilt with Enterprise Linux macros. So basically, instead of finding out at branching time, like, hey, you know, like we need these 2,000 packages from Fedora, and oh no, like 100 of them don't build because there are sub-packages that like require optional features that we don't have in CentOS or similar issues. So you want to be ready at the beginning. So like, hey, if we rebuild this Fedora package for Red Hat with Red Hat definitions, will it build or not? So basically, whenever there is a build on Rawhide, and that package is meant for ELN, for inclusion in CentOS, it will get rebuilt for ELN, and you get notified if it breaks. If we look at how many packages are in ELN, basically it's roughly, well, ELN right now targets what will be CentOS 11, but CentOS 10 branched not that long ago, so as you can see, the number of packages, the number of source packages are basically about the same. And it's about less than 10% of what's actually in Fedora. So how do we use ELN? Like, I will hand wave a bit here because I work mostly on ELN XS, which we'll get to in a bit. And like Red Hat engineers normally like define what will actually get into ELN core itself. But basically, there's a project called Content Resolver Input, and you can define like, hey, these are the packages I want, and that package and its dependencies will get pulled in. But you know, like I'm a community member. Like I don't really like participate directly in releasing CentOS Stream. Like, how about EPEL, which we talked about recently? Can we use ELN to actually get ready for the next upcoming EPEL release? And the answer is yes. As of this morning, like, so this is slightly updated numbers for Carl, like we have 4,100 source packages in EPEL 10. I cannot run this query to tell you how many are in, like in ELN XRES, which is the equivalent of EPEL, because FedRQ does not support it yet, but we can use curl to see like, hey, if I look at the mirrors, how many packages are there? It's like, well, I see a table with 1,276 rows. So yeah, we have 1,276 packages that are continuously built every time they are updated in Fedora to see if they will actually build for RHEL. And if you browse there, you can see like this is just like the first page. Yeah, like a network manager Open Connect, if you need to run like an enterprise Linux desktop, that's now in EPEL because it's not in EL10 anymore. So it's now built as part of ELN Extras. So ELN Extras, it's an extension of Fedora ELN. Community members get to define like what is going to go there. So if you need your package in EPEL and you want to make sure that it will continue building, you add it into an ELN Extras workload, and it will be built for you. Most of this will be eventually like destined for EPEL. There are some additional definitions that, for example, like we have one for the Hyperscale SIG, which is like we want to get it built, but we know we cannot maintain it in EPEL, so it will go to a different location. And this is an example of what the workload look like. It's a YAML file, and most of these are documented, and you just have to basically follow directly. Like this is a workload, the version is always 1, and you give it a name. Like this is what we use to track what we need to actually run the mailing list infrastructure. So we need Mailman itself, and then we need like 2 front web interface packages, and they will pull in like all the other dependencies. So it's a very minimalistic format, right? Like it tells you like what packages you want to bring. It doesn't say like, like, hey, who needs this package, and like why do you need this package? What is it for? Like this format is not meant for that. So I mean, like in computer science, if you have a problem, you can just like solve it by having indirection. So this is my internal format that POI tracker uses. It's a JSON file. Don't worry, I'm not mad. I'm not writing this by hand. So basically, I can say, hey, like as you can see, like does my pointer show up? Yeah. So this is a package that we see earlier in the YAML file. Like I want like a Python 3 mailman web, but this one will also tell you which source package it comes from, and you can overwrite like who is responsible for each package, and you can say like why do you need a package, and the format is extensible, so you can define more keys later on. So the idea is that you have a separate repo, and you can iterate on it faster, and whenever you're ready, you can then like publish it and submit a pull request to get it added to the content resolver. So you can decouple the process. You can keep your private repo private, and like basically like if you're in a company and you have internal teams that require different packages, you don't necessarily want to expose those team names and why they need a package publicly. And it lets you track additional metadata, like who needs this package, why do they need it, and if you care about like branching packages for EPEL, you actually care about the source package name. You don't really care about the binary package name, which is the one you need to put in the content resolver. Yeah, you can track this in a separate repo. You can basically iterate faster, because only when you're ready do you have to submit a PR, and then there's a back and forth until it gets merged. And as I said earlier, like of course you don't want to write JSON by hand, because that's torture. So there is a CLI, and you can say, hey, I want to make a new inventory file, and this will produce basically the file I showed you earlier. And I want to add source RPM to this inventory, And from that source RPM, I want to track only one binary RPM and override the POC. And then we can dump the content resolver YAML file from the inventory. And it will give you exactly what you can submit as your pull request. So, I mean, this is the first use case for POI tracker. Basically, like we want to track it in ELN Extras. The next step going forward will be like, hey, you know, like I have this package. No package is an island, right? Like your package will require like 50 other packages to actually build. And if you are working in EPEL, you know that a lot of these packages are also in EPEL and maintained by the community. So even if you pay Red Hat for support, you cannot just like, hey, you know, like open a support case and say, this package is broken and I need it fixed. So you might want to know like, hey, you know, like what is the health score for my package? Like, hey, your package is depends on like 20 packages in EPEL and like 5 of them have CVEs that have been open for 5 months. Oh no. You know, EPEL is a community distribution. If someone's not fixing your bug, you probably should fix it yourself. And yeah, so this tool lets you keep track of what package you actually care about, and then we can basically just do a transitive closure in the near future to actually say, oh, these are the other packages that it pulls in, and evaluate how healthy they are. I'll be extending it later this year to also track non-RPM artifacts. Like, hey, you know, like I care about this package. The upstream is a pip wheel on like pypy.org. And like, oh, is there like a new version? Is there a security update? Or we can extend it to support other downstream format as well. DPKG probably will not happen this year because I like Debian. I'm not paid to work on it, but we do have this internal format that we might want to support. Okay, so after this, you add your package, you get it added to ELN Extras. It's built every time there is someone pushing it for rawhide. Now what? How do we get from that to EPEL? So packages that are in ELN eventually, basically, like that gets branched for the next enterprise Linux release. So right now, ELN tracks EL11 and CentOS 10 and EPEL 10 have already branched. ELN extras, right now, nothing happens to them. It's still decoupled. When we started ELN extras, we initially planned on like, hey, it would be nice that when EPEL 10 branch, we can automatically branch packages we're already tracking for extras. But it gets a bit tricky because packages have maintainers. The maintainers might not be the ones who care about ELN. And you know, like we don't want to branch packages without permission. So this hasn't happened, but at least, hey, we made sure that those packages can build when they're eventually branched. So we might try to do that for EPEL 11. We have 2+ years to do it, so fingers crossed. But yeah, it's still useful, right? At least you know your package is built. And the dependencies built as well. So this is another tool that's kind of related. It actually predates POI Tracker by 2.5 years. I use this to bootstrap my EPEL 9 packages. So like everything, right? Like you write a tool because it's a force multiplier. It speeds up things that you otherwise would have to do tediously by hand. So if we look at some numbers, these are the number of body updates that I do. It's hard to just get to look at like how many new packages you do because when you're bootstrapping a new release, like the updates basically get released automatically. But basically, over the past 3 years, these are the number of body updates pushed for EPEL 9 and EPEL 9 Next. And for EPEL 10, these are the numbers since August of 2024. It's a huge number. it's slightly misleading. The 347 updates, a lot of them are Golang packages that we then decided we are going to give up on packaging Golang source libraries for EPEL 10 because the bootstrap got stuck on having to bootstrap Java. Because Google apparently used Antler, which is in Java, for actually for building some of the core Golang X packages. So we got stuck there. But yeah, eBranch has a CLI as well. Don't look too closely at this because I'm in the middle of refactoring. But basically, you can say, hey, you know, like what are the build requirements for this package? And once you have a transitive dependency, give me a chain build so I can basically build all of this with as much parallelism as possible. And it also helps you like, hey, you know, like this is EPEL, I don't have ownership on all these packages. Help me file Bugzilla requests asking for the maintainer to branch it for me. Some caveats, like I started mentioning earlier, it's in the middle of major refactor. The first version worked, but the dependency resolution was really slow because I was shelling out to a repo query, which is not great because DNF for API is, if you have tried looking at it, it's a bit painful to use. It's not very Pythonic. So if you try to program with Python, it's the easy way out is to just shell out, but then it's really, really slow because DNF4 is also written in Python and you have to bootstrap like a cold starting a Python program. So now it's been ported to use FedRQ. It's much faster, but the internal format changes a bit and it broke serializing the output to disk, which means the CLI doesn't work. But it's fine. The Python API still works. And I will basically, I'm blocked on releasing a new release until I have time to finish this. I'll move the file format to using Pydantic. So basically, like there will actually be a proper schema in place instead of just right now it's a dictionary with. If you don't have Lisp experience, you cannot read it now. So I apologize for the current format. So yeah, yesterday someone asked during Troy's talk, I think, like, hey, you know, like, is evolution going to be like in CentOS 10? And the answer is no. But I used eBranch yesterday to tell them that, hey, actually, you know, like, it's only like, we only need to branch 9 packages to get evolution in. So I can show you what it looks like. And yeah, obviously you can tell that means that this slide has not been written until after yesterday. I won't tell you when I write it. So yeah, you have to use the Python API for now. So import eBranch, eBranch like a DNF resolver, and say I want to look at, so we're not going to look at publish EPEL packages, we are going to look at the packages used to build EPEL 10, which means that it's much faster because you don't have to wait for the compose. We are looking at evolution and say, hey, what is missing for evolution? Well, okay, this is the raw output. So right now it's saying we have 1 missing package, but it depends on like all these other missing packages. And there are 7 dependencies to evolution that are not around. There's a bug here, like this none shouldn't exist. For some reason, it doesn't know what provides that dependency. And we just iterate and say, well, so this is a bit painful, and you have to like keep doing it, looping it manually because the old version was so slow that I don't want to like automate running it because then it might never finish. So basically, we have 9 dependencies in total. Evolution is missing 7, and then the packages with 0 dependencies. That means you can branch and build them straight away. And the only package that gives me a bit of a pause here is WebKit GTK because if you have tried building it, it's painful. But yeah, everything else was fine, right? Worst case, we don't have HTML email. So yeah, eBranch, PKG depgraph, which is the shared dependency library that that PoiTracker will also use in the future, and PoiTracker, they are all in Fedora right now. eBranch is in EPEL. POI tracker is not because Pydantic is not in EPEL 10 yet, and EPEL 9's Pydantic is too old, so we cannot use it. Sorry, not EPEL 9. I think it's in CentOS 9. So as I mentioned earlier, like I will be hopefully releasing eBranch soon, as soon as I get a few days to actually finish it. It will be much faster. It will support basically you can query like arbitrary Koji tags. So you can say, hey, I want to build against this site tag, which the old version doesn't do. There are some policy changes implemented that so I kind of want to release it soon. Like we used to have this SIG called EPEL packages. That's basically like collective maintenance for EPEL packages, and then we find that it doesn't scale because there are too many packages on it, and we get CC'd every time there is like a bug on any of them. And a lot of people want to join just because like, oh, I joined this SIG and I can build everything in EPEL. And POI tracker, there are a lot of things, improvements that are planned, but none of them are urgent, so this will probably come a bit later. And once we get Pydantic branch for EPEL 10, though, like I can ship this. Scratching my own itch because I do want to run this on the work servers, and like the work servers are getting upgraded to EL10, and right now I cannot run it, so I have all my work inventories are in a private repo on my laptop because I cannot put it in the on work machines yet. So yeah, I think we are really early, but I finished my slides. So this is when you tell me what you need for this, or whether like you find it useful. Do you have any improvements, feature requests that you might want to ask? And yeah, I'll share the slides later, and there are links to all the tools and SIGs you might want to join. Right, questions?
I might just talk with you after, because I have like a bunch of them. Any thoughts of, while you're getting the dependencies, finding out who owns those packages?
Yes, so the quality report that I plan to implement next is basically, oh yeah, that's a bit of a separate question, right? Yeah, that might be useful, because as part of the talk we have about deprecating the EPEL packages SIG, the idea being that we want to see which packages have only single maintainers, which packages should probably be added to different SIGs. So yeah.
Yeah, because I was just thinking that, because if you know, there might be a multimedia SIG, there might be a KDE SIG, and you
right.
could ping, you go like, oh, I know he's in this one, I
is
this person.
Or if like all your dependencies are like owned by like one or two SIGs, you probably should join that SIG and make your life easier.
Yep.
I'll be back in 1 second.
Just a quick comment, Pydantic is already in EPEL 10.
Wait, who is that?
Me.
Oh, it's already? Wow.
Pydantic is now in EPEL 10.
That's awesome. I should have checked that yesterday. Sweet. Who did it? Music?
Yeah.
Awesome. Okay, one of my slides is out of date already. I forgot my hat, so like and I have a spiel prepared too. Like, hey, you know, I'm not wearing my work hat, so you know, this is not a work talk. So thank you. Next question. Thank you. Thank you, everyone.
So we have our break now. We're going to do a quick group photo right out here by the couches. And then we will be back here in 26 minutes at 4 o'clock for a talk about Conflux. I know everybody has questions, so. Hi, everybody. We'll get set up and started here again. All right, we'll go ahead and get started here. This is our last block of sessions. And kicking it off will be Mike McLean, who is the technical lead of the RHEL build team. And will be talking to us about building RPMs and Conflux. So please welcome Mike.
Okay. Is this the right thing? Okay. First, thank you all for coming. I want to set this up by telling you a little about myself. I work on the RHEL build team inside of Red Hat. That's the team that manages the build pipeline for RHEL. I'm known as the author of Koji, which a few of you have used. But I'm not really talking about Koji today, except maybe to contrast it with what we're doing now. One of the big items that in our work in the past year has been getting RPMs to build in Conflux. And that is a work in progress. So I don't have a finished product to show you. But I'm going to talk about where we're at and some of the challenges we have. But first, I'm going to talk a little bit about Conflux because a lot of people don't know much about Conflux. But I do want to set this up by saying that I am not a Conflux expert. So I'm just going to say a little bit about the parts that I know because it's a big system. Okay? The term that they use to describe Conflux is software factory, and I think that's fair. It's a little highfalutin, but I also think it's accurate because it's you'll hear people call it a build system, but it does more than building. It does a lot more than building. It essentially encapsulates the entire pipeline, what we would call the entire pipeline, build, test, release. Right? You take it from all the way from code to essentially finished product. Okay. Internally to Red Hat, it would hypothetically take the place of several different tools that we currently use, not just Koji. It's built on top of a lot of different open source projects, but the really big ones are Kubernetes and Tecton, particularly Tecton chains. So I'm going to launch into a couple slides that I lifted from Ralph's talk. If anybody was at Flock, then you may have seen some of the next few slides before. So, is it look okay? Yeah, big wall of text. Sorry about that. So the Conflux team describes Conflux this way. This is opinionated, Kubernetes native, security first software factory based on Tecton. So opinionated is a fun word, but that means that Conflux is, while it's incredibly flexible in a lot of ways, it's rigid about a few things, and that's where the opinions come in. In Conflux, everything runs in a Tecton pipeline in Kubernetes. So when you run a build, it's going to run in a container in your Kubernetes cluster. And everything gets recorded. That's the transparency item here, is that as the build progresses through the pipeline, because they're using Tecton chains, they're able to log what they call attestations at every step of the way. Everything gets recorded and signed cryptographically, and all of that data gets attached to the end result, which is going to be an OCI artifact. So the output of the build will be stored as an OCI artifact with all the attestations in metadata. Conflux has integrated testing, which is, again, taking over many different systems. So there's a lot of tests built into Conflux already, and I think that's some of the opinionated part. You can add your own tests as a developer. And Conflux uses what they were calling enterprise contracts, but they've renamed them to Conforma now because not everybody that uses Conflux considers themselves enterprise. But what that is essentially a policy engine that is used by Conflux to validate that what Conflux is producing honors the expectations that are set. So release engineers, developers, et cetera, can write policies about what Conflux is producing, and that those policies are based on the attestations that are recorded along the way. So you can you can have some confidence at the end that what you're building fulfills your expectations. That's the goal. The last big goal here on the list is the unified user experience. Conflux is one system instead of the many systems it replaces or aims to replace. So you go to one place to find all your data, to do all your work, instead of having to know how to navigate several different systems. Okay. Conflux is very security focused, and that comes in a number of different ways. One way is that it has baked in support for producing SBOMs, which everybody wants now. Because of the way that Conflux builds, it can record the container environment, everything about the container that was used to do the build, and everything about the sources that go into the build. The expectation in Conflux is that the build part of the pipeline is going to be what they call hermetic, so no network access. So when you do the build, your build can only access the things that were fed into it from the beginning. It can't go out on the net and fetch some new data. So you control the inputs, and that's what's recorded in the attestations. And that allows producing accurate SBOMs in the end, right? As opposed to, say, tools like Sift that look at the source and look at your dependencies and assume that your dependencies are actually what you will use to do the build, even though who knows what was actually in the build environment. So this is a better way of producing SBOMs. An interesting thing about Conflux is that it gates at release time rather than at build time. So it pretty much allows the developer to a lot of freedom to do any kind of build that they want. And that will not fail until it gets to release, and the policy will see that the attestations say that, oh, you built this in some weird way that's not allowed by policy, therefore we can't do anything with it. But that's something like Scratch builds in Koji, I guess, where you can get away with a lot more in Scratch with a Scratch build, but this is much broader in scope. If you go into Conflux as a developer, you can pretty much do almost anything in your container. You have admin in your container when you set up a build pipeline in Conflux. So that's a lot of freedom. And so, but what you can't do is escape the container or do anything outside of a container. So it's very flexible in that way. Conflux, the API is just the Kubernetes API, so they've added controllers into Kubernetes to make Conflux work. I think I mentioned that the user has admin. And everything it produces goes into OCI artifacts. Okay. Well, so that's a brief overview of what Conflux is. And there's a lot. I can't really do it justice in the time that I have. and also get to building RPMs. But I do have some references for you in a later slide, and I would also encourage anybody that's interested to go watch Ralph's talk from Flock, which goes into greater detail and is pretty good. And of course, there's the Conflux docs. I'll have all those links in a later slide. Conflux is still actively growing, and it's being adopted inside of Red Hat to a degree. There's a lot of momentum, a lot of activity, and some products are already using it, but not RPMs. Only just just our very early work on making RPMs work through it. And also Fedora has an instance available to play with. It's got some limits, but if you want to play with an instance, you can go to the Fedora instance. I have a link to that later too. Because I'm the Koji guy, people talk to me about Conflux, and we invariably end up comparing it to Koji, and they're quite different. Conflux is a much larger scope. Koji, neither one's just a build system. Koji does more than building, and Conflux does more than building, but Conflux does essentially more and maybe a little bit less than Koji, but as I said, it does full build, test, release, and really anything that you can build into a Tecton pipeline, you can make Conflux do. So it's a lot. Koji builds and tracks the builds and provides tools for managing and organizing those builds, the results of those builds, which Conflux doesn't have anything quite like that yet, but they are looking at building out something along those lines. We'll see what that shape takes. That's a problem for another quarter, I think. That ticket's still unassigned. So when we look at building RPMs in Conflux, there are a number of challenges. Some of them come from the way Conflux works, and some of them come from the way that RPMs are, especially not just RPMs in general, but the way that we build RPMs in our distribution. One of the challenges we have is the hermetic build requirement. Because what we want to do in Conflux, at least at the beginning, is we want to use mock, and mock definitely needs the network. The approach with Conflux is to prefetch all the things that you need for the build, and then run the build in an isolated way. But when you're doing a build with mock, what you need for the build is a lot in principle. It's a lot to prefetch. So I'll get into how we've addressed that. Let's see, there are other challenges we've had. Resources is another. At the moment, at least in the Conflux instance, we have access to getting the resources right-sized for the types of builds we want to do in RPM land has been difficult. And I don't know, we have some open work on making that better. We'll see how that goes. We've had challenges managing secrets, particularly when it comes to signing. There are situations in RPM land where we need to sign things at build time, like the kernel. And in Conflux, the user has admin in the build pipeline, in the containers. So any secret that you have inside the container, the developer can, in principle, steal. So you don't want to have any secrets that allow you to sign. So we're still figuring that one out too. So what we're doing so far, and this is essentially baby steps. This is not where we want to be, but it's where we're starting, and that is to build RPMs in Conflux and then import them into Koji via the content generator interface. All right, so Conflux becomes another content generator for Koji. And when Conflux does builds, it uses the build repos from Koji just like Koji would. So it's you're running mock inside a container using the same Koji repos. So this makes it fit into the existing workflow that we have, and yet still use Conflux. To make this work in Conflux, we've had to adjust mock. And I'll get into that a little bit. I'm not sure how this reads from there. This is the workflow that we have in Conflux for the builds. This is probably too much to absorb. But I think the key thing here is when we get to the arch split and we start doing the actual build part, we have this step in the pipeline where we pre-calculate the build depths, and that is our single non-hermetic part, and that's the trickery, the mock trickery that I mentioned that allows this to happen. So essentially we run mock twice, and we've modified mock to allow this to happen. So you do this prefetch with mock, where you create the build environment, just like you would for a build, but then you stop, and you just record what you did, and then you don't do the rest of the build. And then that allows us to have a list. We know exactly what dependencies came into the build root, and then we can redo it again. And when we prefetch everything that we needed, and then we run it again. And when we run it again, we use mock in a special mode that is new, where you, instead of having mock solve the dependencies, you just make the same build route that you made before with the prefetched RPMs. Then at the end, we're able to pull the build together, do the import into Koji, or generate the SBOM, which was one of the big goals, and import into Koji at the end. Now, we have at the bottom of the graph sort of this split in the road. At the moment, we're doing, is that purple? Would you say that's purple? Purple side. We import into Koji, and that allows us to, once it's back into Koji, we're able to follow the same workflow that we have. Right. In the future, we would likely want to move more of this into Conflux, but until we can figure out a way to do that without the features that Koji offers, we still need Koji. So I alluded to the changes in mock. There's been a flurry of mock commits related to this, but most of it boils down to these two things: the hermetic builds feature and the build root lock plugin. And this is some example code for using this mock feature. That this is essentially how we're doing the build in Conflux. So first you use mock to calculate build dependencies, and then you run mock in a hermetic way. In Conflux, I think you would draw a line between the first half of this these set of commands and the second, because they happen at different steps. We've also had to make adjustments to Koji to allow this to work. Less than mock, really, but Koji's has had for a long time content generator imports, but they have not allowed RPMs until recently. So we adjusted that, and we also allowed content generators to produce draft builds, which they weren't able to do before either, because we wanted to have parity with the existing RPM workflows, and draft builds matter. Also, we needed to make some policy changes to allow Conflux to do the things it needs to do, and also allow the builds produced by Conflux to go where they need to go. They look a little different in Koji than Koji's own builds, because they're from a content generator. Let's see. For future directions, so this is guesswork on my part, because I don't know what the future holds. But what I expect we'll see is new ways to build RPMs. As I mentioned, what we're doing now is baby steps. I think the way mock works is based on the way we were doing things 20 years ago. And in a Conflux environment, it would probably make sense to build things a little differently. I think right now, essentially, we have nested containers happening, because you run mock in a container, and then mock creates a container to do the build. And I think flat is better than nested. It would be ideal if we could essentially make the container that we need, use that in Conflux instead, but we're not there with tooling yet. Although mock has gained recently some work for using arbitrary containers at the outset, so we may see that along the way. I wish that this was available for you to go poke at right now. The RPM pipeline that we have set up is working. We have built RPMs inside of Red Hat. We haven't published that pipeline publicly yet, mainly because it's tied to a bunch of internal systems, and it wouldn't work with the Conflux in Fedora right now, much less the Git in Fedora right now. So we didn't want to just throw this code over the wall and have it not work. So, but it's coming very soon. That it's actually there's an active ticket to get this released publicly, and then you'll be able to toy with it. That's for RPM builds. However, you certainly can get Conflux. There's lots of documentation on their website. I mentioned Ralph's Flock Talk, which, if you're interested, is definitely worth watching. There is a Fedora Conflux SIG that has meetings every other Thursday. If you're interested, you could pop in and join them. and there's the Fedora Conflux instance, which you can log in with your FASA credentials and start using, if you like. It's something you can play with. I don't want to present all of this as my work. A lot of the work for building RPMs in Conflux has come from the team. So Tomasz Milczek has done a lot of the architecture. Tomasz Kopacek and Pavel have done a lot of the coding, and of course Ralph Bean's been invaluable. So with that, I think I want to take questions. Okay.
So, going back to your hermetic build thingamajig with the result log file and creating this stuff, something that occurred to me while you were talking about it is you could use that as a way to calculate when a package has changed as a result of a build and when it hasn't. So like if you have those build routes and you can have in those alongside the name NVRs of the RPMs, assuming that's what you're pulling, you'd also have the checksum of the payload. Not the whole RPM, but the payload. And that way you could compute if it changes through forward or backward drift to optimize being able to build all those things. Have you thought about other things along the lines of being able to optimize chains of package builds and things like that for this process? Because a lot of what makes doing chains of optimal chains hard is that we don't have enough data inside the chain process to make future decisions as you move along.
That's interesting. We have not looked at that yet. As I said, baby steps.
Continuing with the question of preparing the build route, what happens when you have dynamic build requires, right? Because you need to unpack the RPM, install it in the change route, and run some code from it to generate more build requires.
Yeah,
keep going.
It's nothing Mock hasn't been doing this whole time. It's just it was doing it all in one go before, and so now we're essentially running the mock build up to the point where we have the build route, and then just stopping, freezing it, and then that gets us the information we need to reconstruct the build route again in a way that's hermetic.
So. But the build route you take is the final build route, not the, I assume, yes.
Yeah, of course, yeah. The build route that we record is the build route that is set from just a list of packages that were already there, yeah.
So as a packager, for me, it's very important that I can take any part of the current pipeline and run parts of it locally. Mock build and maybe enter the container and do stuff there, or maybe do fed package local, and that I can debug this in all possible ways. How does this work if we move to Conflux builds?
Well, at the moment, you can still certainly run mock, and at the moment, mock is still pulling the data from Koji, so yeah, you can do the same thing that you have for now. In the future, if the tooling changes, I don't know for sure, but that is certainly something we want to preserve. And I will also add that you should be able to, in Conflux, essentially run your some sort of test build that does your build in a slightly different way. You have a lot more freedom in the build in the pipeline. You could run a different pipeline in Conflux to evaluate what's happening in the build. Does that make sense?
that's a complementary approach, right? But for debugging, like going into the environment is often easier.
Yeah. So I could see intermediate containers getting pushed to a registry that you could possibly pull down and then run them locally.
Yeah, that's definitely something that's on the table, yeah. That too.
So what I was wondering about, if you use mock to fetch all the dependencies and then make the final build route available to the hermetic build, how that means the RPM spec gets to fully declare what the build route is gonna be. So it gets to define its own inputs. So if you're asking the RPM like what are your inputs and then giving those inputs to the build, what's the difference between just making the entire repository available to the hermetic build and then just querying what was used at the end? To me, it seems like exactly the same thing.
Well, it's a matter of bandwidth, really. You know, the repositories that we use for. Sorry, what do you mean by let me back up. What do you mean by repository? Do you mean the code repository? Do you mean the
making every RPM that can be installed as?
Yeah, that's a lot of data to prefetch. We don't want to prefetch the entire repo every time. And also, it's a lot of data to record. You'd be recording data that you didn't actually use.
This is about the motivation behind Conflux. Sorry if I didn't read all about it before. If I'm understanding correctly, is it mostly about the hermetic builds with an attestation log with all the secure boot signed stuff, plus the software bill of materials, or is there more behind the origin of Conflux? What problems it is trying to fix that Koji didn't?
Conflux is trying to fix a lot of problems, but I think they want to unify and systematize a bunch of disparate systems and modernize everything in. Don't worry about it. All right. And yes, security is one of the first goals. It's usually the first goal they list. So doing hermetic builds. Granted, Koji does isolated builds as well, but with Conflux, that's even more strict than what Koji does. I am actually not here to sell anybody on Conflux. I'm just here to talk about how I'm using it, how my team's been using it to build RPMs. If you want to be sold on Conflux, go watch Ralph's talk. How about, Justin?
So I just want to say thanks for coming to CentOS Connect and doing the talk here. I was looking into it. You mentioned that the Conflux SIG and Fedora meets on Thursdays, and I was just trying to learn a little bit more about how can folks get involved and participate with or follow along with the Conflux development efforts. I looked on Fedora calendar and the wiki and the docs, but I wasn't sure where the best place to look for where the SIG is active and those things.
Oh, it's I think the SIG is not a Fedora SIG. I think it's a Conflux SIG. So it's a Conflux SIG about Fedora rather than a Fedora SIG about Conflux. I might be wrong with that, but like the SIG wiki page is in the Conflux wiki, not Fedora wiki. So.
Well, I think that might be a cool place for us to look at making some spaces in Fedora to talk about Conflux too, because it'd be a great, I learned a lot of new things from this talk, and that was the first thing I thought to try to figure out where, as a Fedora developer, I can jump in. So I'd love to talk more later, and we can set up some spaces in the wiki.
I mean, likewise, the Fedora Conflux instance isn't maintained by Fedora, I don't believe. I think that's maintained by that was set up by Conflux, sort of, I think originally as a test bed for Fedora people to play with, to evaluate to see if Fedora wanted to adopt Conflux, which is still an open question, I believe.
Go over here next.
All right, so
thanks for giving this talk. I have a two-part silly question. So first, when you talk about having Tecton as a bed, right, and on top of it, all of it, Tecton, as I understand, uses, like when you give it tasks, it creates multiple pods, like, and it uses single pod to process single tasks. Information usually get lost between these, like when you try to pass from one task to the other task. So usually I have tried Tecton for building things before, and it has not essentially does. I mean, you can solve it using multiple hacks, but essentially that is a potential problem area. Is there something that you are doing to solve that? That's one. And second, when you talk about containers, are you talking rootful containers? Or are you talking like rootless containers here?
It's in Kubernetes. Yeah.
And are you doing something to solve the problem for like not having each task processed by a single pod that creates a lot of latency or even starting up containers?
I don't think that's been enough of a problem for us so far, but again, we're at the early stages of this as well, so I will. Yeah, so no. The answer is no. We don't have a solution for that, but from my experience with Conflux, it does pass things along from one task to another. I don't know how it does it, but there is definitely information passed. Oh yeah, sure, yeah. Yeah, because Conflux is certainly more than just Tecton. It's a lot more. That's a huge piece of it.
Charles, the mic over there.
Hello. Quick question, like you mentioned, like you have an SBOM that record everything that's used to actually do the build. Is the build tooling like mock and Koji, like themselves part of the SBOM as well? So you can say, hey, I built this with this version of Koji and like this version of mock. Maybe like this container checksum.
I believe so.
It's not on.
Quick question. Very loud. Sorry. Automated like rebuilds and things like that. Have you looked at, setting up like pipelines to, make everyone's life easier by, like if dependencies and things change, or we bump glibc and we go rebuild the world just to make sure we still can.
I mean, you certainly could do that, but we haven't gotten that far.
Do you think it should be a goal?
I think exactly when you do automated rebuilds with RPMs is a tricky problem that's sort of independent of Conflux. I don't. But if anything that would trigger that would be yeah, that sounds like a whole other pipeline that you would have to build.
Yeah. So you made a focus about this hermetic building stuff, and talking about doing it in containers seems like the opposite of hermetic. So have you looked at maybe instead using lightweight virtual machines to do it, so that because you don't protect the kernel boundary or any of those other things, and being able to lock all that stuff down makes the environment even more reproducible across different machines and different platforms. I mean, for example, the Open Build service uses virtual machines for its hermetic build mechanism because they can then also record and transmit and reproduce even the operating environment that it builds in.
At the moment, we're not doing that, but controlling the kernel is something that we will need to do because
things get weird.
Things get weird. Most builds, I personally have always thought that any build that depends on the running kernel is broken, but who am I to argue with the toolchain guys?
Right. I share your opinion, and I also share your resignation.
I just had a question, and it's a kind of follow-up on Neil's question, by the way, because we know that the build environment matters a lot in case of will it build or not, and will the test pass or not, because it's completely different from running in classical old CH root style versus systemd and spawn, and then Kubernetes as isolation in containers. So I don't know if you can share or if you have the number, but how many RPM packages have you built so far, and what are the statistics of failing builds in Conflux that are passing in Koji? Because I'm trying to imagine the burden on the maintainer if they have to change everything because of the build environment change.
Right now, we are building a very small sample of RPMs in Conflux. And that's expected to grow, but the number is very small right now. Oh, yeah, he asked when did the effort start, and early summer? Yeah.
You mentioned that there is a Fedora instance of Conflux.
Yeah.
You didn't have the URL for it on the slides.
Oh, I'm sorry, I'm bad at slides. It's linked, so if I can publish the slides later, it's there. But yes, I did not copy the link in text in the slide. But if you Google Fedora Conflux instance, it pulls it right up.
I tried the obvious URL with conflux.fedoraproject.org, and the certificate for that is expired. So I hope it's not that.
Oh.
It is that. Oh, good.
Yeah. Yeah.
I think we have to cut it off there. So thank you, Mike. We are, for the first time, actually running behind. I know, right? I knew there'd be a lot of questions on that. I should have forced Mike to do a lunch and learn session. I like to give other people work. Got it? Camera on the right thing? All right, we'll get set up here. Just 2 more sessions. And then you can all have dinner and then join the waffle party. Do you need power? Yeah.
Maybe.
Does anybody have a microphone? There it is. Thank you. All right. There we go. What's going on? Our next speakers will be Carol Chen and Cedric Clyburn. We'll be talking about bootable containers in action, hands-on with deploying AI workloads. Yeah. All right, please welcome Carol and Cedric.
Mic check, mic check. Good evening, everybody. Sorry, I almost said good morning. My name is Cedric, and I am joined by the wonderful Carol Chen, and we're excited today to be, hopefully, talking about bootable containers. I've dropped this laptop a lot of times, and I'm due for a refresh. Let's see if we can get it back out. Oh, thank you. Yeah, I'm like cursed. Knock on wood. So, but thank you all for being here. We've got a lot to talk about today because a lot has happened in the past year, and some stuff that you might have known or heard about, for example, was talked about at KubeCon this year, where we had the, Last year. This, yeah. November 4th. This man knows. Oh. Okay, so last year, where at KubeCon there was a big announcement to donate some projects that we'll talk about here in a second to the Cloud Native Computing Foundation, one of which was accepted last week that we're going to be talking about today, bootable containers. Now, what are bootable containers? Well, this is primarily the topic of the session's topic, right? What the innovation is and how you can actually use it, and we're going to do some hands-on demos today with Podman Desktop, an open source tool that was also donated to the CNCF to package up and experiment with AI applications and be able to deploy them as OSs using bootable containers as a technology, so that you can take all of your traditional build processes, CI/CD testing and verification of cloud native applications and apply that to disk images as well and be able to deploy them wherever you deploy your applications. And that's why Podman Desktop is involved, where we're going to be showing the demo today. So if you'd like to take a look at the slides or the code that we're going to be using today in the demo, feel free to check it out here. We've got this also included on the conference schedule, so if you go later on to the CentOS Connect website, check out this session, you can download the PDF for the slides as well. So without further ado, we ready to hop in? Awesome. Cool. I'll do a quick introduction for myself. Hi, my name is Cedric. I'm a first-time attendee for both CentOS Connect and FOSDEM. It's crazy. Thank you for the woo. I make videos on the internet, so for example, you see one of those RAG versus fine-tuning that I did with IBM, but I also just make content for developers to learn. I'm an application developer myself, and I dive into containers and AI topics, and I create workshops and demos, and I'm also an organizer for the KCD Kubernetes event in New York City, where I live, and a speaker at some other Linux Foundation events, and pass it over to the wonderful Carol.
Thanks, Cedric. Whoa, this is loud. I'm Carol Chen from Red Hat. I'm a AI community architect, or a community architect in general. I've had the pleasure of leading and supporting many different projects since working in Red Hat, and actually also outside of Red Hat and before Red Hat. So here's just some of them. You might recognize some of these projects. I'm a bit more camera shy, so I don't do a lot of videos like Cedric does, but you know, I really appreciate people who can take interesting technical topics and bring them and explain them to be accessible to a lot of people. So great work, Cedric. Yeah. And if you want to look for me online on the usual haunts, nowadays I don't hang out on X too much, but Mastodon, GitHub, Matrix, that's my Matrix ID, and Blue Sky, you can all use the @SciBat ID to look for me there.
Awesome. So go ahead and kick it off with one more plug, just quickly for, who here knows Dan Walsh? Familiar with his work? SC Linux fans or haters? If you want to check this out, I produce a show with him. It's called Red Hat Dan on Tech on the YouTube, and we cover all types of topics: SC Linux, containers, Podman, tooling, Ramalama, which is the new tool for AI to run it on your local machine, systemd, Quadlet, etc., etc. If you want to learn about the people behind the projects, I highly recommend you check out the show. Episodes are like 10, 15 minutes, and we do deep dives and demos on all of these different technologies. So quick little plug. Carol, question for you. The question of the day, question of the session. What are bootable containers and why do they matter and what do they solve?
Wow, that's a good question. And I recently just learned about bootable containers myself, so hopefully I can be able to shed some light of what I've learned with all of you. Now, imagine deploying your entire operating system with the same ease and consistency as your applications, containerized applications. So bootable containers are what makes this possible, because it unifies system deployment and application management into a seamless, efficient process. What do I mean by that? Oh, all right. Thanks for advancing the slides for me. So for the most part, when we talk about operating systems, it seems like it's a solved problem, but if we look closer, we realize there are a number of things, a number of challenges where people and organizations, when they intersect with technology, depending on your company or industry, some of these could be some challenges that you face. So oftentimes, different platforms tend to require different tooling, or you have to find expertise for very specific platforms for your organization. So while that isn't necessarily a problem in itself, there's inherent overhead and complexity that requires more coordination, and with that, it impacts velocity, the speed that you're moving with your organization or company. So another thing is for testing and validation, a lot of times in practice, budget don't really factor in like maintenance costs, upgrades of the OS, and also the applications running on top. Patching stuff may be easy, but negotiating downtime with stakeholders and different teams involved can be difficult and time-consuming. So these are just some of the hurdles that when we come to the operating system, you may not have ready, easy solutions. So let's see how bootable containers can address some of these. And actually, before we go into bootable containers, let's talk about containers. So if we look at the application side of things, containers solve some of these problems that I mentioned. In terms of like packaging, delivery, they are kind of pretty standardized because the adoption of containers has been pretty fast, well, over the last 10 years, but it has been used in a lot of places, very much standardized, compared to the previous virtualization and cloud computing waves. So this has really a profound impact on the way that people share and use applications with containers. The key lesson here is that containerization technologies and workflows provide just enough standardization, structure, and ease of use. Containers are becoming ubiquitous, and you can build them anywhere. You can do it in production, you can scale it up using pipelines, or even independently on your laptop. It's fast, and that's really, these building blocks of containers has spurred a whole ecosystem, Kubernetes and all the different tools around it. So, oops, how do I go? Yeah, okay. So the earlier mentioned problems have been solved in the application space, and now we're going to apply it to the operating system space. I think with containers, this next step is like a natural evolution to bootable containers. So for over a decade now, containers have evolved into this industry standard. So bootable containers build on top of these existing technologies and extend containers to the entire operating system. And includes also the Linux kernel, like you see here, to allow for a comprehensive container-native workflow and user experience. This is just a simplified illustration, but it basically includes and ships the whole entire OS, includes the kernel, bootloader, and drivers. The ultimate goal here is to install the whole content of this bootable container image on a host. Updates to the host are also applied via bootable image container images. So this means that we pull updates from a standard container registry, as we did with the application containers, the usual way. So let's have a closer look of what this means and how the process looks like. As you know, OCI containers have become the de facto way of deploying and completing a Linux user space for applications. A large set of practices and tooling have evolved around that. Bootable containers are a modern, opinionated way of deploying, configuring, and managing immutable image-based Linux systems using these practices and tooling. So just like ordinary application containers, you can build bootable containers by using existing container technology, such as container files, including Docker files, and with existing tooling such as Foreman, Docker, or BuildKit. You can further store these images on any container registry. Example, Quay, Docker Hub, GitHub container registry, or even some internal container registries that you might have. All right, let's look at how to deploy and update a system. So this figure shows the life cycle of a bootable container and the different steps from building to deploying and updating the system. So from a container image, if you might notice, I actually have my speaker notes in my glasses. Anyway, once a container image has been built, it needs to be converted to a disk image, such as ISO, RAW, or QCOW2. This disk image can then be installed for some target environment, which can be a public cloud instance. You might also want to push the container image to the container registry that you choose. And that's to deploy a new image. To update existing systems, you also build this image to be updated and push it to the registry. Once that's pushed there, the deployed systems on the right can then pull the new image from the registry and then reboot into the new image for the update. All right, what are the tooling involved in this bootable containers? So bootc, that's at the core and center of the bootable containers. It is a command line tool that ships with a number of systemd, services, and timers to manage the bootable container. And among other things, bootc is responsible for downloading and queuing updates and can be used by higher level tools to manage the system and so on. For this reason, bootc is an integral part of each bootable container image. And there are several ways how an individual system can be updated, including by default is the time-based updates with systemd timer. Then there's also event-based updates with the bootc fetch apply updates service, which can be triggered. And lastly, it can be manually updated by running bootc upgrade and rebooting the system. So, and in case something goes wrong with the update, bootc is capable of rolling back to the previous working image. And you use the bootc rollback command for that. So for more details, you can check out this upstream documentation, which is linked here, continuous.github.io/bootc. All right. So how do you, I need to give you more time to do the demo. How do you actually build a container? You can use existing tools, like I mentioned, and then with that, you can then customize the image as you need and build the image with the specifications that you list. So you can use any existing bootc-based image and customize it to your needs. And for more details, again, the link is here in Fedora docs, building containers. All right. At the moment, there are 3 distros with bootable containers: Fedora, CentOS Stream, and RHEL. So I will not. You can see the Fedora and CentOS base images here in the link, but I will now hand it over to Cedric because I think he has more interesting demos coming up to show you how these applies to AI workloads.
That's a perfect segue, and I think we have just a second to kind of check this out as well. So here, also in the slides and everything, is where you can actually take a look at the base images and understand what they actually contain. So you've got full image philosophy, where you've got the kernel, systemd, network manager, a lot of other utilities, and then you have these little minimal images that is really just the base. If you think about it with the UBI images for RHEL, for example, you've got the minimal, you've got the regular, you have one specific for packages, and you could actually create your own base images for bootable containers. So if we go to the source, Fedora, oops. If we go to source for the actual code here, CentOS 9, we can actually understand in the container file how we're creating these base images. So if you want to take a look at that and kind of understand how you could create your own, for example, please do. All the code is here linked in the slides and also from the Fedora documentation. But let me hop back over to the slides and let's talk and see how we actually relate this to AI workloads, which is what I do every day at Red Hat, doing AI specialty tasks and working with customers to get their applications from POCs to actual production, whether it's on an OS like RHEL or CentOS or something like that, or in the cloud, for example, with Kubernetes. So the recommended use cases for bootable containers. A lot of these are pretty standard and you would actually expect this. So for example, one-to-one with the app and host. Most organizations, this is how they do everything, is they're setting up a virtual machine, running one application on it. The benefit for bootable containers here is that you can stack everything at build time so that you have less drift, and so you can actually minimize errors before things go into production, because sometimes the app team is a little far away from the OS team. We can also think about edge appliances, so if something is an IoT device and doesn't regularly get updates, well, we could just use bootc so that whenever it does have connection, it pulls down from the repository that update. But for me specifically, what I love and I'm very interested in, both of us here, is the AI ML stack. And this is a new kind of concept that we've had to think about because we're running all AI workloads essentially now on Linux, right? So to be able to perfectly version the app dependencies, kernel dependencies, the GPU, accelerator drivers, CUDA, and everything else into one stack is really, really important. And so you can kind of see a quick little demonstration of this here. Because in these little bullets, most of the world is already leveraging containers for AI workloads. You can think of NVIDIA's NIMs, for example, and a lot of other use cases. And having this kind of in a bootable container allows us to run the AI models as close as possible to the hardware, so that's benefits in latency, speed, cost, etc. And we're actually going to show an example of this with a RAG demo. But this is a huge opportunity. This is how we're actually building Red Hat Enterprise Linux AI, which is essentially using bootable containers to stack the different components on top of that base image. So you've got the component for the model fine-tuning and training, right? You've got a component for the model serving. You've got a component for just various other utilities that come with this appliance. And so this allows us to version these dependencies in a way that makes things much less complex. So you think about stuff like PyTorch, right? If we go back to this diagram, I'll go back one step here. You could have, for example, PyTorch, and then VLLM, and then the AI model on top. So having one standardized way to put everything together is really, really useful, and it makes a lot of sense. So we're actually going to see this, and the biggest part is that build time versus patching in production is really important to be able to have this stability. But let's see this in action. We've got 5.5 minutes here. So just as we would use containers to do all of these processes in a CI/CD pipeline, and don't forget security, for our applications, we're going to do it for our operating system with the bootc utility for Podman Desktop. How many of us here use Podman Desktop or Podman? Sweet. Okay, that's like at least half the room. So if you haven't seen it before, in the catalog, there's an extension that's going to make your life really easy when you want to build disk images from your containers. So what you do is essentially you would build an image just like you would through the regular process. This could be done with Docker, for example, using a boot C base image, so Fedora, CentOS, RHEL. And once that's built, we actually convert that into a disk image. So you can use one of those options. So for example, a Amazon disk image, virtualization guest image, a .raw, whatever you would like to deploy. And you wait about 2 to 5 minutes and you've got that and you can launch that as a virtual machine. So 4.5 minutes, let's go ahead and see it. Yeah, sure. So the first part that we're going to do is the first half of the demo, which is test and experiment with an AI application. This is, as an application developer, the first stage that everyone's going to go through is like, hey, we've got a use case. We want to use an AI model. How do we actually do that? And can we do that from our local machine versus use a third-party API where we're sending our data? Maybe that's confidential data, or maybe we just want to keep things local. So shall we? Yep. Cool. So over here, Podman Desktop, my favorite tool for working with containers. I wasn't paid to say that. We're here at the recipe catalog, and so there's a lot of utilities to work with AI in containers here, but what we're actually going to do is set up a recipe. So this includes all of the different, I guess I could say, ingredients to set up an AI application. So for example, we check out the code from GitHub, we copy a model as a volume into a container. That inference server is Llama C++, but you could use VLLM, which is a production-ready serving runtime. We build a vector database as a container, a front end, and we package everything up in a pod. So if I go over here, we can see that all the containers are running together, and let's open up the application, and let's ask a question. So who's keynoting FOSDEM 2025? So this model, all right. Demo effect. Here's what I'm going to do. I'm going to restart it, and all those steps that you saw earlier are just going to be recreated, right? That's the beauty of containers. I can easily shut something down and easily start something back again. And fingers crossed, we're not going to get a strange error. But the question I'm going to ask is something that the model wasn't trained on, right? That's the purpose of RAG, is to pull in external information that the model doesn't already know about. Fingers crossed. Come on. Hold on. All right. Oh, okay. Okay, we'll try it one last time. If not, I'll just skip to the bootable containers part. So let's see. I'm just going to delete all of these guys. Everything was working before I got here. So that's the beauty of the live demo. So we'll start the process again. If I wanted to, I could just download a model from the catalog and run that there, but this allows me to pull in source code and actually build an application that I could start experimenting from. Fingers crossed. Hey, who? Maybe they didn't like my question. Who keynoting FOSDEM 25? Okay, so the model's going to think about it. It doesn't know and it can't answer. We're going to provide some information here. This is a FOSDEM brochure that I generated in text. And we're going to upload that in a vector database, and we're going to ask the question again once it has processed and chunked that information, and we'll be able to determine with similarity scores if that context is relevant and pull that back in. So when we ask the question, oh, we got 1 minute left. Okay, we're going to go fast. We're going to ask that question again. It's going to have the context and be able to pull in all the information for the question that our person is asking, right? So great little use case of RAG. What we're going to do actually is come over here and open up the source code. And here we have it. So we've got the container file to build that application, and we've got the source code in Python to actually have that front end and make the calls to the model that was running locally. In that same repository, we've got a container file that is going to build the bootable container. So it's based on CentOS Stream 9, and we're pulling in, for example, the model. We're pulling in the inference server and the database there. And we're setting that up and essentially going to start that as a service, a systemd service, when we actually build this. And so I kind of ran this all here earlier. I'll run it again. Well, All right. Pretend I didn't do that. We've ran this and tagged it locally so that if I go over here, I can check out my images. 4 seconds left. Whew. Rag. Okay, well, let's see. Now we have it in our image registry here locally on our machine. It's quite a big image, but think about it. We're including the model, the inference server, everything that it needs, so that we can now, I'll show you this last part, build this and put it into whatever disk image type. And then finally, we could even run it as a virtual machine, and this is what I did earlier, so that we could test this application out locally and now take this and put it to wherever we want to deploy it. But I went a little bit over time, and I'm really sorry, so we'll kind of wrap up here. And thanks, everyone, for your attention. I hope you had fun.
Thanks, Cedric. It's my fault that we ran over time, so.
Awesome. We have one more talk to get through today. No, that was great. I don't have a gong. I don't play you off. It's all good.
You should have a stick to poke me. Stop already.
Good job actually like looking at it though.
Sorry about that.
No worries.
All right, one more talk today. Be Foreman and pulp packaging. Is it Ewald? Ewald. Okay. I'll let him introduce himself so I don't butcher it. Is everything ready?
Yeah.
Okay. Then go ahead. Please take it away. Thank you for joining. Oh, I think you're not on.
Is it now?
Yes.
Okay, so thank you for attending the last talk of the day, or over the whole conference. It's been certainly interesting. I saw some talks, and over the talks I made some adjustment to my own slide because of relevant material, which is certainly a benefit of being the last one. Also, downside, you keep doing work. Well, a little bit about me. I've been a former contributor since 2012, which is a long time ago by now. I've been a Red Hat engineer since 2017. For those of you who don't know, Foreman is the upstream to Red Hat Satellite, or one of the upstreams. So all of this sort of flows into the downstream product, but I was a community member before. I've tried to keep the information in the talk limited, and in the past I've always tried to dive too deep. Let me know in the end if I actually succeeded or did too much. What is Foreman? Novar already told you, but it's doing host lifecycle management. It's extensible via plugins. The part she didn't really mention because it's too long, perhaps. There's also a big plugin called Catello, which is doing content management, which actually it's so large it also pulls in other dependencies. Like we have, besides Foreman and Foreman proxy, we also have Pulp, which is written in Python. We also have Canopin, written in Java. So all of these sort of things put together makes a fairly complex packaging ecosystem. So we try to do it with a very small team. I think we have about 4 to 6 people who are actively involved in this, but even that, sort of beside your normal job and not really dedicated. So there's a large need to automate. I think for a lot of people, it's true that you don't package because you like packaging. You package things because you want packages on your system to actually be a user. So yeah, the less time you spend on it, I think the better. For us, we've chosen monorepositories. I know it's controversial for some, so I'm not going to go into all details. But we have 3 for all the major applications, mostly because they have their own life cycles, and that just makes it a bit easier. And I will go into details later. These are just terms I made up, but I want to focus on the development workflows and the release workflows. So basically anything that happens before you merge a PR is, in my opinion, development, and basically after is more the release work. That's just how I'm going to treat it. So let's look at development. We are based on GitHub. We use pull requests a lot. We do CI with Jenkins, and then we use Copper as a build service, and that basically tells us, is it all right or not, and if so, we merge it. There are some limitations we have. For example, one problem is that we build every package individually, so you can't really do something like, I'm updating a dependency, and then also it's a build requirement, so I need that in the same PR. That's something we can't do. That's just complicated, and we decided to, well, ignore it for now. It's good enough, but not great. We also try to do repo closure to see if it all passes. For those of you who don't know, repo closure is basically verify if all dependencies are present in the repository after you build it. In my experience in PRs, it's usually not that great. It has some flaws in some technical details, so that's not a great check, but we still do it. As for branching, like we have a mono repository, and it's quite nice that you can actually branch the whole repository at once. So unlike Fedora, where you need to do 20,000 branches, we just do one single Git branch and sort of done. So we have RPM/develop for nightly. We have x.y branches for stable releases. There's some cherry picks in between those. Nothing special. I think most of people here know that. From the name, you might also derive there's something else. And then RPM, and yes, there is. We also do debian packaging, but I'm not going to dive into it today. So sorry for the colors, but this is more of a visual representation. So we have the develop branch at the top. Then you create a new branch for your feature. You try it all out, and it eventually passes, and you merge it. Then at some point you have branching, so you create a new x.y branch. There's always some post-branching actions you need to do. For example, it's no longer 3.14; it's become 3.15. So that's something you do in RPM develop. In the stable branch, you remove all the nightly package building things, but then they live on in parallel, and that's how most people do it. Then you also have package bumps, for example. Very often you have a plugin, and you also want to update that in the stable branch. So you do a cherry pick. So these are, I think, the most common workflows that we do. This is fairly standard, I would say. Just want to go over it. Release parts. So we mentioned earlier, PR merged, and you need to release things. This is, I think, fairly simple. We basically have Git. Jenkins monitors Git and figures out what changed after something was committed. It sends up jobs to Copper, builds it, and that's sort of what we do. And we treat Copper almost like a dumping ground, just as going to be next version. It's a more continuous process. I think that the interesting part comes after that, release pipes. Because this is really the more interesting part. And if I saw, like I mentioned earlier, some interesting talk which had a lot of overlap. In Troy's opening talk, we saw CentOS as build pipelines. They're pretty similar to this. It's basically the same thing. Then Andrew said the same thing for Alma Linux. They do the same thing again, and we do the same thing again. And when I was talking to other people, apparently other people do the same thing. So shouldn't be too surprising. So this is how we did it. We have a compose step first. This is where we take all the builds that we did in Copper. We gather them up. We do our own magic on top of that. We put it on staging yum.theformer.org, which creates a snapshot we can sort of rely on. It's stable. We also do some other magic. Apparently our interpretation of comps is different than what Copper does. We also treat it as a filter, so we can filter out packages we don't want. Apparently Copper does it different, because Copper also creates repositories, but we can't use those. Another limitation is modularity. Copper didn't really do that, so we need to do our own. Luckily, in Nightly we've dropped EL8, so we don't deal with modularity that much anymore. But still, on EL9 we need it for some things, so it's not entirely gone, if only. So I mentioned repo closure in the past. That's also what we do as a first sort of sanity check. It's fairly cheap, but if that doesn't pass, there's no point in actually going further with testing. Then we have a testing phase. It's a bit simplified here. What we do in practice, we have, generally speaking, 2 pipelines install. It says what it does. It installs basically a base OS, runs the Foreman installer on it, and runs a bunch of tests. And we do that for multiple versions. So for every EL version we support it. Currently only 9, but previously we had both 8 and 9. And then for every, we also do it in CentOS Stream, but also we run it on Alma Linux, so we know we are sort of compatible with RHEL. It's just a stand-in, and Alma Linux is easier because it's freely available and you don't need to deal with subscriptions, etc. We also have upgrades. Upgrades are basically what we do with what we call N-2. So we start, let's say that we are testing Foreman 3.14. So we start with Foreman 3.12, we install that, we upgrade it to 3.13, then we upgrade to 3.14 and run the same test suite to see if that still passes. So it gives us some sanity if it's still sort of working. Often find interesting bugs that you didn't expect before. So I'm very happy to have that. And that does the same matrix testing, like the same OS versions, the same distributions. This all runs on CentOS CI. We basically use a big beefy machine, bare metal machine, spin up a bunch of VMs on it, and because it's doing that, you can actually reproduce it locally as well. It's exactly the same, just spin up Vagrant, spin up boxes, and you can reproduce errors. And I think that's proven very useful in the past. When something fails, you want to dive in the exact same environment. This gives us that. But I saw a lot of similarities with compose testing. Currently our tests are mostly written in Bats, which is Bash framework, and Bash is not really a great tool. I saw that CentOS uses TMT, and that's something I'm investigating, but I don't know. But it sounds very promising to sort of standardize these kind of pipelines. And if all tests pass, we're happy to promote. So we promote the content that we had on staging yum.theforeman.org. We promote that to yum.theforeman.org, and users can actually consume it. This is one pipeline. We basically do this for every repository that we create. So it's basically the same pattern over and over again. Also for stable branches, etc. Let's zoom in a bit on the individual repositories. So we have the Foreman packaging. We actually create 4 repositories from one Git repository, partly for historic reasons. So we have the core, which is basically Foreman itself, Foreman proxy. Plugins are built on top of that. They have a bit different life cycle, and that's why it's built on top. And Catalog built on top of that again, mostly again for historic reasons, I would say. But it's still done this way. And we also have a client tooling package package repository that we publish from it. Lifecycle wise, we branch every 3 months, so we do a bunch of procedures around that to make it easy, reproducible. For those of you attending Confirmation Camp on Monday, I'm doing a talk on that there. But that's more a different level. This is more technical on the packaging side of it. And like I mentioned earlier, we had Pulp Corp and Candlepin packaging as well. They're basically the same thing, except that they're a bit simpler. They have their own life cycles, but pretty much the same setup. Right, so what are some common actions? I think every packager knows these. You want to add a package, you want to update the package, remove it, build it, and you do release-related work like branching, etc. So how do we do that? Well, we have a bunch of tooling. We still have a bunch of local scripts, shell scripts that everyone starts with, and they got out of hand. So there's some packages, some scripts to add packages, some to do bumping, to release to a new version, to remove stuff. And then we also have OPEL, and it's an Ansible wrapper, and the Czech speakers here might recognize the joke. OPEL is the Czech word for wrapper. It was intended to replace all local scripts. Given that we still have the local scripts, you can see we're not quite there yet. But the whole idea behind it is you have an Ansible inventory, and every entry in the inventory is a package. So basically that gives you a way to easily do bulk actions. Basically you run Ansible on all of those. Basically you can say OPEL release, package name. But we also have groups, so you can basically say release everything in the Foreman group or the plugin group. And that's proven quite powerful, especially we also introduced tiers, because everyone here knows that when you bootstrap a new version, you have some build dependencies. So we introduced some tiers to say, well, this is basically the first build dependencies, and create those. So that's something that's proven quite useful. and you have Ansible variables because you have all the power of Ansible. So yeah, that's the tooling that we have. I already mentioned we still have a few local scripts. They're fairly simple on how you call them, but they very heavily rely on the gem to RPM, pip to RPM, and npm to RPM. We also have our own templates. So you have, for gem to RPM, we have the default template we have for any gem, but we have a specialized one for any Foreman plugin. So because they have more complex build steps, and this makes it quite easy to add new things as we go along. The bumping is also something we use quite heavily, which is actually the next topic. Adding robots. We automated version bumps, and I already saw the Packit talk earlier. We do a similar thing, maybe our own version of it, because we have a mono repository and Packit works on individual repositories. But I think this one really saves us a lot of time and effort. So it's implemented as a GitHub action. And the strategy is quite simple. It's basically for every updatable package you create, they run in parallel. So it does a checkout of the source code, does some setup steps, it does actual bumping, the bump rpm.sh script that we saw earlier, and then it creates a pull request. And that's basically what it does all the time. And this runs in a cron job. We run it twice a week. We don't run it too often because sometimes when it does a bump, it's not perfect. Something changed in the source package and you want to fix it up. If it runs all the time, it sort of overrides your local changes all the time, which is inconvenient. So that's why we run twice a week. But this saves a lot of effort. So what to update? That's the updatable part. We have a list of supported leaf packages. Basically, the Foreman plugins, you always want the latest version nightly. So whenever a new version is available, just put it in. We also have the gemfile.log. In the Ruby ecosystem, you have bundler, and it creates log files. And you can sort of inspect all the dependencies that it has, and it has pulled in. And we put all of those together and sort of figure out what do we need to update. And that's what we did with the buildable, updatable list. There's some conflict detection. For example, one gemfile.log might pull in a newer version than the other, and everyone knows how annoying those are, but we do some detection and we simply don't update it and sort of yell at you, I had a conflict. But yeah, that's generally speaking what we do. I would say it works quite well. But then we had the problem, we have multiple teams. Because like I mentioned earlier, we had the Foreman plugins, and we actually have multiple plugin maintainers, and every team can merge their own PRs. But how do you do that if you have one mono repository with multiple owners and you don't want to give them full access to everything? GitHub implements code owners, so you can say these files are owned by these teams. It pulls them in as a reviewer, and you can define rule sets to mandate reviews, so that they must approve of their building, or one of those owners must approve, and only then can you merge it. You can also do some additional steps like the Foreman packaging team, they can bypass checks and just do what's needed, but the individual plugin teams don't. So this is something we recently introduced, and together with the automation, it works very well because a PR is opened, they are automatically added as a reviewer, they get a notification and just need to merge. So that's the whole update cycle. It's a bit easier for them and no manual work involved anymore. So I see the timer wasn't started, so I'm not sure how I'm time. Okay. So reflecting, I think good. Standardized workflows, I really like them. Because we're a small team, it helps. The automation helps a lot. It saves a lot of effort and time. I think the templates make it easier as well, because spec files, there's still a bit of a thing you need to learn, and we have plugin maintainers, they don't want to be packagers, they just want to ship their code to users. These things help with that. The reviewing of the generate PRs, also very, very useful. It makes it so easy if you can just, in the morning you get up, you see a PR, you see CI already ran, you know it's good or bad. No more waiting, just approve it if it's green and merge it. Otherwise you fix it up. I like that a lot. But as I mentioned, the bad, I think packaging, it's still a specific knowledge set. When it breaks, it's not obvious to everyone what actually broke. I think that's where you very often still need people with more experience to help the individual plugin maintainers or newer people. Other things, runtime version of Ruby, Python, NPM. EL still has its own life cycle, which is complex. Also, we try to do updates. We support upgrades with leap from EL8 to EL9. You need to align some things, and for example, Postgres you can only upgrade from 13 on because EL9 only understands 13, so those kind of things. But overall, Ruby and Python is really the difficult one. And we've used SCLs and modularity, but in practice, I was never really that convinced with them. Very often it feels that when we use them, we were the first persons doing that thing with them, that we were exploring the solutions, and we figure out, then you talk to the maintainers and say, well, we've never tried this, and it was always painful. You always need to work around things, and that's why I'm happy that, for example, with Python in EL9 at least, you already have versioned packages that can be co-installable. It's way easier. I hope the other ecosystems do the same thing. And then the ugly. I mentioned there's a good thing in templates, but I also said it's ugly. Because I personally think that if you copy code all the time with templates, you're duplicating things, and you need to keep it in sync. And I don't like that. I don't like duplication. So I would like to see more solutions which are more generated. And RPM is doing some things of that. Like runtime requirements. You can generate them dynamically, already saves a lot of duplication. Build time dependencies. We don't use them yet because we were very late, we recently dropped EL8, and until then it didn't make a lot of sense. But I'm looking forward to use them as well to remove even more duplication. But maybe there's more we can do and push more into a system where you use something that's not duplicated all the time and centralized. Also ugly, we never completed the transition to OBOL. Would be nice to finish, but time is always limited. So we have some local scripts for, like I mentioned, the update Python package. We actually call that from bulk core packaging. It lives in formal packaging, and it's never nice, but the way we live. And the release cycles are still hard. CentOS Stream is still not the perfect upstream to RHEL. It's certainly a very nice thing, but very recently, for example, we had RHEL 9.5, where there was a Java update, where suddenly Keytool mandated the parameter. And that change didn't go through CentOS Stream. So when RHEL 9.5 came out, it broke on all versions. So that's, I like the concept of CentOS Stream. We just need to complete it. So there was some yelling at colleagues that they shouldn't do that anymore. But yeah. So in conclusion, automation is great, helps. Bots are nice. Maybe we should do more of those. I saw a few solutions here at the conference that I really like to try as well and make our lives easier. Templates, they help. And monorepositories, I think they help us a lot in doing easy bulk updates and making things a bit easier. Especially because we didn't mention before, but we change our Python version or Ruby version, and if you need to do that across all of the different repositories, that's quite hard. If you drop an OS version, it's quite hard. In monorepository, it's quite a bit easier. So for us, it's a great thing. And with that, I came to the questions. Yes?
Hi, this is really interesting. We have something kind of similar at work, but not using RPM. One question regarding, you mentioned you use, so basically it's mostly Ruby gems and Python and NPM for Node.js. For NPM, do you package individual modules, or do you basically vendor? Because in Fedora we gave up on.
And I completely understand why they gave up. I didn't want to spend half an hour ranting about NPM. Because I completely understand why Fedora gave up. It's we sort of came up with a solution where we bundle a lot of things, and I think it's sadly the only sane thing to do with how NPM ecosystem works, which is sad. But yeah, these days it's a web application, you can't really get around Node.js. Okay. Thank you. These are the URLs that we have, and I think I'm doing well on time. I had some more thoughts that I sort of backup slides if I went fast, because I usually do that. So I had some thoughts about where we can go in the future. Like, could you actually include repo closure in Copper itself? So it already does that and becomes more of a build service for you. Another thing is like the promotion pipelines. That's essentially what Copper could do. It's these days it's already backed by Pulp anyway, so it should have a lot of those options to create that snapshot, you test on it, and then promote it somewhere else. So maybe that's a great Copper feature as well. On the other hand, maybe we'll move to containers in the future. Who knows? And I saw a lot of Conflux talks. Maybe that's more of a direction we'll head into. But yeah, that's some things that I'm sort of thinking about. Other things, RPM autospec, that's not something we can probably use because you have this mono repository, and if you have this bump commit that's empty, are you going to release all your packages? What's going to be, I think that's going to, you can probably do something with for parsing the commit messages, but I don't think you really want to get in that. So for now, we always have the complete change logs in our spec files. But yeah, that's maybe also something to think about. The last is nightly packages. So we do this weird thing where we build packages. We don't update every single nightly package. We simply take the spec file, we change out the tarball, and we build those. And only when we get to the final releases, we actually build proper nightly proper packages. It always feels like a bit of a hack. We change some things like the release field, so we know which Git build it was, but I'm wondering if we could improve on there as well. But for now, it worked for a few years, and it helps a lot with some packages to have nightly, because developers want to see their changes quickly, and it helps. But the biggest downside is that you have this part of it that lives in Git and part of it doesn't. So if you do this for every single package that you have, like every single plugin, the whole bot to automate the package updates and then cherry pick those, that sort of breaks because you now have this, it shouldn't be tracked in Git. So that's still something I'm debating. And the last is build routes. We actually use RHEL build routes for compatibility, so we can actually deploy on also RHEL and Alma Linux, because as Linux policies have this weird thing where you include the version, but if CentOS Stream updates to a new policy, you can no longer install on RHEL. So that's why we use RHEL build routes. But that's also meaning that you don't completely take the benefit of testing on CentOS Stream. So do we actually need to build everything twice? So those are some thoughts that I've had, and I think they're open questions. If people have more answers, I'd be happy to hear them. But yeah, these were my bonus slides. And with that, thank you.
Thank you. That is the end. I'm going to open the door, and hopefully people will come in. They probably won't. If you'll all indulge me for just a minute, and I'll do a little closing session, and I'll tell you about the waffles. And people who don't come in here don't learn about waffles. Oh yeah, open those too. Yeah, thanks. Yeah. That's why I pay her. How long of a delay am I on myself here? So now you all get the live stream experience, you see. So I should have made a thank you slide. I didn't, so I'm just going to pull up the Connect website with the sponsors. These are randomized, by the way. Every time you refresh, there's a little bit of JavaScript. So I'll read in the order. I really want to thank our sponsors. I know I've done it like 3 times already, but Meta, Fedora, Alma Linux, Red Hat, and Rocky Linux, they really help us put on this event. And you guys don't know, like, I have like real logistical problems with taking sponsors, and they have put up with me. So I really appreciate that, and I want to thank them. I also want to thank Amy, who's right here, and Dorka, who is probably still sitting behind the registration desk. You've seen her. You've seen them working these last 2 days, but they've been like really helpful, really instrumental over the last few months of putting this together. There's so much work behind the scenes that happens. So thank you to Amy and Dorka. You all probably wouldn't come if there wasn't anybody to see speaking. So who are my speakers? Can you raise your hands? So thank you to all of these hands raised in the air and the humans attached to them. And finally, also, thanks to all of you, everybody who comes here. Speakers would be speaking to an empty room if you weren't here, and that would be boring. So thanks, all of you. This is the end of this, but apparently there's like another conference that happens for the next 2 days that you guys should totally check out. There is a distributions dev room that I'm going to plug. I'm one of the organizers of it. Benny is one of the organizers of it. I don't say Justin's not here anymore. Richard's not. Like, I think 4 of the 5 organizers were in this room at some point. But there's a lot of really good distro-related content if you're into, you know, distros. And our own Troy Dawson will be giving a presentation, so I will plug him. So check that out on Sunday. And then tonight... oh, that's the wrong slide. There we go. You made it. Congratulations. We will have a waffle party. This will be at 8:30. So this is not dinner. You have like 2.5 hours to go with your friends, go have a good dinner on your own, and then join us at Gaufre de Bruxelles at... Thank you. My French is non-existent. So here's the address. It's on the first floor, which is upstairs. For my fellow Americans, in Europe, the first floor is up 1 level, right? The ground floor is 0. You're all technical people. You should understand arrays indexing at 0. So just come in at about 8:30, go up to the first floor. We will be taking, so we will feed you a waffle and a drink. It's going to be one big order, so we're going to take the order for this at about 8:45, and we can hang out up there and order more stuff throughout the day, or throughout the night, but after our initial order, you're on your own. So you come in, you get a waffle, whatever toppings you want, get a beer, wine, coffee, soda, but if you're not there at 8:45, then you might not make it into the group order. But otherwise, you are welcome to just come and hang out and socialize. Should be a good time. So I think that's all of the information. Does anybody have any more? Okay, that's it. Then I will see you all at 8:30. Oh, please wear your badges. It helps us to know who's attending. You know, I want everybody is welcome to come. I don't want all of FOSDEM to crash it, you know, so, because that could be a little bit crazy. So wear your badges, helps us know, and it, you know, helps us know, like, your name and stuff. So was that it? Was that what you're going to tell me to say? Thank you. Okay, I will see you at 8:30 for waffles.
give my mum some time with my little daughter. She's 87, so how long? We're planning to return to the Czech Republic. I like it. If I had a free hand, I'd love to live in, I don't know, maybe Brussels for a year or two, Paris, Berlin, but they're all over the place. I think. There's a few European capitals I think would be fun to live in. I'm not sure Brussels is high on that list, but it's certainly good food, good drink. I don't know what the nightlife is like, but hell, I'm nearly 60.
I'm often curious what Brussels is like in the summer, because I've never seen it.
Yeah.
So that was what I said. We told me to install Recon originally, and I was like, look, this actually is not a good plan. One, especially this far, there's some folks from Microsoft who I want to engage with instead of joining. And two, my job is even more pronounced as this. And so effectively, we're going to the same city to vacation separately, if you will. Because I'll be working and you'll be vacationing. Now, it's not a good use of your future. Oh, and besides, it's not shitty.
Yeah.
So the summer comment, like, I'm like, yeah. The other is like, we're going to Amsterdam in February because Tony's going to go to a concert. Not to the concert.
What's the concert?
I don't know, some fucking singer, she EPEL or but, like, I'm going to have Stella. You should bring Anna. So anyway, we're going to be in Amsterdam for like 3 days. Well, I want to be in Brussels for 2.5 hours. Like, oh, you know, hey, let's go. So we've talked about my wife and kids. Kind of bring them here and so they can get the shot with themselves instead of me bringing them home. Yeah.
I took the girls to the Open Source Summit in Bilbao a couple of years ago, and that was overall that was a big success. The Linux Foundation treat journos pretty well. They flew us in. I didn't know this because I dragged Brian to one in Dublin about a decade ago, and you were in my ex-girlfriend's house. But
Streaming your
yeah, probably don't want to do that. But yeah, they fly us there. They put us in a nice hotel. So I said to the Linux Foundation, look, would you mind if I came a few days earlier, brought my partner and my kid? I'll pay for their air tickets and whatever the delta is between my hotel rate and the extra one. And they went, yeah, sure, no problem. We'll get the hotel to split the bill. We don't care when you fly. It's not going to make a significant cost difference. So we had about 3-4 days in Bilbao on our own first, and then I spent the days at the conference, and it worked out really well, and we had a good time. So, you know, it can work.
The LF apparently provides reasonably form child accommodations. I don't know any details. My understanding is they have like child care or other bits of plan to help attendees who need to travel.
I noticed, I think this year in Vienna, I noticed there were some kids playing in some of the back rooms here and there, but Ada is still a bit small.
Yeah, no, and I respect that. So you brought America with you?
Yeah, I was just thinking.
I have accidentally discovered the Technology Connections YouTube channel. Oh, I love that channel. Yeah, he's great. Like, I'm very impressed by it. But I love how he constantly refers to American power outlets as our weedy little power outlets. Because the standard has so many problems.
Whatever they want there. There are various memes about the facial expression of American power outlets, which are meaningless to those of us who've barely spent any time in America. So did you know